Very good evening. Vanakkam. Welcome. Suswagatam. Jo bole so nihal, sastrikal. Salam walaikum, salam assalam walaikum. Your Baba HSP. Our dear students. First of all, a warm welcome to all of you. Suswagatam. Greetings to each and everyone. Do let me know that everyone, can you hear me? Can you see me? Your Baba HSP is right now present over here. My dear students, let me check it out whether am I audible as well as visible to all of you all, my dear students. Today you can see number of slides. I will show you the periodic table, the periodic table, modern periodic table, the mnemonics. Okay, what Baba is going to tell you, Muhammad Safin, I can see that Baba is absolutely audible as well as visible. Okay, my dear students, okay. Now, the thing is that in the periodic table, no one is able to keep the periodic table in the brain, the hippocampus. So everyone, today, Baba is going to keep the whole periodic table in your brain. How's the Josh? Everyone, do let me know how's the Josh. Killer Science is there, DD is there now, my dear student, but Baba is going to tell you the modern periodic table with mnemonics. The first time I made mnemonics, the whole day and night I have prepared. Kids, these are the absolutely new mnemonics because in Hindi, I'm making mnemonics. The Baba is teaching for the last 24 years. In Hindi, a lot of mnemonics are there, but in English, this is the first time for the D and F block I made mnemonics, my dear students. It took too much time, but yes, I made it and I will show you. My dear students, second thing, super amazing tricks for SPDF, the electronic configuration. The exceptional electronic configuration of F block, lanthanoid, actinoids in D block, Baba is going to tell you, and not only going to tell you, Baba is going to keep each and everything in your brain. And the students, oh my God, Baba is again and again going to tell you, hey Vasim sir, pranam, pranam, pranam. Why the likes are so less, kids? Smash the like button. Baba, kids, this is not good. See, Baba will cry. Baba will start crying. Baba is teaching for the last 24 plus years. Produce number of ranks, top 10 plus mass selection, and you are not going to smash the like button. What is this, kids? No. I was full of Josh. I was telling you this and that, but my kids, what I'm seeing, likes are very less. Oh no, Baba will start crying, kids. Would you like to see your Baba crying for the likes? Yes, everyone is crying for the likes, for the views, but Baba will not say again that hit the like button, smash the like button. But yes, kids, I want to see your attendance, that regularity, the punctuality, and for that, you have to hit the like buttons, kids. Wow, yeah, I can see now, kids. Baba is teaching for the last 24 plus years, produced number of rank 1, 2, 3, and my dear friends, the government seat will be yours if you are able to understand this periodic table, because the periodic table is the base of physical chemistry, organic chemistry, and the whole redox and each and everything. Wow, that's really fantastic. Number of exceptions are there. Baba is going to tell you each and everything. But my dear friends, if you're new to this channel, yes, it's your duty to get such type of awesome things which holds a hell lot of weightage, you have to subscribe this channel. And yes, hit the like buttons. Yes, kids. Now, what I was telling you about this modern predictable, I will tell you modern predictable with mnemonics, SPDF, effective nuclear charge, that's Slaters rule. Each and everything I will tell you in detail about Slaters rule. And my dear students, let me tell you one thing. You must be thinking, sir, if you're going to tell us these many things, how much time will be required? Kids, see how many slides are there. See, let me show you the number of slides which I have taken 10 days to prepare these slides of mine, kids. Let me show you each and everything. Then I will start teaching. See the sample. See the sample, the exceptions, the mnemonics are there. See, the mnemonics are there. Let me show you, kids. I will tell you each and everything. I will cover this NCERT also. In the NCERT, see, the mnemonics tricks I will give you, kids. Now see, not only this much. The questions, see, such type of questions I will provide just to minimize the time. See, just to minimize the time. Have you ever seen the effective nuclear charge table? This will be yours. I'm going to tell you each and everything. So much homework Baba has done just to minimize your time. I'm not going to take this class so lengthy. I have done this much of homework just to reduce your time. Sometimes your battery is getting discharged. Sometimes your mobile is getting discharged. Sometimes you're feeling hungry. Someone is starving. I want to see, kids, just to minimize your time. I have done. Let me show you the homework Baba has done. See, the Hollywood and Bollywood movie tricks are also there. See, kids, this is, I'm going to tell you the tricks. Now, how many slides are there? How many slides Baba has prepared? See. Oh, see, kids, 145th, 46, 47, 150 slides. Jay, this lecture is going to give you benefit whether you belong to NEET, you are preparing for NEET, or you're preparing for J or J Advanced. This lecture is going to be super awesome because it holds a hell lot of weightage. This is going to be important for each and every one of you. But before I start, kids, everyone, this is your duty. Smash the like button. I want to see more likes, kids. Kids, now Avenger batch students are there. Conquer batch students are there. Let me go back to the schedule. I'm going to start from the first slide, but before that, I want to see more likes, kids. I want to see more and more likes. Hit the like buttons, everyone. Before I reach, now, let me go back, kids. Till that time, everyone, I want to see more likes. Everyone's attendance should be marked. Hey, my dear students. So Baba is back. Baba is back. Baba is back. Kids, Baba is back. Now, my dear students, is everyone ready? Now, is everyone ready? I want to see fire in the chat section. Is everyone ready, kids? Very good. Now, if you are with your pen and paper, I'm not saying that pen and paper is required. These are the notes, super awesome notes. I want to see green hearts. If you're ready, that I will see as the green signal in the chat section, kids. Show me the green hearts if everyone is ready. Yes, kids. If everyone is ready, show me the green hearts. Then I will think myself that yes, everyone is ready. I want to see the whole chat section should become green, kids. Fantastic, fantastic. Yeah, I'm happy. Abhivadanam for your energy, kids. I salute from the internal core of my heart, my dear students. This is Baba, and Baba is, yes, Baba's energy and Baba's success rate is directly proportional to your success rate. If Baba is going to tell you each and everything about the periodic table, and if it is going to benefit, then only you are going to get benefited, and then Baba's success is there. Yes. So kids, yes, I'm going to start. See, I'm going to start with the address of electron, address of an electron. It's just like we human beings. We are living one planet, and one planet, you know, around the sun there are a number of planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto is not there now. So if you want to understand the address of electron, you should know N, L, M. Now you will start thinking, so this is in physical chemistry quantum numbers. My dear students, this is the principal quantum number N. This is just giving the shell in which electron is revolving. And the value of L is dependent from N. That N is going 1, 2, 3, 4, 5, 6, 7, and so on. If this point is clear, this thing you know from the physical chemistry very well, my dear students. Now, if I talk about value of L, see, if I talk about the value of L, this is very, very important. 0, 1, 2, 3. That means it is S, P, D, F. Now, if I talk about how many boxes in S are there, see, one box, only one box. If I talk about P, how many boxes will be there? 3 boxes. 1, 2, 3. I'm not going to say -1, 0, +1, because right now I'm not interested in physical chemistry. I want to teach you about the periodic table. So if I talk about D, just see to it. D will be having, write down in the chat section how many boxes, how many orbitals D will be having. I want to see 5. Very good. It's very simple, but I want to see your answer in the chat section. It's 2, 3, 4, 5, 5. And if I talk about F, kids, write down in the chat section how many orbitals F subshell will be having. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay. So one box is just like the box of shoe or sandal. One box can contain maximum of 2 electrons. That means this will contain how many electrons? It can contain maximum 2. It can contain maximum 6. It can contain maximum 10. Am I right, kids? Am I making any sense? This point is very, very clear to all of you. This S can have maximum of 2 electrons. P can have maximum of 6. Can have maximum of 10. F can have maximum of 14 electrons. This is very, very small, very, very basic. If you are able to, very good. J students are there. I can see this is going to benefit you, kids. It is for each and everyone, because periodic table is the base. and that is for everyone. Now see, kids. See. Everyone along with me, see, in a week, how many days are there? Just to let me know. In a week, how many days are there? In a week, how many days are there? Kids, fast, fast, fast. In a week, how many days? 7 days. 1, 2, 3, 4, 5, 6, 7. Sunday morning. Everyone say along with me, wherever you are seated. You have to follow the rule. Along with me, you have to speak. Not only our brain, our body is also going to learn. Just remember those days when you are in KG. Wow, wow, black sheep, or twinkle, twinkle, little star. At that time, you were not having any knowledge of grammar. But your ma'am was saying just to repeat. Until now, you are having those memories in your brain. So this is the most important thing, kids. It is required that you have to speak loudly. Say everyone loudly, otherwise you won't be able to understand. Everyone, will you follow what I'm saying, kids? First of all, do let me know. Will you follow? Are you having trust in your Baba? Will you follow what Baba is saying? Otherwise, you won't be able to understand. Sunday morning. Sunday morning. 2 times sip. 2 times sip. Sip your tea or milk, whatever. Sip, sip. 2 times sip, sip. Then what you're supposed to do? Simple DP, SDP, simple DP, then once again simple DP, simple DP. Then after this, safe DP, safe DP, safe DP. It's Sunday morning, 2 times sip, sip, 2 times simple DP, and 2 times safe DP. Is this in your brain? Has it gone to your brain, everyone? Say everyone. Sunday morning, sip, sip, simple DP, safe DP, safe DP. Sunday morning, 2 times sip, 2 times simple DP, and 2 times safe DP. Right? Very good. Very good. If you are able to follow it, write down in the chat section also whatever you're speaking with your yes organs. Just write down in the chat section also. Sunday morning, sip, sip, simple DP, simple DP. Now, S can contain maximum of how many electrons? S can contain maximum of how many electrons? 2, 2, 6, 2, 6, 2, 10, 6, 2, 10, 6, 2, 14, 10, 6, 2, 14, 10, 6. You got it. Have got it, kids. Now, it's my humble request. Apply maths. Baba doesn't know maths. Baba is not having any knowledge of maths. Kids, help me. Help me. This will come out how much? Baba doesn't know maths. This will come out how much? 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 Come out how much? Out how much? Write down. Because Baba is not having knowledge of maths. 2, 8, 8, 18, 18, 32, 32. Is Baba right? Is Baba's maths is okay? Is it okay, kids? 2, 8, 8, 18, 18, 32, 32. Very good. Very good. Very good. Now see, these are magic numbers, kids. These are magic numbers. These are magic number, kids. Magic numbers. These are magic numbers. Magic numbers. How they are going to benefit you. These magic numbers. How they are going to play a role. Magic numbers. Now see, kids. With these magic numbers, you can find out atomic number of any element in the whole periodic table. An atomic number is like mobile number. If you know the atomic number of any element, you can find out its each and every chemical as well as physical property, because modern periodic table is based on atomic number. All the physical and chemical properties are the periodic functions of, yes, it is based on atomic numbers. Now see, kids, how this is going to help you. See, kids, if I write down helium, neon, argon, krypton, xenon, radon, everyone knows the atomic number of helium too. Now rest of the atomic numbers, if you don't know, you can form these atomic numbers. How, kids? How? 2 plus 8. 2 plus 8. Now 10 plus how much? 10 plus how much? 10 plus how much? 8. How much it will come out? How much? 18. Now 18 plus how much? See how I got it. How I got it. 18 plus 18. Magic number 18. Then 18. Then 32. Now if any element after this, its atomic number will be 86 plus 32. How much it will come out? 268. 8 through 11. 118. Right, kids? Is this much clear to all of you? Is this much clear to all of you? Is it making sense? Helium, neon, argon, krypton, xenon, radon. Say, everyone. Helium, neon, argon, krypton, xenon, radon. 2, 10, 18, 36, 54, 86. And this will help you. This is going to help you in lanthanoid and actinoids electronic configuration. We can find out electronic configuration over there. Now see, kids. Now see, everyone. See, what is this? S block. S block. Now, our target is to learn S block. How will you learn S block, kids? How will you learn S block? Yes, I'm going to tell you how to learn S block. See, kids, let me show you. This hydrogen is an exceptional case because it belongs to alkali metals as well as halogens. So everyone, for 1A group, Hidden, Lena knows Ruby seized in France. Hidden, Lena knows Ruby seized in France. Ruby seized in France. Ruby seized in France. Oh God. Ruby seized in France. Hidden, Lena knows Ruby seized in France. Clear to all of you? Clear to all of you, my dear students? Is it clear? Everyone? Everyone say, Hidden, Lena knows Ruby seized in France. My dear students, let me tell you one thing. Right now, 532 students are present over there. Out of these 532 students, 10 to 12 students must be like, they would know Or they must be thinking, I know very well the periodic table like this. See kids. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, 2A. Beryllium, magnesium, calcium, strontium, barium, radium. Now, P block. Boron, aluminium, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, helium, neon, argon, krypton, xenon, radon. Now D block. Scandium, yttrium, lanthanum, actinium, titanium, zirconium, hafnium, like this. But my dear students, rest of other students, 99% students, they are not having exact idea about the periodic table. If you are those 10 students, those who actually aware this periodic table, then no problem. But if you don't know, then let me know in the chat section that you want to know mnemonics in English for the whole periodic table. Then only Baba is going to give you. Otherwise, Baba will move towards shielding effect, jet effective. I want to know, I want to see in the periodic table. If you want, don't write you know, you don't know. If you want, then write down yes, I want. Then only Baba is going to, yes, is going to do that much of efforts, apply those many of efforts, my dear students. I want to see. Oh, it's very tough to read. It's very tough to read. You can make blue heart. You can blue heart or show fire in the chat section. Either blue heart or show fire in the chat section. Otherwise, it's very tough to read, kids. It's very tough to read. Either blue hearts or fire in the chat section. Very good. Okay. Okay. Now I got it. I got it. I got it. I got it, kids. I got it. Now see. Hidden Lena knows, Ruby sees in France, beryllium and magical Sir Baba radium. Beryllium and magical Sir Baba radium. See, Hidden Lena knows, Ruby sees in France. First, you have to see with your eyes, then revise 2-3 times, and then close your eyes. Just close your eyes and try to see it in the air. Hidden Lena knows, Ruby sees in France, beryllium and magical Sir Baba radium. Magical, see, magical. Magnesium, calcium, strontium, Sir Baba radium. Is it okay? Is it okay? Hidden Lena knows, Ruby sees in France, beryllium and magical Sir Baba radium. Now in Hindi, already I have given, है लीना की रब से फरियाद, बेटा मांगे कार स्कूटर बापरा जी. This is in Hindi. This is in Hindi. Already I have given. Now see kids. Now everyone, what is this? See, what is this? D block. So D block is really very tough, and number of questions they are going to come from the D block. Is everyone ready for the D block? Now see, D block. I have divided this D block in 3 parts. See, in 3 parts. First part, 3, 4, then 5, 6, 7, then 8, 9, 10, and then 11, 12. Are you able to understand? I have divided the whole D block. D block is very big, huge, like an elephant. So if you can't divide in different parts, you won't be able to do questions. You won't be able to see with the clarity. Now see kids. Sky lace. Everyone say sky lace and sky lace are in Tizori, and Tizori is half of roof. You know, like in Dubai, Burj Khalifa, building is, you know, the height is too much. So we are going to eat lace, you know, lace, They are actually LAYS, but here lays. The lays are in the sky because they are at too much height. Sky lays in Tizori. Tizori, you know, where we used to keep money. Everyone is keeping money in the Tizori. Now see, sky lays in Tizori, and Tizori is half of roof. Trick is sky laces are in Tizori, that is half on roof. Got it? Is it helping, kids? Is it helping? See, these are absolutely new mnemonics, kids. See, sky laces are in Tizori, that is half on roof. Sky laces are in Tizori, that is half on roof. Now, my dear student, you will get number of mnemonics, but in my mnemonic, no extra material is there. Just the symbol is there. Kids, see, only the symbols are there. Sky, SCY, sky, lace, LAC, lace, sky lace. Sky laces are in Tizori. See, Tizori. Nothing extra, nothing extra, nothing is there. Just symbols are there. See, kids. Sky laces are in Tizori, that is half on roof. Done? Is it? Just repeat it. Everyone. Everyone. This Bhupender Jogi is really my good. Kids, first of all, do let me know. You see my mnemonics. Have you seen my mnemonics, kids? In my mnemonics, nothing extra thing is there. Just the element and symbol is there. Now see, kids. Here, this is about Nobita. Have you seen the serial of Nobita? Have you seen Doraemon? Doraemon, then you must remember Nobita. Now, Nobita is having the habit of always getting victory. So see, everyone, this is right now Dubai. I was telling you about the Burj Khalifa, Dubai. So everyone is celebrating the victory of Nobita. Nobita, see, NBTA, Nobita in Dubai. Everyone is celebrating the victory of Nobita in Dubai. See, it is written over here. Trick. Let's celebrate victory of Nobita in Dubai. Kids, the one kid is there. I am unable to see others' reaction, kids. This is Bhupender Jogi. Jogi, Jogi, Jogi. Hey Baba, please Bhupender, let others to concentrate. I cannot see their views, their reaction, kids. Bhupender, please. It's my humble request, Bhupender, please. Bhupender Jogi, please. This is Baba. Baba is a very simple person, Bhupender. Baba can't tolerate you're this much of spamming. Bhupender, please. For God's sake, don't do that. Okay. Come back, everyone. Is this clear? Let's celebrate the victory of Nobita in Dubai. Victory of Nobita in Dubai. Now, what Nobita has done. See what Nobita has done over there. Because Nobita created crazy molybdenum, chromium, molybdenum, tungsten, siaborgium. This Nobita created mole on the tongue. This W is tongue. Nobita created crazy mole on the tongue of singer. This Nobita created crazy mole on the tongue of singer. Because Nobita created crazy mole on the tongue of singer. See, crazy mole on the tongue of singer. You can do also one thing. You can take your copy. If you're not able to see this handwriting, if you're not liking this handwriting, and if this handwriting is clear to all of you, visible to all of you, you can easily understand, then no need to write, just speak it out. It's crazy mole on the tongue of singer. Now the singer man has touched reborn heights. This singer man touched reborn heights. Now this man is touching reborn heights. Kids, I cannot see properly. Is it helping? Are you able to? This is going to help, kids. You have to repeat it 2 to 3 times, kids. I've done lot of efforts. The whole day and night I've given to these mnemonics, kids. See, nothing extra is there. Once it will require, the beginning is always tough. The beginning is always tough. But once I'm in it, I become unstoppable. It will look tough, kids. But once the periodic table is in your brain, you can change the world. Kids, in the starting, it will look tough. But say to yourself, the beginning is always tough. But once I'm in it, I become unstoppable. Now see, everyone repeat. Let's celebrate victory of Nobita in Dubai. Victory of Nobita in Dubai. Crazy mole on the tongue of singer. Man is touching reborn heights. Man is touching reborn heights. Clear? Clear, kids? I want to see. Thank you, Jyoti. Thank you, kids. I have created something. I was waiting for this lecture. Just like people are waiting for Onam, Pongal, Diwali, Holi. I was waiting for this lecture and I was giving my best. And how much it is going to help you, kids. You have to show your gratitude over there. Then only Baba can understand what Baba is going to give you, kids. Thank you, thank you, thank you, thank you, thank you, kids. Thank you. Now, so victory of Nobita in Dubai. Everyone see? Victory of Nobita in Dubai. Crazy mole on the tongue of singer. Man is touching reborn heights. Man is touching reborn heights. Now see. This is another story. That story completed. 2 stories completed. Now we are going towards the third story. Are you ready? Are you ready for the third story? And kids, let me tell you, no one can say that you have seen these mnemonics, because this is the first time Baba has done those many efforts. This is the first time you are going to see these mnemonics. Now, third story. Everyone ready? Is everyone ready for the third story? The story is all about that nowadays everyone is enjoying pizza, burger. We are not giving that much of importance to chapati, rajma rice, dosa idli, rasgulla. Am I right, kids? So see, dosa, if you belong to any place where the dosa is prepared, that is on, yes, wooden, copper or iron base. What is the base on which dosa is prepared? Do let me know. What is that? The heating apparatus made up of? The heating apparatus is made up of iron. Now see, iron. Iron is known as ferrum. Ferrum is having awesome history. By ferrum iron, our blood is having hemoglobin. And hemoglobin, the main source is iron that is going to bind oxygen. So iron is having awesome history. See, ferrum is having awesome history. Ferrum has awesome history. Say everyone, ferrum has awesome history. Ferrum has awesome history. Now, this is cobalt and this is rhodium. Cobalt and rhodium are irregular to market. Cobalt and rhodium were going to the market just to have pizza. Always they were eating pizza. Their mother was saying, Cobalt and Rhodium's mother was always asking, hey, you can have dosa, chapati, but they were always going to the market. But what happened to these two kids, Cobalt and Rhodium? Now they are not going to the market. They are irregular to the market. What they have seen? See, Param is having awesome history. Cobalt and Rhodium are irregular to the market because Cobalt and Rhodium are irregular to the market because they have seen nickel and Pandu, because they have seen nickel and Pandu having potato dosa. Nickel and Pandu are having potato dosa. They have seen because nickel and Pandu are the topper of the class. Nickel and Pandu are the topper of the class, and Cobalt and Rhodium, they have seen that they are enjoying potato dosa. So now they are not going to the market. See the story, kids. Param is having awesome history. Cobalt and Rhodium are irregular to the market. Nickel and Nikki and Pandu are celebrating potato dosa. Kids, these are exactly awesome mnemonics. I hope that they are helping you, kids. Nickel and Pandu are celebrating potato dosa. So everyone say, Param is having awesome history. Say everyone, repeat. Param is having awesome history. Cobalt and Rhodium are irregular to the market because they have seen Nickel and Pandu enjoying potato dosa. Everyone, see everyone. Param, everyone say, Param is having awesome history. Param is having awesome history. Param is having awesome history. And Cobalt and Rhodium are irregular to the market because they have seen Nickel and Pandu are enjoying potato dosa. Thank you. Now I can see, kids. Now I can see you are really liking it, kids. Wow. My dear students, now I can see your chat section is showing me, kids. Really, now I am feeling happy. Baba is really now feeling happy, kids. Wow. Now, my dear students, let me have a glass of water, kids. Let me have a glass of water, kids. Really, you made my day, kids. You made my day. Baba was thinking that my hard work, how much you are going to like, kids. But really, you're liking the whole 10 days and nights I have given to these things, because number of mnemonics are available in Hindi, but in English, mnemonics were not available, my dear students. For the last 24 years, I also made mnemonics in Hindi only. This is the first time I've given my whole time to prepare mnemonics in English, kids. These mnemonics in the whole world you will never see. After this lecture, everyone is going to copy these mnemonics, kids. After this lecture, you will see in the market these mnemonics will get copied. You will see after 2 to 3 days, you will see number of short videos. Everyone is going to copy these mnemonics because these are golden mnemonics without extra words. Each and every word is on symbol only, kids. Now see, kids. Now see. This is left, and this everyone knows. So I have not made any code for this. Copper, silver, gold, and Rg. Copper, silver, gold, Rg. Ginny is having Canadian hex. Ginny is having Canadian hex. Ginny thanked, just wait for a second. copper, silver, gold, and Rg. This is a new element. I will let you know. And after that, zinc, cadmium, mercury. Zinc, cadmium, mercury. Zinc, cadmium, mercury. Zinni is having Canadian hugs, but remember that these are not transition elements. Why? They are not transition elements. It's clearly written in your NCERT. Why these are not transition elements, my dear friends? Transition elements have metallic properties. They have unpaired electrons. They are having very high melting point, just like tungsten. But they are not having any unpaired electron. Their configuration is filled, all filled orbitals, no unpaired electrons. And that's why they are very soft. And that's why they are very soft. And that's why soft. You can cut with a knife. Mercury is liquid at room temperature. Mercury is liquid at room temperature. If I say how many elements are liquid at room temperature, then one is, yes, mercury, the metal, and one is bromine, the non-metal. These are liquid at room temperature. But if I talk about at 33 degrees Celsius, at 33 degrees Celsius, how many elements are liquid? EABR. Gabbar is hugging bro. Gabbar is hugging bro and got seized. Gabbar is hugging bro and got seized. This is the trick. Gabbar is hugging bro and got seized. Gabbar hugged bro and got seized. Now see, my dear friends. Everyone, just see 1, 2, 3. What I have done. This is a quick revision. Everyone, say here for these elements which trick I have told you. Just everyone say sky laces in Tizori half of roof. Sky laces in Tizori half of roof. See where I have shown you. This sky laces in Tizori half of roof. Now what you will say over here? Victory. Yes, victory of Nobita. Everyone say victory of Nobita. If you can remember this, just do your revision. Victory of, this is the blank, this I have left for you kids. Otherwise you won't be able to remember. If you're not right now, if you're not able to learn, you won't be able to remember. Victory of Nobita in Dubai. Crazy mole on the tongue of singer. And man is touching reborn heights. Man is touching reborn heights. Victory of Nobita in Dubai. Crazy mole on the tongue of singer. Man is touching reborn heights. Now this one, say this one, this 8, 9, 10. 8, 9, 10. Yes, if you are able to remember, otherwise no one can help you. Kids, this is for you. This one. Ferrum is having, Ferrum is having awesome history. Very good. Ferrum is having awesome history. Cobalt and rhodium irregular to the market because they have seen nickel and Pandu having potato dosa. Nickel and Pandu having potato dosa. Wow, everyone. Very good. Very good. This is the revision. See, kids, how to revise, how much proper efforts I have applied. I'm keeping each and everything in my mind to do the revision also. See kids, Baba is not only teaching, Baba is, yes, doing your revision also. Now see kids, see, sky laces are in Tizori half roof. Sky laces, you can make a song. Sky laces are in Tizori half roof. Sky laces in Tizori half roof. Let's celebrate victory of Novita in Dubai. Crazy mole on the tongue of single man is touching newborn heights. Man is touching newborn heights. Sky laces are in Tizori half. Victory of Novita in Dubai. On the tongue of single man is touching newborn heights. Ferrum has having awesome history. Cobalt and rhodium irregular to the market. Nickel and palladium are having the potato dosa. Potato dosa. Whenever you want to sing a song, you can keep it in your brain. The sky is in Tizori half. The sky is in Tizori half. That is on the roof. That is on the roof. Hey, that is on the roof. That is on the roof. Let's celebrate the victory of Novita in Dubai. Let's celebrate victory of Novita in Dubai. Crazy mole. Hey, hey, crazy mole. Hey, hey, crazy mole on the tongue of singer. Now man is touching reborn heights. Now man is touching reborn heights. Ferrum has awesome history. Hey, Ferrum is, no, that's like Santa Baba on 25th of December. Ferrum has awesome history. Cobalt and rhodium irregular to the market. Now nickel and palladium are enjoying potato dosa. Enjoying potato dosa. Now see kids. This is whole D block. This is whole D block. You can see. Now, if I come to the D block, first of all, I have to tell you how to write down the electronic configuration. Then only I can teach how many elements they are having exceptional electronic configuration. See, this is the key. Can you see the key? This you can say either key or you can say pistol. It's looking like pistol. Either you can say this is the key or you can say pistol. These are having exceptional configuration, but how to write down the electronic configuration if you don't know, then how to tell you how and why and which elements they are having exceptional configuration. So I'm going to tell you, I'm going to teach the how to write electronic configuration first, how to write down the electronic configuration. Tickets. I'm going to tell you the Aufbau principle. Aufbau principle, you know. Have you heard about Aufbau principle? 1s, 2s, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p. Tick, tick, tick. Double cross 3D, 4D, 5D, 6D, 7D. Look, chat. 4F, 5F, 6F, 7F. This you know from the atomic structure. Why the D is getting started from 3? Why F is starting from 4? My dear students, can you see everything? Is it clear? The board is clear, kids? Is the board clear? Can you see the board? Everyone, can you see the board? Now see what I'm going to do. We have to come from the top to bottom. In your childhood, you must have played that game. Yes? Slider 1, slider 1. See, we have to come down like this. Then go up, then come down. Then go up, then come down. Are you getting my point, kids? Everyone, can you see? Like this. Then go up, then come down. From top to bottom, you have to come from top to bottom. Just see. Everyone, you have to come from top to bottom. Now see, when you are doing this, what type of subshell and orbitals will come in your way? Now see, kids, 1s, just see to it. Let me make it small. Just wait. Let me make it small. Now see, first what is coming? 1s. Aufbau principle. Aufbau principle. Aufbau principle. Is there anyone who is going to tell me Aufbau was the scientist of which country? Aufbau was the scientist of which country? Sweden, Norway, Germany. Do let me know. Aufbau scientist belongs to which country? Germany? Not a scientist. Very good. See, kids, 90% students are writing Germany. Kids, remember that Aufbau means to build up. To build up. Aufbau is not scientist. Aufbau is not scientist. 90% people got failed. Aufbau means that the filling of the electrons will take place in the increasing order of energy level, starting from the lowest energy level. Hey, everyone, can you hear? Aufbau principle states that filling of the electrons will take place in the increasing order of energy level, starting from the lowest energy level. Everyone, what Aufbau principle says? Principle states that filling of the electrons will take place in the increasing order of energy level, starting from the lowest energy. Now, this is the meaning of Aufbau principle. Now, if you can see, then we can write down, see, 1s, then 2s, then 2p, then 3s. Let me write down, otherwise you won't be able to understand, my dear friends. See to it. Now see to it what's coming. I'm writing in the order of increasing energy levels. See kids, starting from the lowest energy level. Everyone help me please. First, what should I write? 1s, then 2s, then yes 2p, then after 2p 3s, then after 3s what I'm supposed to write kids? Write down in the chat section, do let me know. After 3s what I'm supposed to write? 3p. Then after 3p 4s. Now after 4s I have to write down 3d. Then after 3d I will write down 4p, etc. Everyone is able to understand? Do let me know in the chat section. Is everyone getting it, my dear friends? Is everyone getting it, kids? This is very important. If you don't know how to fill electrons, this can contain maximum of 2 electrons, maximum of 6 electrons, 2 electrons, maximum of 6 electrons, 2 electrons, 10 electrons, 6 electrons, etc. If you don't know how to fill the electrons, you won't be able to understand the periodic table. First of all, do let me know. One more thing is there, my dear friend. After 7s, what to write? Okay. A Naveen is writing after 7s. How many of you don't want to, or you want to know another rule also? See kids, how many of you are interested in knowing other trick or basic fundamental how to write down the electronic configuration? See, there is Bohrs-Bari's rule. Have you heard this name? Bohrs-Bari's rule. What is that? Bohrs-Bari's rule. Bohrs-Bari's rule says this. I have to tell you a little bit of physical chemistry. N plus L is lowest will be filled first. If lowest will be filled first, Now by chance, if N plus L is coming same, by chance, if N plus L is coming same, if N plus L is coming, this is not 1, this is L, not 1, right? This is L, this is L, N plus L. If N plus L is same, then if whose N is lower, whose N is smaller will be filled first, Now kids, according to this, you can fill. Now see, let's see. Let me find out for 4s and 3d. You can find out for anything. Let's find out for 4s and 3d. 4s and 3d. (4s and 3d). 4s and 3d. Just see to it, everyone, which is going to be filled first. N plus L. Just you have to keep one thing in your brain. L 0, 1, 2, 3, 4. This is S, P, D, F, E, etc. Now see, 4. The value of N is 4. N plus L, S is 0. 4 plus 0 is 4. Now 3, N is 3. D, where is D? D, L value for D is 2, 5, which is less. The N plus rule says, Bohrs-Bari's rule says, this is lowest, so this will be filled first. That's why its energy level is less. Is it clear to all of you, my dear students? Is it clear to all of you, my dear students? Now let's compare for anything else. Let's compare for 3D and 4P. 3D and 4P. Let's see 3D and 4P. 3D and 4P. 3D and 4P. Which to be filled first? N plus L rule. N plus L rule says 3D. 3D means the value of L is D. D means the value of L is 2. 2. 3 plus 2, 5. Now 4 for P. For P, the value of L is 1. The value of L is 1. 5. See, 5 and 5 both are same. Now N plus rule is coming same. That means who is going to fill first? Who is going to fill first? The one whose value of N is less, it will be filled first. Everyone. Now in this way, if you know the quantum numbers, you can find out. Is it clear to all of you? Is it clear to all of you, my dear students? Any doubt? Is it clear? Show me the thumbs up if it is clear. Low value of N is preferred. Low value of N. Low value of N will be preferred. Will be filled first. If this point is clear to all of you, do let me know. Is it clear? Very good. Very good. Now that's fantastic. That's fantastic. Now, if I ask, what should be the electronic configuration of iron whose atomic number is 26? Now, how to do it? See kids, everyone, 26 atomic number. 1s2, 2s2, 2p6, 3s2, 3p6. Now, after 3p6, 4s2. How much? 2 to 4, 6, 10 to 12, 6, 18 to 20, and 6. That means 3d6. Right, kids? Is it clear to all of you? First of all, do let me know. Then I will tell you the most frequently asked question. Even the students, they are just thinking, they are not asking to any teacher that question. That I will let you know. If this is clear to all of you, then I will tell you what is that question. That is the most frequently question coming to brain, but no one is going to ask to anyone. See kids, the question arises, if the configuration is like this, then why we are going to write like this? See kids, this configuration you can also write 2 to 4, 6, 10 to 12, 6, 18. Whose atomic number was 18? Which noble gas configuration was 18, kids? Do let me know. Which noble gas configuration was 18? Helium, neon, argon, krypton, xenon, radon. See, this is 18. So we can write for iron 26, we can write this is argon. That means value is how much? Argon's value is how much? 18. And then I can write 18 plus what? 18 plus, I will write 4s2, 3d6. 18 plus 2, 20 and 26. Is it clear? 26. But you must have seen it's written like this. Which one you have seen, kids? Do let me know. 3d6, 4s2. The first one or the second one? The first one you have seen, or the second one, or both? Just do let me know. You must have studied in your school. must have studied in your coaching, wherever you have studied your class 11th, you must have seen. Now, my dear students, second one, okay. Now, see, my dear students, both are correct. While filling, you have to write like this. While filling, you have to write like this. And when you are supposed to take out, eliminate, while eliminating out electron, we have to write like this. Now the $1 million question arises. Why is like this? Is this your question? Why we are doing like this? How many of you must be thinking such type of questions? How many of you are having this question, this doubt? Do let me know. While eliminating out electron, we have to write like this. While filling, we are doing like this. How many of you are having this burning question in your brain? Now kids, let me explain. If I say, who made this iron? Who made this iron atom? This iron, who made this iron atom? The God or the human beings? God or human beings? Who made this iron atom? Just do let me know. Who made iron? Who made iron? God or human beings? You will get each and every question. All the doubts will get cleared. God, nature, God made this. Now, what do you think? This is already existing, or we are going to fill the electrons? Electrons are already filled, or we are going to fill electron? Who are we? We are nothing. Electrons have already been filled. In iron, electrons are already existing. They are already present, means present, already filled electrons, are existing. No one is going to fill the electrons. Wherever they are located, they will be like this. Already they are filled. That means, if I say this is iron, this is iron's nucleus, protons 26. The first orbit, the second orbit, the third orbit, and the fourth orbit. Now, that means, what do you think? What God is going to say? While filling, the electrons will be like this, and while eliminating, the electrons will be like this, or always the electrons are in the same way. The electrons are already in the same way, like 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, and 4s2. It's like this. This is the scene. But kids, we cannot go inside the iron or the atom. That's why we have opted that technique, how the Aufbau principle is going to work, because we cannot get entry inside the atom, and that's why we are going to follow Aufbau principle. Are you able to understand? Everyone is able to understand, because we cannot find out why the D is having only 6 when it can hold 10 electrons, and then why it is like this. That's why scientist has given rule. Otherwise, this is the actual iron. This is the actual condition of iron. Kids, everyone is able to understand this concept, that iron is like this only, or the atoms are already, they are existing like this only. Now see kids, once the electronic configuration is clear, then I want to tell you why I have started this. Let me tell you, my dear students, All these are D block elements. Now, if I take the first series, that is fourth period, hydrogen, lithium, sodium, potassium. This is first, second, third, fourth. And now, if I move towards this D block, how the filling will take place. D block's electronic configuration is, first of all, let me tell you like this: NS1, NS2, NS1, NS2 like this, potassium, rubidium, cesium, and francium, 5, 6, 7. Now, beryllium, magnesium, calcium, strontium, barium, radium. Suppose if you want to write the electronic configuration of calcium, directly you can write how? Calcium, the 18 that side, helium, neon, argon, 18 plus 19 and 20, that means 4s2, 4p, 0. Only 4s2 I can write. Can you see? If I want to write magnesium, 3s2. If I want to write sodium, 3s1. If I want to write potassium, 4s1. Is this clear? First of all, the S block is clear. If S block is clear, then I will come to this n-1d, ns. What should I write over here? Do let me know, kids. n-1d means 1 less than the principal quantum number. What should I write? Please repeat. Okay, wait. Let me repeat this one. First of all, let me repeat this one. Don't worry, kids, don't worry. See, kids, see. The S block configuration, S block, okay? 1, 2, 3, 4, 5, 6, 7. Now, hidden Lena knows that we know hydrogen, leave this hydrogen. Hidden Lena knows Ruby, C's in France. Do let me know which configuration should I write down, because it will have NS1 and this one will be having NS2, like beryllium, magnesium, calcium, strontium, barium, radium. Now, lithium is atomic number is 3, sodium is 11, this is 19. Now, do let me know whose electronic configuration you want to be write down. Do let me know, kids, whose electronic configuration you want. Without following Aufbau principle, I will tell you how to write down the electronic configuration. Now, see, potassium, okay? This is potassium. I don't know. Suppose I don't know the atomic number of potassium. Then also I can write down the electronic configuration. See, where is potassium? The value of N is 4. That means 4 is the principal quantum number. This 4 is being the principal quantum number because I know the periodic table. Either you know the atomic number, you can write down the electronic configuration very accurate. Or if you know the periodic table where the element is located, then also equally in good condition you can write down the electronic configuration. So see, kids, 4 and the block is S, NS1, 4S1, that's it. And before this potassium, who was coming? See, helium, neon, argon, krypton, xenon, radon. This was in first, second, third, fourth period, fifth period, sixth period, and their atomic numbers we have written with the help of magic numbers. Do you remember, kids? These atomic numbers we have written with the help of magic numbers. Now, this is in third. Third is ending with 18 and then 14, this fourth will start. That means whatever is going to be 18 plus 18 plus 1, 18 plus 2. Are you getting my point? Now if you want to write for calcium, what you will write? 18, this potassium we have written like this, 4s1. Argon, argon is 18 and then 19. Now if you want to write for calcium, either you know atomic number, if you don't know atomic number, then also argon. Now the NS2, what is the value of N? The period is fourth period, NS2, that means 4s2. Is it clear, kids? Is it clear? Are you able to understand? I haven't followed Aufbau principle. I have written directly because I know the periodic table. My teacher has told me. My teacher taught me the mnemonic for the periodic table. I can write directly. Or if you don't know this, then what kids will do? See, kids, what they will do? Calcium. Oh, 20 atomic number. Aufbau principle. Let's make that ladder 1s2. So he will write like this: 1s2, 2s2, 2p6, 3s2, 20, 2, 2, 4, 6, 4, 5, 6, 7, like that, 6, 2, 8, 2, 10, then 12, then 3p6, 18, 18, then Aufbau principle, what will come? 4s2, 2 to 4, 6, 10, 2, 12, 6, 18, 20. This kid has also written, but he has taken too much time. Are you getting my point, kids? This kid is writing like this. He has to follow Aufbau principle. He has to draw the diagram. Then you have to do this. Number of chances of errors are there. But if you know where this calcium is located, see, like a perfect person, see, like the kids of HSPN family, see kids, HSPN family. Oh, examiner is asking calcium. Where is calcium? Beryllium and magical sir, Baba radium. Sir has told me it's not here, it was here. Beryllium and magical sir, Baba radium. Now sir has told us that here it was hidden Lena knows, hidden Lena knows. I'm taking precaution. Hidden Lena knows Ruby sees in France, and this sir has told us that this is the first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Now they are asking for this, so it will be NS2. What is the N? 4. So 4s2. That's it. That's it. This is the outermost electronic configuration. Now, kids, you must be having one more thing in your brain: how to find out group and period. I will come to that titanium. I will come to that titanium. So see how to find out group and period. How to find out group and period. Group and period. Now see, kids, if somebody has given you this configuration, we don't know which element, XYZ element. Now see, whatever is written over here, this is its period. This is indicating its period. And just see these electrons are indicating its group. So second group, fourth period. Can you see? Second group, fourth period. Can you see, kids? Can you see? Can you see outermost valence electron? Outermost valence electron. Outermost valence electron. Now see, kids. Let me show you. Let me show you the magic. Let me show you the magic. Now suppose if somebody has given you like this, 3s2, 3p6. Now which element is this? Its group, its period, and the name of the element. Name of element. Name of element. Should I tell you all three questions answer, or you are going to tell me? Will you tell me? Yeah, I will send the PDF. Don't worry, I will share each and everything. But first of all, do let me know. Do let me know. 3s2 3p6. What do you think? Magnesium, calcium, no kids, no. See, the last electron is filled in. Last electron is filled in what? Last electron is filled in P. So this means this element belongs to P block. This indicates element belongs to P block. Am I making sense, kids? Do let me know. Am I making sense? Am I making sense? 16th group third period. Aparna is writing 16th group third period. Let's see, kids. Let's see. 3, this 3 is indicating n value is 3. That means third period. Third period. Now sum of S and P is 3s and 3p. Sum of electron 2 plus 6 is how much? 8. That means it belongs to 0 group. 0 group. 0 group. Now see, kids, 0 group, noble gas. It is name of element. I'm going to tell you noble gas configuration. Now see, 3s2 3p6. If I follow Aufbau principle, if you want to follow, you can follow. Otherwise, we can directly write down. See, helium, neon, argon, krypton. Now if I write down, this is the exceptional case. Its filling is 1s2, but then also it is in P block, exceptional case, but it should be 2s2 2p6 3s2 3p6. So argon is the element. This is argon. See, kids, and name of element is argon. Period is third. Group is 0 group or 18th group, noble gas configuration. How many of you got it? Do let me know, kids. Everyone, do let me know, kids. If this fundamental thing is clear to all of you, do let me know. Otherwise, I will let you know once again. I will explain it again. Kids, everyone, do let me know if this is clear to each and everyone, and I can cross check it. See, I can make it more clear. See, kids, how? See, if I take argon, let's move in the reverse direction. Helium, neon, argon, krypton, xenon, radon, 2, 10, 18. If I go in the reverse direction, see, argon's atomic number is 18. Now let's follow Aufbau principle. Aufbau principle. Now see what it is going to come. For 18, write down 1s2, 2s2, 2p6, 3s2, 3p6. How much it is coming? 2 to 4, 6, 10 to 12 and 18. See, it's getting matched or not. This is the cross check. I've done the cross check. Now how to find out anything? If the atomic number is given, you can find out the group and period. If the outermost configuration is given, then also you can find out the atomic number as well as the group and period. Is it clear? Then I will move. Then, okay, you want another example. How to find out the group? Okay, okay. Why we are adding 2 and 6? See, the outermost shell is, outermost shell. See, we have to see the outermost valence shell. How many electrons are present? How many electrons? That's why we have added 2 and 6, because they both are in third orbit. They are in electrons in the third shell. Third shell. This point is clear. First of all, do let me know, is this point clear to all of you? Is this point clear to all of you now? Is this clear? Now see kids, I'm going to give you another question. See, another question. Everyone ready? Is everyone ready? Question is, find out group period and name of an element. Now what is given? Given thing is, given is atomic number. Z is the atomic number is 15. 15 is the atomic number. Let's see who is going to find it out first. Yes, everyone, fast. Let's see kids. Just find it out. Atomic number, the value Z is given 15. Yes. Then I will go to the D block elements, kids. Then I will move towards D block element. Phosphorus, Geeta, yes. Chaitanya, very good. Wow, that's really awesome. Now see, if atomic number is 15 is given, kids, see, 15, that means Aufbau principle we can apply Aufbau principle. That is 1s2, 2s2, 2p6, 3s2. Now see, 2, 2, 4, 6, 10, 2, 12. Now 12, 12 and 15. One thing is clear, kids. First of all, everyone do let me know, is this thing clear to each and everyone? This is the electronic configuration. In this way we will write down electronic configuration. If this point clear to all of you. Now see, we have to select this one. This is the outermost electronic configuration, outermost electronic valence shell. Now just add these, everyone, you have to add these and do let me know what you get. 2 plus 3, 2 plus 3, 2 plus 3 is coming out how much, kids? 2 plus 3 is coming out how much, kids? Do let me know. 2 plus 3 is coming out 5. Third period, this is indicating 3 is indicating period. So third period and fifth group. Now third period and fifth group. How to find out which element is it? How to find out which element? See kids. Now to find out which element, we should know P block elements. Let me show you the P block elements. Let's make P block elements, otherwise you won't be able to understand, kids. See, you should know the P block elements. If you are having the data in your brain, you can do it. See, the P block elements. How many P will be there? P1, P1, P2, P3, P4, P5, P6. So how many groups will be there in P? How many groups will be there in P? How many groups will be there in P? 6. 6, because P can hold how many electrons? I've told you this thing, that P can hold how many electrons? P can hold 6 electrons. P can hold 6 electrons. So I have to divide it in 6 parts. I hope this point is clear to all of you like this. 1, 2, 3, 4, 5 and 6. Now see, let me write down third, fourth, fifth, sixth, seventh, 0 group. Now see, cross, cross, cross. Why I'm writing cross? Because there is nothing in this 1, 2, 3, 4th period, 5th period, 6th period, 7th period. Now I will write boron, aluminium, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, and helium also exceptional case. So leave helium. Start from neon, argon, krypton, xenon, radon. This is P block. Is it clear to all of you, my dear students? Can you see? Can you see everyone? These are the periods. We are going like this. If we are moving like this, these are the periods. These are being the periods. These are the periods. And they are the groups. Now see kids, if I want to write down the electronic configuration for this, now see everyone how to write it down. See kids, for this, what I will write for this is the second period. So leap period, just write down. Actually, the configuration is NS2 NP 126 126. For P block elements, this is the general electronic configuration NS2 NP126. Just keep it in your brain. NS2 NP126. Now see kids, this is third group, but this is indicating period, so leave it. Any element which is present over here, we are getting from S. S was fully filled. S was like NS1, NS2 already filled, NS2 is already filled. So what should I write over here? NS2 is already filled, kids. NS2 is already there. So what should I write in NP? NP. So the sum will come out 3. What should I write over here? NP. How much should I write over there? So the sum of S and P should come out 3, kids. 1. Very good. 1. So here I will write NS2 NP2. Here I will write NS2 NP3. Here I will write NS2 NP4. Here I will write NS2 NP5, and here I will write NS2 NP6, because if you're not able to write down the electronic configuration, you won't be able to understand the periodic table and the periodic properties, kids. Is this point clear to all of you? First of all, do let me know. Are you able to understand this much, kids? Is everyone able to understand, kids? Because if you're not able to understand S and P, they are simple most. then you won't be able to understand D and F. And if you don't know the electronic configuration, how will you be able to understand the exceptional configuration? And kids, have some water. Keep hydrated. If you want to eliminate out water, you can eliminate out. If you want to intake water, you can intake. Kids, keep yourself hydrated. Thank you, Darshini. Thank you, Super Class. Thank you, Lahirka. Thank you. Wow, thank you. No. Right now we have started and you are asking for break. Hey kids, don't be like this. You are going to be the best doctors and engineers. And sometimes doctors are supposed to do operation for 6 to 12 hours continuously without any break, kids. Right now, HSP Baba has started the class and you started asking for break. This is not the right thing, kids. How dare you? You can't. You are not supposed to do these things, kids. No. Wow, thank you. Thank you. Oh my God. Shushma Singari is writing that concentration decreases on adding water. Oh my God. The new concept. I have heard about that if you add, my God, water to the solution, then the concentration decreases. But she is writing, this girl has written that concentration decreases. But my dear students, you may be right, but you have seen the battery, lead storage battery, the inverter battery, the automobile battery. If the concentration increases too much, that battery is not going to work, because anode to cathode electrons will stop moving, and once the electrons they are going to stop moving, there will be no current. So is our body. If you are making it too much diluted, then also problem. But if you are making it too much concentrated, then the minerals will start moving from the urine, and that is going to be a big problem. So never think like that. Now kids, so our configuration was, configuration was 3s2 3p, third and fifth group, third and fifth. Now see, third and fifth, which element? Third. Zoom, third period. These are the periods. Third period, yeah, this will be in this line because it was coming. See, let me write down over here 3s2 3p3. It was coming 3s2 3p3. So this is indicating period. Let me write down period, otherwise you will think it's palladium. It was period, and this 3 plus 2, 5 is going to give you group. So third period and fifth group. See this line and see this line where it is getting matched. Where it is getting matched. Kids, do let me know where it's getting matched. Zoom, zoom. Hey, you are the answer. You are being the answer. Phosphorus. So it is phosphorus. Kids, got it? Have you played such type of game? In your childhood, you must have played. Just tell me the number. Just tell me the element. Is that element is in this row? Yeah, it is in this row only. In which group? This group? No, Baba, no. This group? No, Baba, no. This group? Yes. Oh, then this is the answer. Have you played this game? Have you played this game, kids? Okay, now let's come. Now let's come. If this is clear, do let me know, kids. If this much is clear, then I am going to shift to the D block. Say, show me the green signal, then I am going to move towards the D block, kids. Show me the green signal, then I am going to move towards D block, kids. How to find the group? Okay, I will tell you. Okay, now see, kids. So let me move towards the D block. D block, general configuration is N minus 1D NS. Now fill in the blanks. N minus 1D, definitely N minus 1D will move from 1 to 10. 1 to 10, it should go from 1 to 10. Now tell me, NS should be NS. What should I write over here? The NS value. Everyone do let me know, what should I write down for NS? How much should I write down for NS, kids? It's NS. People are writing 2. It is expected to be 2. It is expected to be 2. It is expected to be 2, but in exceptional configuration, this NS can be 1, or there is one example, very rare, where NS 0. Will you write 0? Will you write 0? No, we cannot write because there will be, so 0 doesn't exist. I will show you, right? 1. So let me explain, kid. Two elements you know very well. The chromium. First let me write down the elements so that you can find out. Fc, Pi, VCr, Mn, Fe, Co, Ni, Cu, Zn. This is very important, kids. Everyone has to remember this. Everyone has to keep this thing in your brain. These elements are very important. These elements are very important. They belongs to the 4th period and 3D series. 4th is the period for these elements. 4th period and 3D series. Now how to learn, kids? In this way, left to right. Now see, kids, science teacher very crazy man. Everyone say, science teacher very crazy man. Oh my god, everyone is writing science teacher very crazy man. Everyone say, science teacher very crazy man. Hey, science teacher, very crazy man. Science teacher very crazy man. Let me write down till that time their atomic numbers. Its atomic number is, its atomic number is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Science teacher very crazy man. felt cold, felt cold in night, felt cold in night with cousin, felt cold in night with cousin. Science teacher, very crazy man, felt cold in night with cousin. Everyone, oh my God, I can see everyone is started writing in the chat section. That's really awesome. These are HSPN. These are really HSPN. Science teacher, very crazy man. Wherever you're seated, say the body, let the body learn it. Science teacher, very crazy man. Felt cold in night with cousin. Science teacher, very crazy man. Having fear of cobra in night with cousin. Okay, you can write like this also. Having fever of cobra in night with cousin. Science teacher, very crazy man. Felt cold in night with cousin. Very good. Now see, I'm going to write down the electronic configuration of this chromium and the zinc. They are having exceptional, no, zinc is having okay, copper is having exceptional configuration. See, these two elements I'm going to write. See kids, I'm going to write, see everyone, chromium atomic number is 24. So if I start writing 1s2, s2, 2p6, 3s2, 3p6, 4s2, how much? 2 to 4, 6, 10, 12, 18, 20, and 3d4. This is the expected configuration. Expected. According to Aufbau Principle, Hund's rule, and Pauli's exclusion principle. So, according to Aufbau Principle, this is expected, but this is wrong. This is wrong. This is wrong. This is declared to be wrong. This is declared to be wrong, kids. This is wrong. Now, why this is wrong? What they have done, the last one, from here they have transferred one electron to that position. So they are saying 4s1, 3d5. Now, why they have done it like this? See, the reason is 1, 2, 3, 4. If the electrons are present like this, 5 electrons, they are saying it is having half filled stability. Half filled stability. Now, what is that? That means this electron, these are the houses. Just suppose these are the houses. This electron is saying, I can come to your house, you come to my house. One exchange. I will come to your house, you come to my house. I'm coming to your house, you come to my house. By doing that, they are delocalization. They are doing delocalization. Just like in COVID pandemic, we were not able to move because the government said curfew is there. No one is allowed to leave his or her house. So we were feeling uncomfortable. So these electrons, they are having webbical nature. See how they will be feeling in one locating in such a small area. They are weights, just like scent. You spray scent, it will delocalize. Then, kya hukm hai mere aaka, like that, it will spread. So electron wants to occupy maximum space. Gas wants to occupy maximum space. Now see kids, how many exchanges? 1, 2, 3, 4. 4 exchanges. Now this electron is saying, I have come to your house, but I have not gone to their houses. I haven't gone to their houses. You have gone to everyone's house, but this electron is saying, hey, I want to go their houses also. Now, three exchanges more, three more exchanges. Now, this electron is saying, I have reached to your house, I want to reach their houses also. So, this electron is going to their house, two more exchanges. Now, this electron is saying, hey, let me come. I want to come to your house. You just visit my house. 1. So, 4 plus 3 plus 2 plus 1. How much it is coming, kids? 3, 2, 5, 6 and 4. 10 exchanges. They are giving more stability, more delocalization, and that's why half-filled configuration is more stable. Everyone got it? Everyone got it? Is everyone clear? Now see, kids, let me tell you, without writing this much, you can increase your speed. You can write down electronic configuration without Aufbau principle. How many of you want to write down electronic configuration without applying Aufbau principle? Do let me know, kids. Science teacher, very crazy man, felt cold in night with cousin. How many of you want to write down electronic configuration without Aufbau principle? 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Because when you're moving to D block or the coordination chemistry, they will ask you find out the magnetic moment, and then you have to increase your speed at that time. Otherwise, you want to increase your speed, you won't be get rank. So kids, okay, see, just reverse it. Just reverse it and write down. Reversing it, I will write 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 2. I'm going to give you trick. See, Baba's trick. See, everyone, Baba's trick. Now we know that the general configuration is, see, it is fourth period. So n minus 1d ns2. That means I'm supposed to write down, this is fourth period. Fourth period, that means 3d and 4s2. Now see everywhere here 1 2, that means 3d1 4s2. Now 3d2 4s2. Now see 3d3 4s2. Now this is exceptional configuration, so leave it. Right now I've told you this is 3d5 4s1 exception. Now see, how will you write 3d5 4s2, 3d6 4s2, 3d7 4s2, now 3d8 4s2. This is also exceptional configuration, so leave it. 92, 29. So see, 3d10, one going to that 4s1, exceptional configuration. This is also exceptional configuration. Now this one, 3d10 4s2. Clear? I haven't followed above principle and directly I have written, kids. Is this awesome trick or not? First of all, do let me know, kids, because this will help you a lot when examiner is going to ask about coordination chemistry's question, hybridization, valence bond theory, or the number of unpaired electrons to find out paramagnetic, dimagnetic. How is this Baba's trick? Baba made it, kids. Baba made it. Are you liking this trick, kids? Do let me know. Baba's trick. Baba HSP made it. Baba, HSP made it. Now, if you are able to understand, kids, how is the Josh? First of all, do let me know. Then I'm going to switch to the D blocks exceptional configuration. I want to see your Josh. The Josh should not get decreased. The energy level should not get decreased, kids. Everyone, call your friends. Hit the like buttons, not buttons. It's only one button is there. You can hit only once. But you can call your friends, kids. I want to see the energy level. Key, water, chicky. Chicky means eating that good and round next one with your nearest place and eat it whenever you're getting time. Wow, now see kids. Wow, that's really awesome. Now see kids. These elements do not follow rules. These elements, first of all, everyone just see, this is the key. Make the key, you have to keep it in your brain. This TC, leave this TC. Why I have left this TC? Because this is journal. This is not exception. This is following the rules. This is journal. Whatever the elements I have written with this blue inside this box, they are exceptional cases. Now you have seen every element is supposed to have 4s2. See, 4s2. Every element is supposed to be having 4s2. Only these exceptional cases are having 4s1. See, they are having 4s1. Can you see, kids? Can you see? The exceptions, they are having 4s1. Otherwise, every element, each and every element is supposed to be having s2. Now see, kids, the elements inside these black elements, they all are exceptions. They all are being exceptions. They all are being exceptions, kids. Will you able to keep it in your brain, kids? Do let me know. These are exceptions, kids. Can you keep it in your brain? Because examiner will ask, will you be able to keep it in your brain, kids? Do let me know. Okay. Okay. So what you are able to understand, first of all, do let me know what you are able to understand, kids. What you are able to understand. These elements are having D1 configuration. Leave this. This is not exceptional case. This is having D1, D1, D1. Rest which are in blue, they all are having D2 configuration. These blue ones are having D2 configuration, and the elements which are inside this box, they are having D1 configuration, D1 configuration. Palladium is also having D2. So are you getting my point, kids? Will you be able to keep it in your brain? Yeah, everywhere. Now see, kids. Very good. No, M Traveler is writing, sir, not D1, it's S2. Yeah. Yes. Sorry. I take my words back. They are having S1. S1. Not, no. I said D1. Sorry. They are having S1. Kids, S1. Titanium is green because this is not exceptional case. This is not exceptional case, and it should be in blue. It should be in blue. It should be in blue. Let me write down, this titanium should be in blue because it's not, is breaking the chain, and it's not exceptional case. This is titanium. It should be like this. This is not exceptional. These are exceptional cases, and these elements, they are having S1 configuration. I said D1 by slip of tongue. I said D1. They are not having D1, they are having S1 configuration. Clear, kids? Clear to all of you? Is it clear? Is that clear to all of you, kids? They all are having S1 configuration, S1. These elements which are inside the key, let me write down. let me write down the elements which are inside the key. Inside the key, can you see the key? What is the color of the key? Do let me know what is the color of the key. What is the color of the key? If you can see the key, could kids do let me know what is the color of the key? Everyone, do let me know what is the color of the key. Orange. Inside the key, that is orange color, they are having S1 configuration. S1. But just see your NCERT, not all, one element is having S2 also. Which one is that? Outside the key, whereas outside the key are having S2 configuration. But there is one element which is having S2, but then also it is exceptional configuration. Do let me know. Inside the key, out of these elements, there is one element. This is, let me make it TC. TC is not the exceptional case. There is one element inside the key which is being having exceptional configuration, but it is not having S1. Just see your NCERT, everyone. You are having NCERT. Take your NCERT and just check it out. TC to I have drawn in blue. TC to I have drawn the elements which are in the key. They are having exceptional configuration. There is one element which is not having S1. Just take out your NCERT and check it out. Hey, even I'm checking. See, everyone check it out. Just check it out. Which element is that? Which element is that? Check it out, kids. Just check it out. Everyone just check it out. Try to find out. This is the NCERT. See, you have to apply eagle eyes because that question can come. Palladium. Very good. Very good. Palladium. How it is having exceptional configuration. See, the other family members of palladium. See, palladium's nickel is having 3D8 4s2. Now, platinum is having 6s1, but palladium is having 4d10. So S is what? 4d10. So S is how much? 0. S is 0. S is 0, kids. So palladium, see kids, palladium is having 4d 10 and 5s0. Am I right, kids? First of all, do let me know. 4d10 5s0. It is written in your NCERT or not? Class 11th NCERT. Just check it out. Everyone just check it out. Class 11th NCERT. First of all, check it out. This palladium is having this configuration or not? Do let me know, kids. Everyone, do let me know. Now that means this is the only element whose D is having 0. See where I have written this one. I have written that NS is 1 in exceptional cases. This is 1. But see, I have written it cross. So only one case. Only one case is there. Only one case. What is that? That is palladium. Palladium is the case, otherwise 0. Very rare. Kids, just see to it. See, nickel, these are the number of things are there. No rules. It's, these are the exceptional cases. One kid is asking, why not nickel? Okay, Abhyashri, everyone got it. First of all, do let me know. You got it or not? Palladium's exceptional case. Everyone got it or not, kids? Do let me know. This is really awesome. Something really very good. How many of you got it for the first time? How many of you are able to see it for the first time? Do write down in the chat section. Show me the thumbs up if yes. Those who are going to see these exceptional conflicts. See, chromium and copper, everyone knows. The whole world knows about chromium and copper are the two exceptional cases. But these many exceptional, and palladium is 4d10. Oh my God. See, where is palladium? This. We are thinking they are having D10. But this palladium, Pandeyji is very smart. Pandeyji has filled his D block. You must have watched one movie, Pandeyji. So Pandeyji is very smart. Pandeyji is very smart. He has filled his D10. Pandeyji is very smart. And this is Pandey, not Pandey. This is which one? Pandu. This is Pandu. Pandu is very smart. Pandu has filled its D. Pandu is very smart. Pandu is a smart guy. Filled D10. Now you can remember Pandu. No break right now, kids. I will give you break at 9. I will give you break at 9, kids. Yeah, Pandu was eating potato and dosa. That's my Pandu is very smart. Pandu is very smart because Pandu was eating potato dosa with Nikki. Kids, let me tell you, kids, I'm having 115 slides. Right now, I haven't used even a single written slide. Till now, Baba has not used even a single written slide, and that's why I have written those slides to minimize time. But this class can go up to 1 or 2. Means I have to teach each and everything. First of all, do let me know, kids. Am I right or wrong? This, I'm doing this much of sacrifice I'm doing for you, and this lecture will be the best lecture in the whole world because no one is having these notes. I swear, kids, how much I've written, how much I made. This class is like a festival for me, kids. If Baba can do this much, at 9 I will give you one break. At one break, my dear kids, and think about those students, those who are thinking chemistry pedicure radu customer. Just think about South students, those because they are not having any mnemonics. Everyone is giving mnemonics in Hindi. But just think about South student, English medium student. This batch is purely English medium. Just think about those students. They are thinking like chemistry pedicure radu customer. But I have to say, it's romba sulbham. That means most of the students are thinking like chemistry, inorganic chemistry is tough. But I have to say it's very easy. Inorganic chemistry, periodic table, pedicure radu customer. It's romba sulbham, kids. Yeah, it can go up to 2 a.m. It can go up to 2 a.m. Now see, kids. Let me come to the F block. Hey, Sinsim, my dear F block. Now in F, how many electrons can be filled? How many electrons in the F? Yes. 1 run monu nale anche are ere ette umpat pad vanna pad randa pad mula pad nale pad vanna pad randa pad monu pad nale 1 randa mule nale 1 randa monu nale anche are ette umpat 20 pad vanna pad randa pad monu pad nale 14 electrons. 14. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is lanthanoid, this is actinoid having 14 elements. Okay. Now, Baba is going to give you the trick. Baba is going to give you a trick. See everyone. Hey, oh my God, this much is written. How will you able to learn it? See everyone. Should I start? Should I start? You know Prime Minister, you know Pradhan Mantri, you know PM. What is the difference? Is there any difference in between Prime Minister, Pradhan Mantri, PM? They are same. Thank you, thank you, thank you, kids. Thank you, thank you, thank you. Pradhan Mantri, PM, Prime Minister, they are same. Now see, the awesome trick Baba is going to tell you. See. C. Actually, C in English it is C, S-E-E, but here C. Prime Minister or Pradhan Mantri, C, Prime Minister and PM are same. You will never get this trick anywhere. Now from tomorrow, everyone is going to copy it. See, kids, you will see the short videos on this. Kids, Baba has made it. Baba has spent whole day and night. Now see, Prime Minister and PM are same. You will never get this trick anywhere, kids. I swear, kids. Number of tricks you must have seen, but no one has made this trick in the whole world, whole universe, kids. This much of creativity, no one can do, kids. See, everyone write down. See, Prime Minister and PM are same. See, this is logic or not? Just say, is it logic or not, kids? See, Prime Minister and PM are same. See, Prime Minister and PM are same. Now, after this, have you heard the name of place Uganda? Have you heard the name of place Uganda? Have you heard the name of place Uganda? Baba's style, nothing extra is coming. In the mnemonic, only the symbols are coming. This is the most important thing. Number of tricks you must be having in your brain. They are having number of extra things, and that's why with those tricks you are getting confused. But in Baba's style, Baba is giving such a great trick that only symbols are coming. Nothing extra thing is coming in the trick of Baba. South Africa's place. That Uganda is known for rivers and mountains. The place, Uganda, that is well known for the rivers and the mountains. This is the best thing about Uganda, because the nature is very, very important. Now see, Prime Minister and PM are same. Uganda's good things are on think table. Uganda's good thing are on think table. Uganda's good things or Uganda's God things are on think table. Uganda's good thing or Uganda's thing are on table. Simply Uganda is on table. Uganda is on table. You can write Uganda is on table. Or Uganda's good thing are on table. Uganda's God things are on table. Or Uganda is on table. Kids, hi, brothers, sisters, kids, really, you see how much time I must have spent, kids. Everyone, kids. Now everyone, inge va, ivde va. I will show you the trick. Baba is saying, inge va, come here. Baba is going to give you Uganda's good table. Oh, very good. Uganda's good table. Now, see, Prime Minister and PM are same, means same. Uganda is on table. Now, what Prime Minister has done? Deputy Home Minister and Engineer. Deputy Home Minister and Engineer will come tomorrow on YouTube from Lucknow just to see these good things. Deputy Home Minister, in the minister only ER is there. Deputy Home Minister, ER there is in minister only. If you don't like it, you can add engineer. Deputy Home Minister and Engineer will come tomorrow on YouTube from Lucknow. Deputy Home Minister and Engineer will come tomorrow on YouTube from Lucknow. This is Arni is writing, when you have learned Tamil. Kids, when I was in class 3, my father was in Kerala, Tiruvananthapuram. My father is a doctor, was a doctor, better to say. Now he's retired. He is still doctor, but he was in Army Medical Corps. That from class 3 to 6, I was there in Kerala, Tiruvananthapuram at that time. Now, everyone say CCC. Prime Minister, CCC, Prime Minister and PM means same. CCC, Prime Minister and PM means same. Uganda is on table. See, Prime Minister and PM means same. Uganda is on table. Now, Deputy Home Minister and Engineer will come tomorrow on YouTube from Lucknow. Clear? Is it clear, kids? Is it clear? Wow, Luke has written, kids. Luke has written. Kids, I want 1,000 likes. If really I'm doing a great work, really, if you're liking it, please hit the like buttons, call your friends, make it 1,000, kids. It's not good thing. I will tell you, legends only, I will tell you how to do the questions. Let me come to that place. Let me tell you the basics. If you don't know basics, then how will you do that numericals? If you don't know how to ride bicycle or drive, how can you participate in the race? Okay, everyone, try to make it 1,000. Call your friends. J batch, energy batch, J NEET, everyone. Now see, kids. See, this is lanthanoid. Say, everyone. Now, should I tell you one slok? In Sanskrit? Should I tell you one slok in Sanskrit for this? This is about Hanumanji. This is all about Hanumanji when Hanumanji has gone to Lanka, Sri Lanka. Should I let you know? See, try to understand. So I'm going a bit aside so that you can see and correlate with this. Let me shift aside. Then I will speak. See, I'm moving aside, then I will speak. से पर नंद प्रेम समयूं गदरई तब दई हो इतमाय बलूरे. से पर नंद प्रेम समयूं गदरई तब दई हो इतमाय बलूरे. से पर नंद प्रेम समयुगद रई तब दई हो इतमाय बलूरे. हे से पर नंद प्रेम समयुगद रई तब दई हो इतमाय बलूरे. से पर नंद प्रेम समयुगद रई तब दई हो तमाए बलूरे. It's now let's come to actinides. Thank you, thank you, thank you, thank you. Now this is the first time I'm getting the reward of my koshishe efforts. Now let's see. This is C Prime Minister and PM means same. This I have written for you. C Prime Minister and PM means same. Uganda's got things on think table. Deputy Home Minister Engineer will come tomorrow on YouTube from Lucknow. Now, I'm going to give you this actinoid. Actinoid. Are you ready for actinoid? Thank you, kids. Thank you, thank you. Thank you, kids. Thank you, thank you. Now, everyone is ready for actinoids. Hey, everyone, see. Are you ready for actinoids? Are you ready for actinoids? Thank you, Latharkia, thank you, thank you. So, everyone, are you ready for actinoids? Now, see. Do you know Thor? Do you know Thor? Thor? Do you know Thor? Now, we know that these Spider-Man, He-Man, Thor, all these Avengers, they can reach to any place. Just like we Avengers, we can reach to any place. So this Thor is having the habit of moving to the outermost planet from the sun. You know, planets in the distance wise from the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, Buध, Shukra, Prithvi, Mangal, Brihaspati, Shani. You remember? As you go away from the sun is like nucleus, and the orbits are like shells in which electron is revolving like planets. They are moving around the sun. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto is not there. So which planets are farthest away? So this Thor is having habit of going to those planets. So see, Thor, Thor, Thor's PA. Even Thor is not going. Thor is asking his PA, hey, you go. Let me make some other things. Now, Thor is not going. Thor's PA, Thor has sent its PA. Thor's PA has gone to Uranus, Neptune, and Pluto. Pluto is not there, but see, kids. Thor's PA has gone to Uranus, Neptune, and Pluto. Their names are also like this only. Thor's PA has gone to Uranus, Neptune, and Pluto. Clear? Now, in the AM came back to California. First, PA has gone to Uranus, Neptune, Pluto, and now in the morning, in the AM time, he has come back to California. Thor's PA has gone to Uranus, Neptune, Pluto, and in the morning AM came back to California. Now, for what he has gone? For what? To do what thing he has gone? See, he brought some knowledge, the records from there, and he has given to Einstein and Mendel. He has given to Einstein and Mendel. See, Thor's PA has gone to Uranus, Neptune, Pluto, and came back in the AM. In the AM, came back to California, and he has given notes to the Einstein, and Einstein has become famous. Einstein has become famous, and Mendel has given Nobel law. This PA has helped Einstein and Mendel. So see, Thor's PA has gone to Uranus, Neptune, Pluto in the AM, came back to California and given some clues, and Einstein has become famous, and Mendel has given Nobel law. See, nothing is extra. These are the actual meaning of the elements: thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einstein, fermium, mendelium, novelium, lawrencium. These are the actual meaning of elements. Kids, I can't see your messages. Is everyone getting it? I'm unable to see your chats. Kids, is everything okay? Is everything okay, kids? I'm unable to see your chats. Now I can see. Yeah, now I can see. So everyone just do let me know. Everyone, how is it? How is it? Horse PA. So everyone say, Horse PA has gone to Uranus, Neptune, Pluto. Horse PA has gone to Uranus, Neptune, Pluto. In the morning, AM came back to California. And Einstein has become famous and Mendel has given Nobel law. Thank you, kids. Thank you. Thank you. At 9, I will give you one break. At 9 p.m. I will give you one break, right? At 9, I will give you one break, kids. Now, see. Now, these elements, the configuration, electronic configuration, what do you think? General electronic configuration for these elements should be. What do you think, kids? General electronic configuration is supposed to be, kids, do let me know. Number of questions they will ask you based on this. Everyone do let me know what do you think. N minus 2f. N minus 2f. From where to where? From 1 to 14. 1 to 14. Then n minus 1. N minus 1 d. What do you think d should be? D should be, and ns2. D, what should I write over there? D. This is the most important thing, my dear students. What D will come? What the value of D will come? What do you think, kids? D will come 1 to 10. No, no, no. Let me tell you the position of these elements, where it lies in the periodic table. Okay, then only will come to know. Otherwise, you won't be able to understand. See, kids, just wait. Just wait. Let me tell you where it actually lies. This is S block. This is S block. And this is D block. And there is P block, right? There, leave it. The P block is there. Okay, that is P block. Leave it. Nothing to do with P block right now. This is S block. Hydrogen, leave hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Otherwise, you won't be able to understand. Kit C. First, second, third, fourth, fifth, sixth, seventh. Now see, here is barium. Here is barium. This is also of S block. Till now, this is S block, right? Till now, this is S block. Till now, it is S block, kids. Now see, from here, just see to it. If I say this is D block, this is first, this is second, this is third, and this is fourth. And The atomic number of lanthanum is 57 and hafnium is 72. Can you see anything missing here? Can you see anything missing over here, kids? Is anything missing over here, kids? Do let me know. Do you think anything missing over here? Missing over here, kids? Anything missing over here? Just do let me know. Can you see anything missing over here, kids? Anything missing over here, kids? Can you see anything missing over here? 58 to 71. That's why these are known as transition elements. These are known as transition elements. Transition D block. D block elements are known as transition. But in between this 58 to 71, just see 58 to 71, 14 elements are missing. 14 elements in between transition, and these are known as inner transition, and that's why they are known as inner transition, because they are lying inner of transition. Inner transition elements, and these elements belongs to F block, and that is lanthanoids. And see, 58 atomic number is of cerium, and 71 is of lutetium. So cerium to lutetium, these elements, just let me show you these elements. 58 to 71, see, 58 to 71, actually they are located in D block's inner, but there is no space. So D block said, you just get lost, get away, nipoda, and that's why they have gone out of D block, but their actual position is there only. That's why these are known as inner transition elements. These are known as inner transition elements. Are you able to understand? Now let me show you one more thing. These 90 to 103, where they actually lying? See, which period they are actually lying? This. There is no space, but let me write down. Francium, barium, radium. Here it should be radium. Now here it should be AC, sky lace, and here 14 elements. This space is for 14 elements, and now 90 to 103 elements, at 14 elements, they are known as actinides. After starting actinum, lanthanoids are starting after lanthanum, and these are 90 to 103. And then here it will come Rutherfordium 104, kids. These actinoids place. If not clear, then let me make another page. Don't worry, kids. Let me make another page. So to give you the clarity, you're not able to understand. Let me show you, kids. Let me show you. This is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So we were talking over here 6th and 7th period, 6th period and 7th period. So cesium, barium, radium, these are S block elements only, S block. But see now, D block, here D block, this is also D block, This is also D block. But here, see, its atomic number is 57. Its atomic number is 72. Now elements cerium to lutetium 58 to 71. 14 elements are lying over here. These are known as lanthanoids. Lanthanoid kits. Now in this AC, now here 90 to 103, thorium to lawrencium, thorium to lawrencium, thorium to lawrencium, thorium 90 to lawrencium 103 elements. These are actinides after actinum. Actinum's atomic number is 89. Rutherfordium is D block. This is D block. Rutherfordium is D block. But these are kits. First of all, do let me know. I have moved aside. Okay, no charging in. Okay, just after 15 minutes, I will give you a break. Kits, just wait for 15 minutes. Little bit confusing. Okay. First of all, do let me know how many of you are able to understand. Then I will make, otherwise I will make neat and clean picture. If those who are able to understand, show me the thumbs up. Those who want to understand, show me the green hearts. Those who are interested to understand once again in the neat and clean picture, show me the green hearts. And if you are able to understand, have you understood? If you understood, show me the thumbs up, so that I can get the clear picture. Those who have understood, show me the thumbs up. Those who wants to get it explained again, okay. Now see, I got it. The message is clear to me. Let me write down. See, this is your periodic table S block. This is your D block. This is your D block. This is your P block. Okay, this much is clear. If I write this much, are you able to understand this much? This is your S block. Blue one is your S block. This green one, this one, and divide it. This blue one is your S block. Blue one is your S block. Green one is your D block. Red one, this maroon one is your P block. This much is clear? Is this much clear? P block. Blue one is S block. This green one is D block. Till now, is it clear? Is it clear? Now see, if I write down hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. If I write their horizontal periods, horizontal are the periods: first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Alkali metals. Now I'm going to write alkaline earth metals. Alkaline earth metals. Beryllium is exceptional. Beryllium, magnesium, calcium, strontium, barium, radium. Now, this is first group. This is second group. It also moves like this. This is another way of writing. Third group, fourth group, fifth, sixth, seventh, eighth, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Till now, is it clear to each and everyone? Till now, is it clear, kids? Now, in the third group, I am going to write SC. Do you remember? YLAC. These are D block elements. These are D block elements. These are D block elements. How to write down their electronic configuration, that also we should know. See, kids, its electronic configuration. This is 4s1, 4s2. This is 3d1. So last electron is coming in D. 4s2, 3d1. 5s2, 4d1. 6s2, 5d1. 7s2, 6d1. Now, till now, everyone is able to understand. Is everyone able to understand, kids, till now? Now, if I write down here the element, this element, the fourth one, this is titanium, zirconium, hafnium, rutherfordium. After its atomic number is 21 and this is 22. It's okay. Are you getting my point? Its atomic number is 21, it's 22. Now, what is the atomic number of this? We don't know. So, we have to take help from here. Helium, neon, argon, krypton, xenon, radon. So see, if I write down their periods 1, 2, 3, 4, 5, helium, neon, argon, krypton, xenon, radon, 6. Is it okay? Now this is in fifth. Fifth means after 4. We know atomic number of these elements. These elements. What is the atomic number, kids? It is 2. Let me use another page. Not the page, but the color. 2, 10, 18, 36, 54, 86. Right, kids? I'm moving slowly so that everyone should be able to understand. Are you getting my point, kids? I'm moving very slowly so that everyone should be able to understand, kids. Now see, this is in fourth, that is 36. After 36, 37, 38, and this will be 39 and the 40. It will come like this. And this is 54. After 54, what do you think? 54, 55, 56. This is coming 57. And after 57, it has to be, it's supposed to be 58. But it is not 58. It is coming 72. What do you think? Is it okay? Or some problem is there? Just think. Are you getting my point? This is coming 21. After 21, it's coming 22. It is okay. It is okay. Now 36, 37, 38, 39, and this is coming 40. This is also okay. But this is coming 55, 56, 57, and 72. Something is missing over here. Here something is missing, and this missing thing is known as lanthanoids. This missing thing is known as lanthanoid. 14 elements, cerium to lutetium, cerium to lutetium, cerium to lutetium, 58 to 71. They haven't got position over here. That's why they have been thrown out just below the periodic table. They are saying, oh my God, you are top notch and you have kept me at the lower position. What is this? This is not good. They are talking like this. These elements have been thrown just below the periodic table and they are saying, oh, we are in your charan, we are on your feet, We are always saying, hey, hey, they have thrown out over there. Now, here it is 89. It is 89. This is 104. Something is missing over here also. 14 elements. Those 14 elements are missing. They are known as actinoids. Now, kids, do let me know. Now the each and everything is clear. Yeah, just after 6 minutes, I will give you a break. I will give you a break, kids. Just after 6 minutes. Was first of all, do let me know everyone is able to understand, kids, what I was trying to tell you. What I'm now. How many of you are able to understand? Show me the thumbs up. Those who are able to understand, show me the thumbs up. If you're not able to understand, then show me the hearts. Okay. Now see, kids. Now see, these elements, they are having lot of configurational problems. See, kids. So this is the general electronic configuration n minus 1d. Now this was the question. D should be having how many electrons? Just see once again. D should be having how many electrons? D is supposed to be having D1 configuration. D1C. Just before these, D1 is coming. So D1, they are supposed to be having D1. They are supposed to be having D1 or not, kids? See, they are just coming before this. These are D block elements. They are coming just before lanthanoid and actinoid. So D1 should be there, and here the filling of electrons should take place in F. And that's why they belong to F block. Their F should be filled, and that's why they are said to be having an F block. Are you able to understand? Kids, now see, they are supposed to be having F and D is supposed to be 1, but there are a number of exceptional configuration. Let me show you, kids. Let me show you. These are the exceptions, and this has been asked number of times in the examination. If you are having NCERT, the elements which I have marked the round circle, they are having D1. Only these elements, this one, this one, this one, this one, this one, they are having D1 configuration. Rest of all others, they are not having D1. Just see to it. Just see to it, kids. Your NCERT, just check it out. These are the exceptional configuration. Just check your NCERT. Let me show you. Let me show you. Class 11th NCERT. Just take out class 11th NCERT and see. Cerium is having D0. PR is having D0, 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 D0. Only GD is having GD1. GD1, LU1. And DY in some books is given D1. DY is also, in some books, DY is also given to be exception. In 11th or 12th, this is also shown to be the exceptional case. DY is also shown to be the exceptional case, kids. Now, kids, how many of you want trick for this? Then I will explain. Have you seen your NCERT? Have you seen your NCERT? These elements are having D1 configuration, the round circle, and this is black, dark green. This is cerium. In class 11th and class 12, there is difference, and this Thor is having D2. This Thor is having D2. Let me show you. Let me show you what is given and what is the trick. Let me show you, kids. Just see to it. Just see. See. These are the exceptional configuration. Thor is having D2. Rest of all other having D1. And there is D1. Cerium is given 1 or 0. In class 11th, it is given 1. But in 12th, it is given 0. Are you able to understand? Then only I am going to tell you the trick. If you are able to understand, then do let me know. Then I'm going to tell you the trick. If you're not able to understand the concept, rest of all other, they are having 0. In D, they are having 0. These are the exceptional cases. This is having D1, dy is having D1, dy is having D1. And if you're an NCRT, some other things are given, I will ask, but please get the PR is also given. PR is 0. Let me tell you, kids. First, see what I'm telling you. The elements which are in round circle, they are having D1 or D2. Listen to me, what I'm telling you. The elements which are in green round circle, they are having D1 or D2. One element is having D2. Rest of all other round circle, they are having D1. Rest of all other elements, they are having D0. LR, yeah, this LR is also having, see, LR is also having, and I have written over there, see, LR I have written, LR is written over here, see kids, it's by chance it was missing, LR is there, LR is there. Are you able to understand? The round circle one, they are having D1 configuration, rest of all are having D0. One kid is asking, cerium is having 5D0. Just see in class 11th and 12th, I must have written C, kids. See, cerium is 1 or 0. In class 11th NCRT, it is given 1. On 12th, it is giving 0. See, let me show you. See, cerium. D0 in 11th NCRT and D1 in 12th. See, just check it out. How much hard work Baba has done. How much hard work Baba has done. See, cerium D0 in class 11th NCRT and class 12 D1 it is given. See kids, whatever you check out your NCRT, Baba has already done that much, kids. Lanthanum is in D block. So lanthanum is a D block. No need to write lanthanum. I have written only because it is having D1. Lanthanum belongs to D block. No, it's not F block. Lanthanum is D block. So whether you write or no need to write, it's D block. So leave it. This is D block only. And why I have written? Because it is also having D1 configuration. But focus on GD, CE, LU. They are having D1. First of all, do let me know everyone is able to understand what I am telling you, kids. First of all, do let me know, are you able to understand what I am telling you? The round circle one are having D1, rest all are having D0. Let me copy it and let me write down. Otherwise, you won't be able to understand, see kids, what I am going to tell you. Let me minimize it. Now let me write down. All circled elements are having D1 configuration, D1. Thorium is having D2. Thorium is having D2. Rest of all the elements are having D0. Whereas rest of all lanthanoids and actinoids having D0 configuration. Now statement is clear. Now my dear students, I've told you I will give you break. I will give you break at 9. Sorry kids. Kids, just give me 5 minutes. Then I will give you a break. Otherwise, this will start crying D block that you are leaving me in between. Kids, just give me 5 minutes. I'm extremely sorry. I promised you to give a break at 9, but this is just crying D block. Please complete. Please let them know each and everything about me. Then you can give the break. Kids, now this thing is clear. Now the question arises, how to remember. How to remember. So many exceptions are there. Sir, your knowledge is perfect. We are agreed. We are able to understand each and everything, but how to remember it? It's how many of you want the trick for it? How many of you need trick for it? Kids, do let me know. Baba is going to give you the trick. Now one kid is writing dy is D0. In one NCERT it is D0, but another NCERT it's changed. Now see kids, God is, this was the question which has been asked in NEET, AIMS and IIT. God is 1, 2, 3. God is 1, 2, 3, 4, 5, 6 like that. Do let me know. God is 1. God is 1. See. God is 1. GD is 1. God is 1. D1. God is 1. God is 1. God is 1. 1. GD1. D1. D1. Now the trick is good cellulase. Good cellulase. Everyone say good cellulase. I will tell you, Jyoti, both are correct. So wherever they are writing D0, CE, 1 or 0, both are correct. So examiner will take care of it. He is not going to give you. So if at two places D is 1 or 0, so examiner will take care of it, no problem. Good cellulase. Everyone say good cellulase. Now, good D1 cellulase, CELULA. CELULA. They all are having D1 configuration. They all are having D1 configuration. Clear? They all are having D1 configuration. D1. All of them, they are having D1 configuration. Good cellulase. Everyone say good cellulase. Good cellulase. Now, good cellulase. Clear? Clear? Now see, according to you, Napoleon is on similar path from day one. Say, according to you, Napoleon is on similar path from day one. Day one is D1. Day one is D1. According to you, AC, U, Napoleon or Neptunium, you can write Napoleon or Neptunium, is on similar, CMLR, similar. We call in English similar, but Hindi or English similar path, PATH. According to you, Napoleon is on similar path from day one. Yeah, this is more than enough for JEE or NEET. No one can ask any question out of this. Good cellulase, GDCELULA. This LA is lanthanum. This belongs to D block. So definitely it is going to be D1 only. According to you, AC is actinium. Definitely it is D block. This is D block. But UNP similar path. They all following D1 configuration. But this thorium is following D2 configuration. Rest of all they are following D1 configuration. This thorium is D2. Is it clear? Now see, I have given this trick. I have written this trick. God is one. Cellulose is one. Cellulase. But in one book, dy is also given. So see, dy. According to you, Napoleon or Neptunium is on similar path, D1 configuration, and Thor is D2 configuration. And see, okay, see, I made one more quote because in some book dy is given, dy is also given. So see, good day. Have you eaten good day? Good day. Cellulase biscuits. Cellulase enzyme which is acting on cellulose. Very thick. Make it better. Good day. Good day biscuit. Good day. Good day. Cellulase. So this is GD. This is dy. This is Cu, Ce, Lu, La. Once again, C, no problem. So all these are F block elements, but this lanthanum is D block. So all they are having D1 configuration. D1, rest are D0. So kids, now I can give you a break, kids, but first of all, do let me know till now everyone is able to understand, kids. Till now, is it clear to each and everyone? Is it clear to each and everyone? Good day, cellulose. Yeah. Now, my dear students, for how many minutes you need a break? Your break supposed to be of what duration? Kids, do let me know. What other teachers have given you break? What was the duration of that break, kids? What was the 20 minutes break? So it's 20 means 8, 11. So kids, we have to give break because most of the students, their battery is not charged. We don't know. At some places there is heavy rain. It's terribly raining, kids. It's hailing. So some kids, their battery is not charged. They will take help from some place, whatever the place, whatever the person, thing, they are going to take help. So we have to think about those students also. Otherwise, I'm okay with no break. I don't want to give a break, but some kids, they need some snacks, they need some energy, some has to eliminate out water, some has to take water, some kids. So it's 20-minute break, kids. Okay, so we will meet at 8:35. We are going to meet at 8:35. It is okay, kids? Will it be okay? 8:35. We are going to meet at 8:35. And kids, will you come with the same energy level? 8:30 p.m. with same energy. Come with same energy. The class will resume at 8:35. Class will get resumed. Class okay, kids? But you have to make a promise. Everyone, you have to come with the same energy level. Otherwise, Baba will become angry. You know, Baba means a lot. Baba is having 24 years of experience. Baba is going to bless you. You have to come with the same energy level. Number of things are there. Now, I will write less. In the second half, I will write less and I will use the written slides. Till now, I have used very less written slides. After this, I'm going to make use of maximum written slides. Now from 9 to 11, at 11, I will give you second break. Say to your parents, at 11, you are going to get second break. And then after that, I will start the class because I have to teach each and everything, kids. Is it okay? Show me thumbs up. You will come with the same energy, everyone. Everyone, will you come with the same energy, kids? Do let me know that. Are you ready to come with the same energy level? I want to see with the same energy level after the break. Yeah, yes, 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 yes. Okay, so let's meet at 8:35. Really, you are good students and you're definitely going to break number of records, and I can see your rank because your dedication, the one who's really doing hard work, the success is waiting. I can see your hard work, the one who's really doing hard work, the success is waiting for those students. Fantastic. Avengers, Conquer, everyone, fantastic. Once again, welcome back to your Avengers, Unacademy NEET English channel, my dear students. This is your Baba HSP, and I'm on time, my dear students. Baba is never late. Hey, have you had your dinner? Have you had some snacks, fruits? Eating fruits in the evening is not good. So you must have had your dinner. I think so. My dear friends, yes. Your batteries got charged. Your energy level must got increased. You have taken glucose. The carbohydrate got converted to glucose, and they are going to produce ATPs 36, 38. Eukaryotic, prokaryotic, glycolysis, imide, and Maillard pathway. The ATP is full of energy, oxygen, hemoglobin. My dear students, if you got it, the energy, yes. So first of all, everyone, to let me know that your Baba is audible as well as visible. My dear students, hey everyone, do let me know that Baba is, yeah, super high. I can see that's really awesome. My dear students, right now I'm not only teaching this periodic table, I'm just trying to dissolve all my chemistry molecules. I want to dissolve this chemistry in your hippocampus so that no need of revision again and again. Just your Baba is trying put in such a way the concepts, the time of examination, when everyone is thinking about revision, how to do revision, you should be happy, you should be in a comfortable position that no need of revision, that you should be in that condition that yes, at least periodic table, the periodic table which is a base that should be there in your brain, hippocampus. Now, when you are going to correlate the concepts of physical chemistry and organic chemistry, the rest of the whole inorganic chemistry, that it will become really easy. You will see the redox reactions, the chemical bonding, each and everything, the clarity will be there. And yes, you will be able to do the questions. Questions will look like easy peasy and lemon squeezy like that. Oh, my dear friends. So, is everyone ready? Are you ready, kids? If everyone ready, show me the green hearts. That is the signal. That is the signal. If you're not having green hearts, you can show me some fire in the chat section. Some fire or the green hearts. That will be the signal to once again continue the class after this break, that is known as dinner break or snack breaks, that I don't know, because right now I haven't done my dinner. Once I'm going to eat, I'm going to have my dinner, I won't be able to teach because I'm in the standing position. I have to deliver this lecture. So all my chemistry molecules, let's begin. Let's begin, kids. Let's begin. Now, this much homework I have done. Now, you must be thinking, sir, this is very lengthy. The lanthanoids, actinides, they are very lengthy. How to write down their electronic configuration? Now, my dear students, if you follow Aufbau Principle, 1s2, 2s2, 2p6, 3s2, 3p6, it will take too much time. It's going to take too much time. You won't be able to write down the electronic configuration. So, how many of you want to have the trick, the logic, how to write down such a lengthy electronic configuration? Because number of times examiner has asked such type of questions. Number of questions have been asked in this way. So how many of you want? Kids, do let me know. Now see, if we write C, E, P, R, N, D, P, M, S, M, they are not having exceptional configuration. Leave C CE, leave C, and C, they are not having exceptional configuration. In the lanthanoid, there was GD, LU, right? And some cases D by. So they all will be having D0 configuration, D0. Now see kids, if I say xenon, what is the atomic number of xenon? What is the atomic number of xenon? Helium, neon. From here only I have started: helium, neon, argon, krypton, xenon, radon. The magic number I have told you, at that place I have told you 2, 10, 18, 36, 54, 86. Now xenon stands for 54, is having the value of 54. That means if anyone is saying xenon, that means it accounts for 54. It is like gold. It is like gold. Gold is having value. To keep the gold, they will give you money. So xenon is having 54 value and this is 58. How much I should add to 54 so that it should become 58? Definitely 4. Now S2 is completed. Everywhere S2 will be there. S2 will be there. Wherever you see S2 will be there. S2, 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 because S block is completely filled. So S2 have to have over there, right? Now, if I say D is 0, now I have to make 4. It's if D is 0, 2, I have to make 4. How much I should write over here? 2. If I say this is D1, 2, 1, 3, then it should be like this. This one you are able to understand because its atomic number is 58. Its atomic number is 58. So I have to do like this. Now, my dear friends, this thing is clear to all of you or not? Do let me know first of all, this thing is clear to all of you or not? Now, if it is clear, then one more question will be coming to your brain. So how to remember the atomic number? By chance, if we don't know atomic number, then how to write? This is the question. I'm giving you one more clue. If you don't know the atomic number, then also how to do it. Let me tell you. Let me tell you. By chance, if you're not provided with the atomic number, then how to do it? See kids, let me tell you. If I say this was hydrogen, lithium, hidden, Lena, nose, ruby, sees in France. And one thing I have told you very clearly, that this is first period, second period, third period, fourth period, fifth period, sixth period, seventh period. From sixth period it is starting. It is like cesium, barium, then lanthanum, and then these elements are starting. Cerium to lutetium, 58 to 71, but we are not interested in their atomic number. These are lanthanoids, 14 elements. But we are not interested in their atomic number. But you can see one thing. See kids, you can see one thing. This is 4s1. This is 6s1. This is 6s1. 6s1, 6s2. Now, this is 6s2 and 5d1 and 4f0. Till now, everyone is able to understand. 1, 2. See, 2 and then one more, 3. So, from here to here, we have filled how many electrons in xenon? Xenon was 54. Xenon was 54. I made it 55, 56, 57, means 1, 2, 3. Anything which is going to start, we have to fill 4 electrons, like 4, then 5, 6, 7. I have to start from 4. Everyone able to understand? 1, 2, 3 already filled. Now I will say 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, then 13, then 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. These elements I'm supposed to fill. Are you able to understand, kids? Are you able to understand? Without knowing the atomic number, you can write down the electronic configuration. Even if you don't know the atomic number, then also you can write down. So how it is going to be helpful? 4, 5, 6, 7, 8, 9 means 4 and 17. See, 4 and 17, how I am going to make use of it? 4 and 17, see. 4 and 17. Kids, do let me know. Okay. With atomic number, you can write down the electronic configuration. Without knowing even the atomic number, I will let you know how to write down the electronic configuration. See, kids, let me tell you. Let me explain. See. If I write down now, see, everyone see to it. If I write down like this, here was something 4s1, 4s2, and there was lanthanum. This was cesium. This was barium, and here was lanthanum. Lanthanum was 4s2 and 3d1, right? Is it clear? Now, whatever I have to fill, how many electrons to xenon I have to add over here? See, if I say xenon, xenon's value is 54. 54. Now, 54, 55, 56, 57, 58 means I have to add 4 over here. I'm supposed to add 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 I'm supposed to add. It's okay. Now they have asked the configuration for gadolinium. Suppose they are asking for gadolinium. Write down its electronic configuration. So I will write xenon. Its value is how much? Its value is 54. Now I will write 4s2. 4s2 means 54 plus 2. 56 means this to included over here. This to included over here. Are you getting my point? This has been included over here up to 4s2 and d1 I have used, means I have to add 10 electrons. Mean to xenon. Are you getting my point? How many electrons I am supposed to add, kids? Here I am supposed to add 4, 5, 6, 7, 8, 9, 10. In this I am supposed to this I am supposed to add 10. So 54, 2 already I have used. How many are left? 8 are left. Now, okay, I will tell you according to atomic number also. First of all, let me tell you without atomic number 6s. Oh, sorry, it's not 4s2, it's 6s2. Sorry, kids, 6s2. Now, we know that D, this is the exceptional case. So D is 1 because it is an exceptional case. An exceptional case. Now, kids, do let me know 3 I have used, only how many are left? To make it 10, to make it 10, how many are left? How many are left, kids? To make it 10, 2 and 1 I have used. How many are left? 7. So what should I write? 4F 7. Can I write like this? Can I write like this, kids? Just check it out, and just check it out. What is the atomic number of gadolinium? Gadolinium's atomic number is 64. 64. If you want to write down, you can write down with the help of atomic number. Just check your NCERT. Everyone just check your NCERT. Let me show you what is written in NCERT. See, let me show you NCERT. This is written in NCERT. Gadolinium. This is gadolinium. 6s2 5d1 4f7. Check it out. This we have written with the help of electronic configuration, atomic number, and there I have told you without using any atomic number. Kids, just see, this is your NCERT, written in your NCERT. See, kids, let me know you are able to understand. Is everyone able to understand, kids? Kids, first of all, your concept understanding is very, very important for me. This is not easy. It's not easy, so I'm asking, kids. It's not easy, that's why I'm asking. If you're not able to understand, I will tell you once again, kids. First of all, let me know you are able to understand or not. How many of you got it? Show me the thumbs up. Those who have understood. Those who have understood, show me the thumbs up. Those who want to understand, show me the hearts. Those who want to understand, show me the hearts. And those who have understood, okay. Now, few students are there, 50% are there, those who are not able to understand. Let me tell you, don't worry. Don't worry. See, kids, do one thing. Do one thing. Do one thing. See, everywhere write down S2, 6s2, 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 2, 2, 2. In everyone write down 2, 2, 2, 2, 2, 2. Let me show you. Let me show you. Don't worry, kids. No need to worry. Baba is there. See, kids. When Baba is there, no need to worry. See, kids. Let me tell you. Don't worry, kids. See, kids. What I'm supposed to write? They all belong to 6th period. So I will write 6s2, 2, 2, 2. Have you seen movie? The computer sound 2, 2, 2, 2, 2. 6s2, 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 and 6s2. This is fine. No exception in 6s2 because already 6s2 has been filled. Already 6s2 has been filled. Now we know that exceptional cases. This is an exceptional case. This is an exceptional case. This is an exceptional case. And In some books, this is also in 11th and 12th is having two types of. We know one thing very clearly, that xenon stands for 54. Now in 54, how much should I add that it should become 58? 4, right? 2 already filled. 2 already filled. Now see, we know that if this is an exceptional case, I will write 5D1. 2, 1 I have already filled. How much is left? 1 is left. So I will write 4F1. Now in this 6S2, it's not an exceptional case. So I will write 5D0. Now 54, how much should I add? 5, 2 already have filled. So 4F. Now if you are able to understand, do let me know. 4F, how much should I write? Those who are really able to understand, do let me know. How much should I write, so that how much should I add over here so that this 54 should become 59? Means differences of 5. 2 I have filled, only 2 have filled. How much should I write? 3. So it is being 3. Now here 6S2, 5D0. Now it is very clear. How much should I add? 2 already added. It is 3. Difference is 6. So 4F4. Now in this 5D0, how much should I write? 4F5. I hope that now everyone is able to understand. 6S2, 5D0, how much should I write? 5F6. Now 5D0, how much should I write? 5F6. Now this is an exceptional case, so I have to write 5D1. So 5D1, if I am writing, how much? Now 5D1 I have filled. I think, is it okay? Everything is going fantastic. It was 54 and this is 63. Differences of 9. 2 I have added. So 7 it was here. This is wrong. It was 7. It was 7. Now 5D1. It was supposed to be 8, but I have shifted 1. So it will be, sorry, it's 4. It's 4, not 5, because 5 is there, 2 less. So it should be 4F, 4F5, 4F6, 4F7, but I have shifted over there, 4F7. It will also be 4F7. This is exceptional case. An exceptional case we know from the trick. Now everyone is able to understand, kids. Is everyone able to understand? You can complete it like this, in this way. Now, my dear students, now just to let me know, are you able to understand? Those who were not able to understand, now let me know you are able to understand. 6S2, 5, it's 5D0, 0. Now 54, 67, 65, 11 I am supposed to add. 2 I have already added. 4F9. It's, now you understood or not? Do let me know, my dear students, or should I complete it? Everyone, you got it? Without atomic number, I have told you. Without atomic number, I have told you. Just add. Okay. So everyone is able to understand. Now see, kids, the configuration also I have given. So you can do it whenever you're getting time. You can just practice it. Whether atomic number has been provided or not, you can do it. Without d orbital filling, because only d one row was there. So F block is just before the elements, and that's why I will let you know lanthanoid contraction, actinide contraction. Lanthanoid and actinide contraction are based on these things only. That I will let you know, kids. Now see, this I have written for you. This I have written for you. You can do it whenever you're getting time. So for each and every element, I have written the configuration, right? Now see, kids. This is for the elements Z above 100, above 100. Above 100 means starting from 101. You must have seen one question has been asked in the NEET examination, that write down this and this IUPAC name, and these elements, I will show you those elements name was not given. Those elements name were not given, means the element which has been asked, its name was not given. Now see, first of all, try to understand, kids. For 0, we know we are going to use nil. First of all, let me tell you, kids. First of all, the most important thing, let me tell you, kids. This is used when atomic number is more than 100. 0 is nil, okay. 1 is un, 2 by, just like in Malayalam or Tamil, you say 1 run moon. Hindi 1 2 3 4. English 1 2 3 4. So in this IUPAC it is nil, un, bi, tri, quad, pent, hex, hept, oct. Only this you have to remember, kids. 9 is, for 9 it is n, double n. This is important. Otherwise, rest of the things you know. And this is nil, okay. Un starting from U, bi, b, tri, t, quad, q, pent, p, hex, h, hept or sept, s, oct, o, n, 9. Only this you have to remember. N will start from E. If you are able to do this much, I'm damn sure you will be able to do the question. Till now, is it clear, kids? Now see how the question will be asked. See, they will give you question like, suppose if he has given, write down bohorium. If the question has been given like this, bohorium's IUPAC name, IUPAC. Kids, will you be able to write down what's the problem? See, in this question, what's the problem? Let me know what's the problem in this question, kids. Where you got stuck, where you are going to get stuck in this question. Do let me know. What is the problem over here? Bohorium IUPAC name. Kids, in the chat section, if you are full on energy, if you are able to hear me, if you are able to see me, tell me atomic number is not provided. The problem is very good. You are able to understand. Problem is atomic number has not been provided. Now, kids, this is really the real actual problem. So we have to cram the elements with their atomic number. And who is going to do that? Who is going to make it possible? Do let me know in the chat section. From 101 to 111, this is the required must condition. From 101 to 111, all the elements with atomic number we have to learn. We have to learn. Who is going to do that? Baba, your Baba. See, kids. See, everyone. See how I am going to do this. I must have made one code trick. See, I was telling you, I have done a lot of homework for you. See, just read it out. If you are able to see it, Mendel got Nobel law. Do you remember where I have told you Mendel got Nobel law? Force PA horse PA has gone to Uranus, Neptune, Pluto. In the AM, came back to California. Einstein has become famous and Mendel has given Nobel Law. Do you remember? Mendel has given Nobel Law. Mendelium, Nobelium, Lawrencium. Mendel has given Nobel Law. Just see. Mendel has given Nobel Law. But Rutherford didn't like it. Rutherford didn't like it. When Rutherford didn't like it, Rutherford gone to Dubai through sea. Rutherford didn't like it. That's why Rutherford gone to Dubai through sea. Gone to Dubai through sea. 3 and 3, 6 elements you have done. Mendel got Nobel Law. Rutherford gone to Dubai through sea. Everyone, Mendel got Nobel Law. Rutherford gone to Dubai through sea. Now, Bohr has gone to market to bring dosa and rasgulla. Bohr was the friend of Mendel. Bohr has gone to market to buy dosa and rasgulla. Bohr has gone to market to buy dosa and rasgulla. Just see kids. All 101 to 100 elements you can see in the sequence. Mendel got Nobel Law. Mendel got Nobel Law. Rutherford has gone to Dubai through sea. Rutherford has gone to Dubai through sea. Bohr has gone to market to buy dosa and rasgulla. Kids, I can't see the Josh in the chats. Kids, such a great mnemonic I made. Otherwise, everyone is going to lose 1 mark, one question of 4 marks, and they are going to get negative marks, means 5 marks they are going to lose. Kids, Mendel got Nobel Law. Rutherford gone to Dubai through sea. Bohr has gone to market to bring dosa and rasgulla. Kids, everyone, this is the first time anyone has made trick for this, kids. Now, if you know that atomic number of Bohr is 107, if you know atomic number of Bohr is 7, then see what you can do. Bohr is atomic number is how much? 100 and Bohr is 107. Now anyone can write, see, 107 Bohr, Bohrium, 107. How will you write? For 1, what will you write, kids? For 1, you will write un. For 0, nil. For 7, sap. Now ium. Un, nil, septium. It is easy or not? Is it easy or not, kids? Now let's see what they have written. Un, nil, septium. Un, nil, septium. UNS. It's clear to all of you or not? Is it clear? And if you want to write down in short, what you are supposed to do? UNS. It's, I can't see in the chat what you want to say. Is it clear or not? Has it been got cleared or not? Did you understand? Have you understood, kids? Easy. Okay. Now we are going to move towards Z effective. We are going to move towards Z effective, kids. This is very, very important. Very, very important. Effective nuclear charge. We are going to see effective nuclear charge. Which you know as Z effective. Now kids, let's make it easy. Here I'm going to tell you about Slater's rule also. I will let you know Slater's rule. Shielding, I will tell you. Shielding also. Number of things I'm going to tell you. Are you ready for it, kids? Shielding, screening, number of things I'm going to tell you. Is everyone ready, kids? Is everyone ready? Show me the green signal if you are ready, kids. Ready. Everyone is ready. Now see. First of all, I would like to ask kids one question, that this is the sun. Let's take, this is the sun. This is the sun. Just answer my question, then only you will be able to understand, kids. This is the sun, right? And it is giving sun rays. It is spreading out sun rays. Sun rays are going like this. They are going like this. They are going like this. They are going like this. And it is being sun. This is being sun. Sun is the ultimate source of energy, and these lines, they travel in a straight line in the form of packets and like that. Now see kids, if I say there is one cloud, there is one cloud, the cloud is like this, there is one cloud, and the cloud is like this, kids. The name of this cloud is and it is having some small like this, okay, bigger one, smaller one, through which sun rays can get passed. The sun rays can get passed the sun rays can get passed. Okay, the cloud's name is S. This cloud's name is S. S cloud. S cloud. There is another cloud named as P. There is another cloud named as P. P cloud. This is being P cloud. This is P cloud. Name is being P cloud. There is another cloud named as D cloud. D cloud. D cloud. This is G cloud, kids. Now there is one more cloud. Its name is F cloud. F. F cloud. Name is F cloud. Now kids, which cloud is going to stop maximum sun rays? Which cloud is going to stop maximum sun rays? There is one boy. There is one boy. This boy's name is Ramu. Ramu is standing over here. And there is Alia. Alia is standing over here. This is Alia. The sun rays are coming through this cloud, these sun rays are coming through this cloud, and these sun rays are coming through this cloud. Who is getting more sun rays, kids? Who is getting? Yeah, yes, this cloud is unable to stop. This cloud is unable to stop sun rays. Very less shielding. Shield, if someone is going to fight and someone is going to attack through the sword, and if the shield is not good, the kavach, the shield they are wearing, if not good, then that person is definitely going to die. Spider-Man, He-Man, the people are having that, which man is there? Some Iron Man is there who is going to use that shield. That lady is there. I don't remember the Avengers movie. I have seen some hero is there who is going to use that shield to protect himself, or that lady is going to use shield to protect herself. So the shielding of F is very, very poor, and the shielding of S is good, and P is also good. Everyone able to understand that this Alia is going to get more effect of heat, and the Ramu is getting less heat. The result is Ramu is getting least heat. Ramu is getting least heat, and Alia is getting maximum heat, maximum sun rays. So what I am going to tell you, in the chemistry, I will consider in place of sun the nucleus, because in the nucleus there is proton which is having positive charge, and the electrons are moving, outermost electrons. Let me tell you what I am going to consider. These peoples have considered they are like electrons, and the sun is like nucleus. Nucleus is putting force on the outermost electron. So my dear friends, if I say sun is giving X amount of heat energy, sun is giving X amount of heat energy, is Ramu getting X amount of heat energy? Is Ramu getting X amount of heat energy? No. Ramu is getting X minus Y, and Alia is getting X minus Z or something. But this, whatever I'm going to subtract, this is big amount, and here I'm going to subtract S minus, that is not that big. Are you getting my point, kids? Everyone able to understand? This value is bigger because it has been stopped. It is acting as good screen. It is acting as very, very good screen. The curtain is good. This is acting as very, very poor screen. So kids, if I say the screen, the protection power, whose screening effect is better, kids, what will you say? What will you say, kids? Whose protection power is good? My dear students, do let me know whose protection power is good. SPDF, who is going to act as better shield? Definitely S, then P, they are good. But if I talk about D, bad, and F is very, very bad. Very, very bad shielding effect. That shielding is very, very poor. This is the power of shielding, the best screen I can say. This is acting as best screen. Best screen. This is acting as poorest screen. Poorest screen. Am I right, kids? Their screening effect is very, very poor. Screening is known as shielding. Screening or shielding, same word. Poor, and their screening is good. Good screening. Now, if you are able to understand this much, then do let me know. Then only I can teach you. Then I can make you able to understand. First of all, do let me know, everyone. I will come to the attractive force, Z effective, Z minus something constant. But first of all, if you are able to understand this much, say yes. I want to see something in the chat section so that I can understand. You are far away from me if you're not writing anything in the chat. So to read out the chat, it's not easy. So only symbol we can see. If this much is clear, show me the hearts, thumbs up, fire, whatever you want to say. Keep on showing, kids. No need to say again and again. I will continue over here. Just I want to see that yes, everyone is able to understand. Now, my dear student, if this thing is clear to all of you, then I would like to say, just see. Now let me come to the nucleus. Let me come to the nucleus. This is your nucleus. This is your nucleus. And in the nucleus, there is proton. There is proton. Let me take an example. Whatever example you say, I will take that element. I will consider that element. Just to let me know. Any element you take, I will take that element. Just write down any element. I will explain with the help of that element. Write down in the chat section. Any element's name you can write. I will explain with the help of that element, kids. Then I will tell you all the elements. But first of all, just for the start, do let me know any element. I will start with that element. See, kids. You just write down potassium. Okay, potassium. This is potassium. What is the atomic number of potassium? Atomic number of potassium is how much? 19. So 19 protons are there. That is positive charge. This is positive charge. Consider this protons like king. Very good example you have taken. Consider it like king. This king. Okay. Let's take K as king. The protons, this much force of attraction is there. Now see how many orbits are there. How many orbits will be there, kids? First orbit, second orbit, third orbit, kids. How many? Fourth. In the fourth, one more orbit. Let me take one more orbit. Fourth orbit, right? Okay, kids. Is it okay? Now, in the first orbit, how many electrons are there? 2 electrons. 1 electron, 2 electrons. Before writing on that side, this electron you can consider like Rani. In every language, Rani is like Rani only, except English. Whether it is Tamil, it is Malayalam, Hindi, Gujarati, Bihari, any language you can take, its Rani is Rani. Its king, that is Rani. Okay. Now, king is loving. There is force of attraction towards this Rani. It will put force of attraction. Am I right, kids? King will put force of attraction. Here also force of attraction. Force of attraction, force of attraction. Force of attraction, force of attraction. But in Rani and Rani there will be. But in between two Ranis there will be what? In between these two Ranis there will be repulsive force, force of repulsion. Till now everyone is able to understand. Is it clear? Now 2 electrons, then I will write down 8 electrons. Then I will write down that 2s2 and 2p6. 6 to 8 to 10. Then 3s2, 3p6. And last 4s1. I will write down 4s1. 4s1. So, what do you think? What do you think it's? Is this king able to put that much force of attraction, or its force of attraction will decrease because it will pass from here, it will collide. See kids, these Ranis, 6 Ranis, 3p6 Ranis, and number of others, 3p6, and I'm going to write 4s1. So if I consider this Rani, this electron, what do you think? The force of attraction will be more or less gets, it has to go over there. Very less force of attraction this electron is experiencing. Are you getting my point? Now suppose if no other electrons are present over here, no other electrons. See, if I write down just like, for example, if I write down, for example, sodium 10. If I write down sodium 10, sodium 10 plus. If I write sodium 10 plus, then how many electrons are there? 10 plus 11 is the atomic number. Only one electron. That means I will write down the nucleus. I will draw the nucleus. 10 positive charge, no, 11 positive charge, 11 protons. But in the first orbit, second orbit, third orbit, fourth orbit, whatever the orbit, if I say, there is how many electrons? Only one electron is there, and the whole force of attraction is felt by this. So this force of attraction's magnitude will be more or less no repulsion, only attraction. There is just force of attraction, only force of attraction. So whatever there's a nuclear charge, the same charge this electron is feeling, nothing is getting subtracted. The nuclear charge, the whole proton's charge is felt by this electron, so there is no loss. So I will say Z effective nuclear charge is equal to Z only, because there is no repulsion, no repulsion. So for electron, single electron system, Z effective for single electron entities, Z effective, that is effective nuclear charge, is equal to Z only. But if I talk about for others, then Z effective is somewhat less than Z, and this something which is subtracted, this is known as Slaters constant. Agreed, kids? Are you agreed? For other elements, we have to subtract this something. That means Z effective is equal to Z minus this something, and this something we have to subtract, because of this is due to force of repulsion, due to force of repulsion is another thing. They are acting as shield. They are not allowing, these electrons are not allowing the whole nuclear force to go over there. They are cancelling out. Just like if we are getting rupees, money, any grant from bigger system, and it's coming less amount, the farmers are getting less amount, the rest of the money is in the air, so they are not getting the whole amount from where it has been started. So this is due to shielding of these electrons, due to the something has been subtracted due to shielding of electrons. Which electrons? Which are in between. Suppose if there is extra electrons, some electron is moving here, some electron is present outside like this, they will not cancel any force, because this and this, there is force of attraction in between this and this. They are outsiders. Outsiders has nothing to do. Suppose if I am going to calculate the force of attraction by this nucleus on this electron, then 4s1 electron has nothing to do. If I want to calculate in potassium the Z effective on 3p6, then 4s1 has nothing to do, means right hand side one or the outsider electrons has nothing to do with this something. This something is known as sigma constant, or this is Slaters constant, Slaters constant, or screening constant, or shielding constant. It's everyone, what I have told you, don't show any divergence, kids. I'm making these many efforts for you, kids, and I want to see each and everything crystal clear in the chats. First of all, do let me know, is everyone able to understand this we have to subtract and this we have to calculate, because Z is fixed. This is the atomic number. This is always fixed. I will give you the written notes also. I will give you each and everything. But first of all, everyone, do let me know that is everyone able to understand whatever the electrons in between nucleus and the test electron. This is known as test electron. Testing on which we are going to calculate. Test electron means the electron on which we are calculating Z effective. Z effective, that is test electron. So kids, do let me know. I will tell you screening constant. How to calculate, I will let you know. I will tell you each and everything. But first of all, do let me know, is the concept clarity is there? What actually we are going to calculate? Now see, kids. Everyone see, Z effective that is effective nuclear charge. Effective, why I'm saying effective? Because something has got cancelled out. Effective nuclear charge is equal to Z, that is atomic number, minus this sigma. This is known as screening constant. Either you can say screening constant or you can say shielding constant, or you can say Slaters constant, Slaters scientist constant. Now, what is this sigma? Let me show you the picture from where the story has been started. See, the sun was spreading its ultimate source of rays, but this Ramu was not getting all the rays. Some rays were captured by this screen. So sun was spreading X amount of heat energy, but Ramu is not able to get X amount of heat energy because some heat energy was captured by the screen S subshell. So it is getting less amount, and this I want to tell you, this is sigma. The Alia was getting more heat, but not the whole amount, because this is F diffused. It has also cancelled out a little bit amount of heat. So this is sigma. So this is getting more heat, so more effective nuclear charge. This sun is giving more heat, the sun is giving less heat, less effective nuclear charge. Now the value of sigma is more, this value is more. If this is more, then Z effective will be less. Z effective means the effective heat. This is giving X amount of heat, but this Ramu is not getting the whole amount of heat. The effective is this much. Something got lost because that has been captured by the screen. It's if the value of sigma is more, Z effective will decrease. the value of sigma is less, the Z effective will be more. One thing is clear. Are you getting my point? Everyone, do let me know, kids. I can't see the fire, the Josh. It's looking like one way. It's looking like one way. First of all, do let me know, then only I can tell you if it is clear. At least try to show me why I'm begging for the thumbs up, likes. Once if it is clear, just like you must have heard stories from grandpa, grandmother, whenever they are going to tell you a story, you have to say, yes, papa, I'm able to understand, mama, I'm getting it. You are doing like that. If somebody is going to tell you a story, grandpa, grandfather, then in between you have to say, meanwhile, yeah, yes, eventually I'm getting it. I'm able to understand like that. Now, see kids, just see this table. I made this table. Anything you are able to understand, this table I made for you. Just see this table. Anything you are able to understand, do let me know. Are you able to understand? For S and P, it's different. For D and F, D or F, it's different. I will explain it. I will explain it. I will solve the numericals. I will tell you the tricks. But first see this table, everyone. For S or P, when the electron in the same shell, its contribution is 0.35. That means it is acting as screen. It is absorbing that nucleus charge. The value is 0.35. Other than the test electron. Suppose in the outermost shell, there are 4 electrons. Then one is the test electron, rest of 3 are the friends. Now n minus 1, they will act as 0.85 because they are more closer to the nucleus. If any electron which is more closer to the nucleus, its screen will be more. If you have gone to watch any movie, if someone is standing just on the screen, see kids, if I'm standing over here, see, this is nucleus. Let's suppose this board is nucleus. If I'm standing over here, you can see this much part of the board, right? Now, if and you are the nucleus, this is not the nucleus, this is test electron, right? This is test electron and this camera is the nucleus. Now, if I'm standing away from the camera, most of the part you can see, only some part is not visible. Now see, I'm coming close to the nucleus. Just see, I will act as screen. As I'm coming close, most of the portion you are unable to see. Now, if I'm coming very close, now tell me how much board you are unable to see. Now see kids, I've come over here. Now I'm very much close to the nucleus. Now only a small part of the board you can see, only very small part of the board you can see. Now as I'm going away from the nucleus, so the screen, I was a screen. In between you are the proton and this is the test electron. In between you and this, I was the screen. As the electron are nearer to the nucleus, they are giving or more effect as a screen. Got it? So rest of other electrons means n minus 1. After that, their contribution is 1. Right now, leave this. This I will explain later on. First, focus on SP. Is it clear? Just focus on sp. N is the orbit. The meaning of N is nth shell. N is nth shell. Nth shell, orbit. Now, should I explain? Should I explain by taking example? Should I explain by taking example? Suppose if I'm going to take an example of magnesium. Let me take an example of magnesium. Okay, are you ready? Are you ready? Let me take an example of magnesium. This is magnesium. 12 protons. Now, orbits. First orbit, second orbit, third orbit. In the first orbit, we are having 1s2, 2 electrons, 2s2, 2p6, and 3s2. Is it okay? Is it okay? Now, if you want to find out the Z effective on the outermost electron, so just select any electron. If you want to find out Z effective on this, Z effective on this electron, so this is your test electron, means on this you are going to find out. Now if you want to find out effect on me, I will not act as screen. Rest of other electrons in between nucleus and this, they will act as screen. Even this electron, because electron has wavical nature, sometimes this electron will move from here, sometimes this electron will move from here, so this will also act as screen. It will also act as screen. Now leaving this test electron, rest of all they are acting as screen. This is screen, this is screen, this is screen, this is screen, this is in the same orbit, nth orbit, this is in n minus 1th, and this is rest, n minus 2 is rest. So what is the contribution? Its contribution is now 1, 8, this one electron's contribution is how much? This one electron, 1 into 0.35, 8 electrons, 8 into 0.85, and these rest of 2 electrons, 2 into 1, just add them. This will be your sigma. This will be your sigma value, Slaters constant value. 1 into 0.35, 2 into 1, 2, 8 into 0.85 plus 0.35. Now 8 5s are 40. Just apply your maths if you know maths. 8 5s are 40, 0, 8 8s are 64, and 4 68, 6.8. I am getting 6.8 and 2 8.8 and 0.35, 8.8, 8.80 and 0.35, 0.35, it's 5, 11, so it's 8311, 9.15. I'm getting 9.15, right or wrong, kids? Just check it out. I'm getting, okay, you are saying there is no electron. It's not plus 12. It's not magnesium 12 plus. Oh my God. It's this I have written. This is magnesium. This is magnesium and its proton number is 12. Magnesium, it's not magnesium 12 plus. Without electron, how you will? Protons are 12. Somebody is writing in magnesium 12 plus there is no electron. It is like this, kids. It is like this. Protons are 12. Now I have calculated 9.15. Just calculate, everyone. 2 plus 8 into 0.85 plus 0.35 is coming 9.15 or not? Everyone, say, what are you doing, kids? You are not showing it fast. Calculation. Kids, everyone do let me know. I'm not able to see your answer, kids. Your calculation is slow or you're not paying attention, kids. Either your calculation is slow or you're not paying proper attention, kids. Do let me know what's the reason. I want the answer. I want the answer whether my calculation is right or wrong, kids. Do let me know fast, quick, quick. My calculation is right or wrong, fast. Do let me know. 9.15. So how much should be the Z effective, kids? What should be the Z effective? Do let me know. The Z effective will be, then the Z effective will be atomic number minus sigma, that is 12 minus 9.15. How much it will come, kids? How much it will come? 12, 9, 9, 2.85. According to me, it should be 2.85. Kids, see, is it coming 2.85? 75, somebody is writing 75. Somebody is writing 3.15. Kids, what is your maths? Someone is writing 2.75. Someone is writing 3.1. Kids, you don't know how to apply maths? Your maths is weak, kids. Now, should I calculate another one? Should I calculate another one? Should I calculate another one, kids? Just give me any element. Just give me any element. Kids. No, kids, don't do like that. See, if you are going to subtract 12 minus 9, if you have subtracted 12 minus 9, it should be 3, but 0.15 more, so it should be less than 3. One more example. Okay, see, in the form of question I am going to give you. See, first of all, this is the question. This is the question for you. See, first of all, do let me know what should be the answer. Calcium, I will explain. I have already explained. No, I can't move to the another topic. Let me tell you this in detail. Tell me the answer of this question. First question. I want to see the answer, kids. I want to see the answer, my dear students. So, here is your answer. Hip, hip, hooray. You are the winner, winner. Now, winner, you are the winner. Now, let's see another question. Another question. See, can you see this question? Calculate Z effective for electron in 4s subshell of iron. Now what to do, how to do it? Should I solve it? Should I solve it? See, kids, how to do it? See, kids, first of all, I have to write down the configuration for iron. What should be the configuration for iron? See, iron's atomic number is 26. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2, right? This is the electronic configuration of iron. Now out of these two, 4s subshell, out of these two, one is test electron. So suppose this is one electron, this is one electron, one will be considered as test electron. Now, in the same orbit, how many electrons or how many electron has been or have been left? How many electrons has been or have been left in the NH cell? In the same cell, how many electrons are left? Only one electron. So in the NH shell, the contribution is 0.35. Is it okay? Now, these are n minus 1. These are in n minus 1. Their contribution is 0.856, 6 and 2. How many are they? How many are they, kids? 6, 6 and 2. How many? How many are they? Just do let me know, kids. Do let me know. How many are they? Kids, where it's gone? Where it's gone, kids? Yeah, it's over here. How many are they? 6, 6, 12 and 2, 14. Their contribution is how much, kids? 14 into 0.85. Now, kids, most of the students will be there who can't remember the value. How many of you want to remember the value? See, I have given one quote. I have not focused over there. I have given quote. See, she and he, he, he. For remembering 0.85, there is one code he. What is he? In English, A, B, C, D, E, F, G, H. Just see. A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H. Just see, kids. 1, 2, 3, 4, 5, 6, 7, 8. So see, E is 585, 0.85 he. And to remember 0.35, 0.35 she, pointer she, pointer he, pointer she, pointer he. Is it helping, kids? I want to see in the chat section, is it helping, kids? What you have started, sister ask her, my dear students, this is not good. Kids, if you're doing like that, the whole efforts, each and everything, kids, how much hard work Baba is doing, kids? How much hard work Baba is doing, kids? What are you doing? This is she, this is he. See, he. How many tricks I am giving? You can't appreciate, kids. What is this? You are busy. Kids, how many tricks Baba is giving? She, he. Just to remember, pointer she, pointer he. Pointer she, pointer he. Just see each and everything. Let me show you first. Let me show you how much homework I have done. See, kids. See, then I will tell you the calculation. Slaters rule. Slaters rule to know screening constant. Screening constant. How to calculate electronic configuration must be in the following order. This is the way, and the way you are supposed to write down the electronic configuration. See, can you see the slides? I'm writing so that it should go directly in your brain. See how good the slide is. Now see, latest rule to know screening constant. Screening constant for S and P. Electron in any group to the right of the NS and P group contribute nothing, which is outsider. Outsiders contribute nothing. This is not secrets to the shielding constant. All electrons in the NS and P group shields electron to an extent of 0.35 except for the 1s. For example, hydrogen 1s, that I will let you know later on. Now see, for S and P, all electrons in n minus 1s shall shield and extent of 0.85 each, strict like pointer he. Now, for D and F, I will tell you later on, right now, otherwise you won't be able to understand. For single electron entities like hydrogen, helium plus sodium, 10 plus magnesium, 11 plus, etc., sigma, this value is 0, so Z effective is 0, Z effective is equal to Z minus sigma, that is 0. See the slides. Whatever I'm telling you while writing, I could have done this, kids. See, the slides I made for you, handwritten slides without any error, kids. Zero error, zero error, zero error. See, kids, I could have shown you like this. I could have taught you like this. Have you seen the slides? How much homework I have done for you just to save your time, just to save your time. Now see, screening effect, this we have done. This we have done. Now the question was like this. We were over here. 14 into 0.85. Now, these are rest of other electrons, 6 to 8, 10. 10 into 1. Just add them. 10 plus this plus that. So let me show you. I've done the calculation for you just to save your time. See, 10 into 1 plus 14 into 0.85 plus 1 into 0.35. This is 10. This is 11.90. That is 0.35. So it is coming 22.225. But this is coming the value of sigma. This is the value of sigma, Slaters constant. But Z effective will be atomic number minus sigma. 26 minus 22.25, 3.75 is the answer. I could have done this. I was telling you each and everything while writing so that you can understand. Otherwise, see kids, 3.75 is the answer. 3.75 is the answer. Can you see? And this is the answer. This is another question. I will let you know. But before that, you should know 3.75 is the answer. First of all, do let me know how many of you are able to understand. If yes, if you have understood it, show me the thumbs up. Fast, 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 everyone. Now, kids, very good. Everyone is able to understand. Now, this question is tough. This question is really tough question. This question is tough. Should I tell you why this question is tough? Should I tell you why this question is tough? Should I let you know? Darshani is asking 14 into 0.85. How much? Darshani is asking 14 into 0.85. Just see, 14 into 0.85. Do the calculation. See, 14 into 0.85. How much it is coming? Do it, kids. 14 into 0.85. Darshani, just see the maths. 14's table of 14. You will get it. It's accurate. Absolutely correct. 11.9. It's 11.9 only. Darshani, it's 11.90 only. Baba is awesome in calculation. It's correct. Baba is awesome in calculation. Now see, kids, what I was telling you. This question is tough. Why this question is tough? Should I tell you? Should I tell you? See, what was the rule? The rule was for D or F, because their shielding is very, very poor. For D or F, 0.35 and after 1. For here it was n minus 1, 0.85, but here it is 1. Can you see? This is the rule. Here For S and P in n minus 1 it was 0.85, but for D or F it is 1. Are you able to understand? Everyone able to understand, kids? And one more thing, you have to follow this grouping. How to write down the electronic configuration. While writing electronic configuration, the grouping matters a lot. Grouping is very, very important. How to group secrets. This is very, very important. How to group. SSP, I'm HSP, I'm HSP, S and P will remain all together. SP, SP, but D is not having any group. See, D is not having any group. Let me show you. Somewhere else also I have written this thing. Somewhere else also have written this thing, kids, that how to write down the, how to group it. Okay, see, this was the first rule only. S, SP, SP, but D is not having any group. SP, D is not having any group. F is not having any group. D, duffers, they don't have any group. Duffer, do remember the trick. D and F, D and F, duffers. HSP, SP has group, but duffers don't have group. D and F, D and F, they are not having any group. They are alone. They are solitary. They are alone. See, kids. Now, if you are able to understand, then I will let you know how to do that question. That question is a bit tough. If you are going to do any mistake, you won't be able to do. See, kids. This was the question, and its solution I'm going to give you first while writing. See, kids. Iron 26, 1s2, S2, 2p6, group them, they are the group. Now 3s2, 3p6, they are also group. Now 3d6, 4s2, 4s2 will have no contribution. You have to understand no contribution. Why? They are on the right hand side. So in between the nucleus, this positive and D, these electrons will shield. That has nothing to do with the shielding. If this point is clear, then see the grouping. This is considered to be its orbit. They are not in their orbit because grouping is different. Don't say they are in the same orbit, because this is one group, this is one group, this is one group, this is one group, and that is its nth shell. That will be counted as its nth shell, and these will be counted as rest of others. These will be counted as rest of others, and this is the magic. These are rest of others. Now out of 6, 1 is test electron. Just 6 minus 1, 5 are in the nth shell, and their contribution is 5 into 0.35, and rest of others contribution 6 to 8, 10, 16 to 18 into 1, 18 into 1 plus 5 into 0.35. This will come out to be 5 5s are 25, 2 5 that is 15, 17, 1.75. Am I right? 18 plus 1.75 is how much? 10, 5, 7, 9, 19.75, 20 minus 26 minus 19.75. Just check it out. Am I right? Or now see, kids, I'm absolutely correct. This is the calculation. See, I have done for you. 26 minus 19.75, 6.25 is the correct answer. See, kids, this question was a bit tough. Kids, how many of you are able to understand? Do let me know, kids. Everyone, do let me know, kids. This, see how much hard work I have done for you. Everyone is able to understand, kids. Do let me know if you are yes, able to understand. Do let me know, my dear students. Again and again, I'm asking, kids. You are taking too much time to give the reply. Hey, everyone. Don't take too much time. This is not to every action. There should be equal and opposite reaction. At 11, I will give you. At 11, I will give you break. Now see, kids. See. Here is one question. Just see to it. Awesome question. Let's see how much you are able to understand. How much you are able to understand. What should be the answer? Let me move aside so that just think this is your examination question. What's the correct answer? Yes, yes. Maximum students are going for 3, that is C. Some are going for D. C is the correct answer. Congratulate yourself. If your answer is found to be correct, congratulate. Yes, yes. Fantastic. See, screening effect of D is less than of P, less than of S. S is missing, so less than of S as well as less than that of P. D's screening is better than F. We can say D's screening is better than F, so less than P is right. That's the correct answer. Now see, another question. Yeah, one more question. See, kids, such a great question. See, what's the answer? Now this question can be solved by everyone. C is the correct answer. Fantastic. I'm happy with your answer. C is the correct answer. Fantastic, kids. Now this, here is another question. Here is being another question. What is the answer of this question? These are the questions which have already been asked in different examinations, whether we talk about AIMS, NEET or JEE. These have been asked. So this, oh, where it's gone. D is the answer. D is the answer. D. If you're not able to understand, should I tell you? Oh, I think question got changed. I think question got changed, kids. Oh, just wait. Just wait. I think question got changed. Sodium. No, according to Slaters rule, that is another question. This was another question. Okay, kids. This question was different. No, this is another question. This question, where it's gone. Oh my God, it's gone. Now see, this is the question. According to Slater's rule, jet effective in group. This is very tough question. Very tough question. Its answer is D. How many of you want to understand? This is really tough question, kids. This is a really tough question. How many of you want to understand, kids? How many of you want to understand? Show me thumbs up that if you want to understand. Fourth is the correct answer, and let me show you. Let me show you the table for this. I made one table. See, kids. Just see. Just see to it. If you are able to understand this table, then any question of the world you can do. The ionization energy, the electron affinity, the electronegativity, everything you will be able to do. See, kids. lithium 1.30, then sodium 2.20, 2.20, 2.20, 2.00, constant. Beryllium 1.95, then 2.85, 2.85, 2.85, 2.85, constant. 8.25, 8.25, 7.60, 7.60, 6.95. So generally it is constant. It's not always constant. 1.95. So generally it is constant. Now, how many of you want to calculate jet effective without applying any Slaters rule? You can calculate. It will come like this only. If you calculate the rule which I have told you, if you want to calculate, you can calculate. It will come this much only. But without applying Slaters rule, without any calculation, how many of you want to calculate jet effective? Show me the thumbs up or the hearts or the fire. I will tell you the trick. Baba will tell you the trick. Then all the questions of ionization energy, electron affinity, electronegativity, you can solve without any problem. Everyone, okay. Everyone wants. See. Just remember 0.65, magic number. And if you are not able to remember this 0.65, let me tell you. If you're not able to remember this 0.65, 0.65, if you're not able to remember this magic number, let me give you the trick. Trick for trick. See. A, B, C, D, E, F, E, H. 1, 2, 3, 4, 5, 6, 7, 8. This 6 is what? F. F. And the 5 is what? E. Fe. Just remember iron. Fe is iron. Just the Iron Man will help you. This Iron Man will help you. Iron Man. Pointer Iron Man. Iron Man. What type of Iron Man? Pointer. Pointer Iron Man is going to help you. Pointer Iron Man. Pointer Fe. So this will help you to remember that 0.65. Is it clear? Kids, once again, is it clear? Now, if you are able to remember this 0.65, that see 1.30 at 0.65, 1.95 at 0.65, 2.60, 0.65, 0.65, 0.65, 0.65. Directly, if you want to go from here to there, 1, 2, 3, 4, 5, 6, 6 into 0.65 and add to this, you will get that answer. 2.20 at 0.65, 2.85 at 0.65, 3.0 at 0.65, 4. We'll get this. See kids, it's working. It's working, kids. See kids. Now you are able to find out all these, and these are constant. These are constant. No need to calculate. No need to calculate. And if you are not able to remember this value, Baba will tell you how to remember. Baba 2, B, A, B 2, 2.2. Baba, just remember HSP Baba. Just remember HSP Baba. So 2.2, add this. 2.2, add this, you will get the answer. Kids, are you getting it? Everyone, just to let me know. Is everyone able to understand? Is everyone able to understand? Now see kids. If yes, then see. If you have seen this table now, try to do this question. Try to do now. Let me show you, otherwise once again you won't be able to do it. From where the value constant started. The constant value has started from Na. Na, soda and Maggie. The constant value has started from soda and Maggie. Do remember, from soda and Maggie. Soda, potassium, rubidium, they all are having constant. Lithium is having less, sodium is having more, then they are having constant. Beryllium is having less, magnesium is having more than constant. Soda and Maggie, soda and Maggie. Now come to this question. Let's see, will you be able to do it or not? Yes, here is your question. Here is your question, kids. Here is your question. Everyone, see to it. Let's see, kids, whether you will be able to do it or not. Everyone. Now, let's see whether the tricks are working or not. Yay! Tricks are working. Soda and Maggie. Soda, Maggie, potassium, below sodium, it's constant. It's constant. It's constant. Now, see. Now, kids, this I have given to you. This rule of 0.65 will not be valid over here. So they are having abrupt on moving from left to right. Generally, Z effective increases. On moving from left to right, generally Z effective increases. See, in the S&P, you have seen that it was continuously increasing. See, 2.2, 2.85 in the S block and P block, it was continuously increasing. But in D block, the Z effective is having not the regular order, abrupt values, no uniformity. See, 3.2 less, increasing, less than increased. So no constant values. So the values are abrupt, they are getting changed. Now see, kids, this is the question. This we have done, I think. No, we haven't done it. Just do let me know. PD is period. It's not Pandeji, it's period. PD means period. Just try to do it. Try to do this question. Let's see how many of you are able to do it, kids. A and C. There is some are saying A, some are saying. Let's see. B is the answer. Oh, Z effective increases down the group. Z effective increases in it. Oh, this is wrong answer. B is wrong, kids. B can't be the screening effect increases down the group. Oh my God. So this can't be the answer. So what is the correct answer, kids? This can't be the answer. Let me rub it. This can't be the answer, kids. Oh, gone. This can't be the answer. Oh, once again it's gone. So what should be the correct answer, kids? Just do let me know what should be the correct answer. Which statement is false? This is the answer. This is the only answer, because they have not asked which is correct. They have asked which is incorrect. False, false, false. So this is the correct answer, because this is only false. Z effective increases down the group generally, because it was constant. It was generally constant. Now, how many of you have not seen this false? It's how many of you have done the same mistake? How many of you have done the same mistake? Which statement is false? Screening effect increases down the group. This is correct. Why this is correct? Because number of electrons will increase. More electrons, number of shells will increase. Number of shells increases, so number of electrons increases, so screening will increase. Agreed? This is correct. This one is correct. This is not false. As you move down the group, in each group, number of filled shells will increase. So number of electrons will increase. So definitely screening, it's not jet effective, it is screening. Screening means more the electrons, they will act as obstacle. When they are acting as obstacles, so they will act as more screening effect. It's, are you getting it? Got it? Got it? Now, let's see. Z effective is directly proportional to positive charge and inversely proportional to negative charge. Absolutely correct. We can talk like this. Z effective is directly proportional to protons, more the protons and less number of electrons, inversely proportional to electrons. This is correct. Are you getting my point? If there is positive charge, that means less electrons are there, less electrons are there, less electrons are there, less screening will be there, less screening is there, less will be the value of sigma, less is the value of sigma, Z effective will be more, because something which is getting subtracted, that value is less. So definitely this is correct. Got it? Everyone is able to understand. Now see kids, Z effective for isoelectronic species, entities. Just read it out. How much you are able to understand, do let me know, then I will explain. Then only I will explain, kids. Do let me know how much are you able to understand, kids. See, isoelectronic entities, all they are having, okay, let me check it out, 2 electrons, 2 electrons, 2, 2. So all they are having 2 electrons. This is having less proton, more electrons, so repulsion will be more. Repulsion is more, so Z effective will be less. See, its protons, King's power is more, but kaons are less, Ranis are less. So the nucleus will attract the outermost electron, or you can say it is having less electrons, so repulsion is less. But nothing to do with the repulsion. Screen, less electrons, less screen, less screening constant, less value of sigma, more will be the Z effective. Everyone, are you able to understand? Isoelectronic means having same number of electrons. Isoelectronic entity means having same number of electrons. Having same number of electrons. Kids, if this is clear, now this is 10 electrons, 10 electrons, 10, 10, 10, 10. So see, this is having less electron, more proton, less electron. See, I've told you this rule. This right now I've told you, less electron, more proton, Z effective is directly proportional. Everyone is able to understand. I hope that everyone is able to understand, kids. Now, oxides, fantastic. Kids, now in this you can call everyone, call your friends. What I'm going to tell you, this is a question. This is the concept which holds a hell lot of weightage. Everyone was waiting, world, the whole world is waiting for this topic, oxides, amphoteric oxides. Kids, kids, are you ready? I'm going to give you the trick for it. Are you ready, kids? Hey, everyone, just tell me, is everyone ready? Is everyone ready, kids? Now see, amphoteric oxides, amphoteric oxides, just a second, kids, just a sec. Okay, kids, see. Amphoteric oxides are those oxides which can react with acid as well as bases, both. Now see how to remember these oxides. These are 1, 2, just remember 3 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus, and this is written all oxidation state, means 1, 2, 3, 4, 5, 6. These six elements in any oxidation state, means in all oxidation state. For example, if I say tin, so tin, whether it is in 2 plus form or it is in 4 plus form, lead in 2 plus form or 4 plus form, in all form they will form amphoteric oxide. That means if I write SnO2, SnO, PbO, PbO2, in all oxidation states, these six elements will act as amphoteric oxide, but these only in +3, but vanadium in +5, manganese in +4, and tellurium in +4. Now, how to learn these elements? Now, see, kids. Can you see anything? Can you see anything, kids? Aishwarya Auntie, and this is Amitabh, Big B. Why I have taken Big B's pick? Amitabh, AM, amphoteric, Amitabh, amphoteric. So Amitabh is with Aishwarya Auntie. Now Aishwarya ji is having a baby, so she is you can say Aishwarya Auntie. Aishwarya Auntie and Carrie Minati, you know Carrie, C-A-R, Carrie Minati. Aishwarya Auntie and Carrie Minati, kids. Who is going to make such type of trick? Nothing extra is there. Aishwarya Auntie is antimony. Carrie Minati, kids. At least show some gestures, show some gratitude. Kids, no one is going to give you such type of trick, kids, in the whole world. This is only Baba. This is only Baba's creativity, kids. And see the rhyme. Aishwarya Auntie, Carrie Minati. Aishwarya Auntie, Carrie Minati, amphoteric oxide. Aishwarya Auntie, Carrie Minati. Kids, are you liking it? Are you liking my efforts? Kids, really nowhere you are going to get such type of fundamental tricks. No one can give you. And after this day, you will see such type of pics, videos, short videos. Everyone is going to use this. This video is going to be viral, kids. I'm damn sure this video is going to be viral. I'm damn sure, kids. Now, see, Aishwarya Auntie Carrie Minati, got irony victory. We always take pick like this, V for victory. Aishwarya Auntie Carrie Minati got irony victory. Now, on whom? On jungle's best son is Prabhu. You know Prabhu Deva or Prabhu, God. So there was a movie, Jungle's Best Son. See, jungle, nothing extra is there. Jungle, Z-N-G-L, Jungle's Best Son. In the which song? If I say one singer is there from outside India, means abroad singer. I don't remember. He is going to eat tea. He is not going to say tea. So best son. In Hindi, if you say basin, jungly basin. In Hindi, you can say jungly basin. Otherwise, jungle's best son, Prabhu. Aishwarya Auntie Kariminati got irony victory on Jungle's best son Prabhu. This is the movie in which Prabhu is the hero and he is the best son of jungle, the protector of jungle, best son. Aishwarya Auntie Kariminati got irony victory. The movie is Jungle's best son Prabhu. Jungle's best son is Prabhu. Yeah, ground floor, basin, that is basin. So you can say jungly basin. It's everyone is loving it. Now the studies are looking like games, looking like rhymes, looking like song. Ashuryanti Kariminati got irony victory. Ashurya Auntie Kariminati got irony victory on Jungle's best son Prabhu. Jungle's best son Prabhu. Oh my God, this much of love, kids, this much of love. Baba is really happy. Everyone, if you're new to this channel, subscribe this channel, and those already who have subscribed, hit the like button, kids. I want to see more and more likes. Your Baba is greedy about the likes, kids. The first time I am seeing this much of love from your side, kids. Really awesome, really awesome. Oh my God, how many are new and how many are enjoying it? At 11, I will give you the break. At 11, I will give you the break. Baba is miracle. Thank you, thank you. Oh my God, thank you. Now, after this, see, acidic oxides. As the oxidation state increases, remember that, as the oxidation state increases, acidic character of oxides also increases. So if we go down the group, the basic strength increases, acidic strength decreases, and we go from left to right, acidic strength increases. Now see, neutral oxides with oxidation, no, metal oxides with oxidation state 5, 6, 7, they are acidic. Just leave vanadium oxide. Vanadium is an exceptional case. V2O5 is amphoteric. So this is amphoteric. Right now we have seen. Other than that, the metal oxides which are having oxidation state of 5, 6 or 7 like this, they are acidic. For example, Mn2O7, 7 oxidation state, CrO3, this is red color, this is orange color, they are acidic. Now, metalloids, who are metalloids? Aishwarya Auntie G is selling tea. First of all, remember the metalloids. If you don't know metalloids, once again, Aishwarya Auntie G is selling tea. These are the metalloids. Aishwarya Auntie G is selling tea. So all metalloid oxides other than amphoteric. See, arsenics plus 3 oxidation state was amphoteric. Just see, arsenics plus 3 oxidation state, arsenic and antimony's plus 3 oxidation state was amphoteric, but their plus 5 oxidation state is being acidic because they're not amphoteric. So all metal oxides other than amphoteric, they are acidic. They are acidic oxides. And non-metal oxides, they are acidic oxides. So these many are acidic oxides, metals forming, metalloids forming non-metals. So metals also forms means acidic oxides in higher oxidation. Metalloids also form acidic oxide, and non-metals definitely they are going to form acidic oxide. Is it clear? Is it clear, kids? If yes, I'm going to move ahead. See the slides. CONO, these are neutral oxides and they are given in your NCERT. I will show you. They will neither act with acid nor they are going to act as base, nor with acid, neither with acid nor with base. The trick is No CO is laughing. This is laughing gas. N2O is known as laughing gas. So CO, you know, CO, company's CO. So no CO is laughing. Why? No CO is laughing. No CO, this is not cobalt, carbon monoxide, they are equal. No CO is laughing because neutral oxides have no acidic or basic properties. And that's why CO is not laughing. CO is not happy. CO is not laughing. No CO is laughing because they are neutral oxides. They cannot react acids or they cannot react with bases. They are not able to react. They are inert. They haven't got the right to react. Now see, this is given over here. See, this is NCRT. I've taken the pick for you kids. I've taken the pick from the NCRT and then I have done the zoom in and then see CO, NO, N2O are amphoteric oxides. No, CO, NO and N2O are neutral oxides, and neutral oxides have no acidic or basic properties. Neutral, CO, NO, N2O, amphoteric oxide. They are writing because above it they have written Al2O3, As2O3 about amphoteric. See, so they are writing neutral oxides have no acidic or basic properties, but amphoteric oxide behave acidic as well as bases. Let me have a glass of water. Otherwise, kids, can you see kids? Can you see kids? See, at 11 I will give you break. At 11 kids. Now see kids. Now, metal basic oxide. Less oxidation state, they are basic. Generally +4 and acidic. I've told you 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Higher oxidation, they are acidic. Lower oxidation state, base. Otherwise, they are amphoteric. Amphoteric. Now, this is given. This slide I have given you as the notes. Seek best notes. You are going to get anywhere these notes? Nowhere. You can see and you will be able to do because reasons I have told you. I have explained each and everything. Now see kids. Right hand side acidic character increases. Sodium, mangal, phosphorus, SO3. For oxides of same element, acidic strength does not assure acidic strength is directly proportional to number of this oxygen is missing, number of oxygen atoms, number of oxygen atoms divided by number of central atom. Just see, if I say central atom is 1, 2, 3. Now how to calculate? Just see, if I write 2 oxygen atom 2 by 1 is coming 2, 3 by 2 is coming 1.5 and 1 by 1 is coming 1. So who is going to be most acidic? Acidic strength is directly proportional to number of atoms, oxygen atoms divided by number of central atom. The ratio is coming 2, 1.5, 1. So the acidic strength is increased. Here also the central atom is not same. So number of oxidation state is increasing. So the acidic strength is also increasing. Everyone, is it clear? I hope this is clear. Oh my God, what is this? Okay, now see kids. Left to right, H2CO3, H3PO4, H2SO4. You see the oxidation state. If you see, here it is +7, here it is 4 2s are 8, 6 plus 6, here it is 3 2s are 6, 3 plus 3, and now see. Top to bottom, you see number of oxygen got this is same H2, no, sulfur and selenium. So going downside, the basic strength increases and acidic strength decreases. I hope this is really very much clear to all of you. Now see, oxyacids. This is going to be really very, very important. Oxyacids. What do you mean by oxyacids? Let me tell you. Oxyacid meaning is, if I say this is phosphorus, this is double bond O, and this is OH, rest of the valencies. So this is the compulsory part for a compound to be known as oxyacid. This is having this much, then this is known as oxyacid. Why this is known as oxyacid? Let me tell you. If this proton is eliminating out, this oxygen will get negative charge, and once this negative charge is there, you can see what it is going to do. So if somebody is going to leave you, means going away from your life, and if you can live happily without that person, you will say, oh, you want to go, just go, ni poda, go away from here, get out. But if you can't live without that person, you will say, oh, please don't go, I can't live without you. So this oxygen said, oh, proton, if you want to go, just leave, I don't care. This negative charge will do resonance and I will feel better. I will do resonance, zoom, 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 zikak, zikak, resonance stabilized. So this conjugate base is stabilized by resonance, So it is not, this is delocalized. So this is stable conjugate base. So this is known as acid because its conjugate base is stable and acidic strength is directly proportional to stability of conjugate base. Acidic strength is directly proportional to stability of conjugate base. Is it clear to all of you kids? Stability of conjugate base. Is this clear to all of you kids? Now let me come back. Just see to it. Acidic strength is directly proportional to number of oxygen atoms. This thing I have told you, this thing I have explained. Now HClO, HClO2C, rest of the things are remaining constant. Only the thing which is getting changed, that is number of oxygen atoms, Cl1O, 2O, 3O, 4O, 1, 2O, 3O, 3O, 4O. But see here, H3PO4 is less acidic than H3PO3 is less acidic than H3PO2. How many of you want to understand it? Everywhere as the oxygen atoms were increasing, the acidic strength was increasing, but here 4 oxygen but less acidic, 3 oxygens, the one with only 2 oxygen atoms is being most acidic. How many of you want to understand? At 9, just after 15 minutes, I will give you the break. Just after 15 minutes. Just after 15 minutes, I will give you the. Now see, why is like that? Why? What's the reason of this? See kids, I've explained this. Now let me make one more table for this. Make it clear. Just see to it. This is P double bond O, OH, OH, OH. This is P double bond O, OH, OH, H. This is P double bond O, OH, H, H. Now see kids, 3 I have drawn. All 3 I have drawn. This is H3PO4. This is being H3PO3. This is being H3PO2. They can even give you their names. It's not necessary they are going to give a structure. We should know their names also. This is known as orthophosphoric acid. Higher oxidation state is ic acid, orthophosphorus acid. This is hypophosphorus acid, or you can say phosphinic acid. Very well known name, phosphinic acid. Phosphinic acid. Common name, nickname, and its name is phosphonic acid. Phosphonic acid, because they can give you these names also. Now see kids, this is having how many replaceable H? 1, 2, 3 replaceable H. It is having just 2 replaceable H, because this is directly attached to phosphorus, cannot leave. This is having only 1 replaceable H. Now the answer is lying over here only. Let me show you kids. If this is going to release its 3 hydrogens, it will look like this. See kids, P double bond O, O negative, O negative, O negative. Here P double bond O, O negative, O negative, H. Here P double bond O, O negative, H, H. Gets double bond is like doctor, and negative charge is suffering, is like patient. Just try to understand. Everyone try to understand. This is being doctor, and this is sufferer, is like patient. This is patient. One doctor, one patient. Then I will tell you the resonance. Here one doctor, two patients. Here one doctor and 3 patients. Which patient is feeling more happy? Although all the patients, they are not feeling happy because they are being sufferer. They are the patients. But then also, which patient is feeling more better? Which patient is feeling more better? If I say this is A patient, this is being B patient, and this is being C patient, which is in better condition? Do let me know kids fast. I want to see your answer. If you're not responding, yes, because full time this doctor is taking care of it. Full time this doctor is taking care of this oxygen, that is known as resonance, that equivalent resonance in between this 2 equivalent resonating structures you will get, because sometimes negative charge on this oxygen and some other time negative charge on this oxygen. So here you are going to get 2 equivalent resonating structures. Now see kids, in this, once this is doing resonance, then the charge is localized. When this is doing resonance, this charge is localized. In this, when this is doing resonance, these two are localized. When this is doing resonance, these two localized. So here less dispersal of charge, here more dispersal of charge. You can say the magnitude of charge is least. Once the magnitude of charge is least, then this conjugate base acid is being most acidic, and that's why this is being most acidic. I hope that everyone is able to understand. If yes, show me the thumbs up. Just after 10 minutes I will give you the break kids. If are you able to understand, do let me know kids that yes, you got it. Now see kids, just see the slide, the quality of slide. That this slide is really very important, very important. See kids, this slide is very important. This slide will change your brain, change your mind, my dear students. Now the kids, those who are thinking like negative charge is most stable on the most electronegative atom, your thinking process, thought process will change. The slide will change your thought process. Now see, negative charge is most stable on biggest atom. The first thing, size matters a lot. See, More than this is acidic. More than this is acidic. More than that acidic. And then Hi is most acidic, the most acidic and the least acidic, because iodine's size is maximum. The one who is being maximum in size, the negative charge on that atom is more delocalized. So negative charge is more stable on biggest atom. See, negative charge is more stable on more electronegative atom, but this is valid only when the size of central atom in a period remains same. When the size is constant, carbon, nitrogen, oxygen, fluorine, they all four belongs to the same period in the long form of modern periodic table. When the size of central atom is same, then the negative charge is most stable on the more or most electronegative atom. So this is valid. But when the size is not same, then the negative charge is most stable on the biggest atom. Everyone is able to understand? Everyone is able to understand? This is really the best concept I am giving you. So always remember, when the size is getting changed, first of all you have to see the size. First prime factor is the size. When the size is different, that means when they belong to different period, then negative charge is most stable on the biggest atom. Once the size is same of central atom, then negative charge is more stable on most electronegative atom. Now see, electronegativity factor is on second number, size factor is on number 1. See, this is the stability of conjugate base. Now, atomic radius. We have reached to the atomic radius, kids. Finally, we have reached to the atomic radius. Now, my dear students, let's have a talk for 1 to 2 minutes. Let me see, my dear students. First of all, I would like to say, really, you are dedicated, hardworking students. And I would like to say, there will be mistakes, there will be doubts, there will be obstacles, but with your hard work, there will be success. And you can do that, because if you are having ability to sit for how many hours past 11, 6 hours, 6 hours, so already you are there with me. Just 1 or 2 hours more, kids, not more than 2. I think I'm going to give the break. Right now, I'm going to give you the break, kids. Baba, I'm replying. Shiv Kumar, oh, no, I haven't forgotten anyone. Haven't forgotten anyone. Shiv Kumar, how can you forget you? Shukuna, Luke, Killer Science, Gokul. Now I can see, kids, I was busy in teaching, and you know that chats were running very fast, so I was unable to see the chats. Just the symbols I was able to see, my dear students. The chats was running way fast, so I was unable to see the chats, what is written over there, because I was focusing on teaching. Now, yeah, I can see you, kids. Your whatever you are writing in the chat, I can read also. Right now. Whatever you are writing in the chat, I can see very clearly. Now, Mark Wala is there, South Sea is there. Now, kids, how many of you are there? How many of you are there who are studying for the first time with Baba HSP? How many of you are there who is studying for the first time with Baba HSP? Just show me. Write down me. Write down me. Srinath, I remember you. How can I forget you? Srinath, how can I forget you? I remember. So, are you liking my teaching? It's definitely, of course, you must be liking. That's why you are there. But have you seen anything new, kids? Have you seen anything new? Definitely, I will upload the PDF PDF will get shared to you, my dear students. I will take care of that. I will take care of each and everything, even the minute things. Don't worry. Swami Hassan. Yeah, I remember. I remember. Kids, I want to see the your some words that mind blowing. My slides are mind blowing, kids. These slides I made for you. Even when I was doing MTech, I was not giving that much importance for the my notes, but for you kids, your future matters a lot, and for your future, I have gone through these slides. I made mnemonics, new mnemonics in the English, because in English mnemonics were not there. I tried my level best. Oh my God, Laharika, thank you, thank you. Pranesh, I remember. No, I haven't had my dinner, because once if I am going to do the dinner and then I will feel sleepy. I won't be able to teach with this much of energy. Right now, I'm full on energy. Wow, thank you, Somni Hassan. Oh, very good, very good. Thank you, thank you, thank you. Thanks a lot, my dear friends. First of all, do let me know, if I give you 20 minutes break, will you come with the same josh, same energy? Thank you, Shabri, Vasan, Shivakumar, Aditya. Lots of love from Kerala, Ajma. Thank you, really thanks. Will you come with the same energy level? Duration of the class will be 1 hour, 1 or 1.5 hours. Means after that, after okay, not 30, maximum 20 minutes. Will you come with the same energy level, kids? Just do let me know. If I give you 20 minutes break, will you come with the same energy level, kids? Okay, okay. So I will start this atomic radius at 11.20. 11.20. Tomorrow is the practice session. Tomorrow not. Tomorrow at 10 o'clock, the free class is there on Unacademy platform. There is a free class at 10 a.m. in the morning. So there I will take your doubts. Any doubt is there. If you are unable to understand any concept, any question, I will take your all the queries, and that free class is free for everyone. That is on Unacademy platform as special session. That special session I've kept for you, and you will get the link. Link you will get just in this video only. Okay, the link is there. So my dear students, yes, if by chance anyone is going not able to get that link, you can see on the Unacademy platform, HSP Baba, and go the Unacademy channel, that platform, and you will get the class, right? So no, it's already scheduled. Surgeon, it's already scheduled. It can't get changed. It's 10. It's 10 a.m. in the morning, 10 to 11:30. Okay. What is the code? HSP10, HSP10, HSP10. So, okay, kids. Last slide. See, this is the last slide. Here the negative charge. Here the negative charge is most stable. So this is most stable. Here the negative charge is least stable. So this is the best base. It can easily accept proton. So let's meet at 11:20, right? Okay, my dear friends. So come with the same energy level. Let's meet at 11.20. Okay. So 20 minutes, short break. Namaskaram, greetings. Welcome once again to the HSPN world of chemistry. All my dear friends, so once again, Baba is feeling fresh. It's just looking like that I'm going to start this class. It's not looking like that long way. We have studied number of things. It's just looking like I have entered into the class. Now I will make a fresh beginning, a fresh start. Ready, kids? How's the Josh? Are you with full energy? Are you with full energy, kids? Is everyone with full energy, my dear friends? I want to see the chat section, the Josh. Because if the energy is less, we're not going to get that much in our head, that much is not going to get entered. Grasp more. We should be more energetic. Then only each and everything will directly go to our hippocampus. So I think everyone is ready. Now, atomic radius. Let's start with the atomic radius. Kids, do let me know. What about my specs? Those specs I've kept. These are also my specs only, my dear students. These are also my specs only. Now, have you ever seen tornado? Do you know the meaning of tornado? Oh my God. Baba Basim sir is there. Thalaiba is there. Still awake. Pranam. Younger brother. Pranam. Anna. I'm your Anna. Okay. So, Basim sir is there, everyone. Our Veera level Thalaiba, king of chemistry. Brother. Hey. Welcome, welcome. वालेकुम सलाम अस्सलाम वालेकुम जो बोले सो निहाल सत श्री अकाल वनक्कम वेलकम अभिवादनम ग्रेट हे Wasim sir is there. It's everyone. Do you remember those days when we were in Bangalore, kids? Ambika ma'am, Wasim sir, a captive sir, and all we were all together, you know. Now the team is huge, my dear friends. Once again, we'll come to the Chennai or Bangalore. We'll take sessions all together, my dear friends. Okay. So this is really greetings to Wasim sir. Friends are loving, missing, and cyclone. Yeah, tornado. Tornado is cyclone, kids. Can you measure, just like on the road, once the car is moving, you can see at what distance you can cross that car. If suppose the tornado, cyclone, Bavander is moving from the road, will you be able to move from the side of that tornado? Answer is no. Because the cyclone, tornado, they are having vehicle nature. They are not having sharp boundaries. Now, kids must be thinking, sir, you were supposed to tell us about the atomic radius. What happened to you? You started talking about tornado. Yeah, I'm coming to this point only, my dear friends. Because just reading books, reading notes are not going to give you knowledge. Once, if you start thinking by yourself, that tornado can't have sharp boundary. Just like that, my dear friends, when the nucleus is present and the boundary of atom is measured by the electron, and my dear friends, then my dear friends, there is no sharp boundary of an atom. Why? because from the nucleus, you just see the outermost electron, that is the boundary, but the outermost electron or rest of the electrons, they're not moving in a particular path. We will say, sir, that is the orbit. Orbit is okay, but orbit is the space around the nucleus which is made by electron, and electron is not particle, it is particle as well as wave, that is wavicle. That means it's not having sharp boundary, so atomic radius is very, very tough to be measured. Now see, let me show you whatever I'm telling you, kids, it's written over here. See, atomic radius, the distance of valence shell electron from nucleus is called radius. Is called at is nothing, is called it should be is called its is called its radius, called its, right? Now, it is very, very difficult to measure the atomic radius because the isolation of single atom is very difficult. All atoms are very, very tiny particles. They all live all together. You cannot find atom as a lone particle. One atom will never get. You're not going to get. Once if you're going to get, then also you can't measure. As I've told you, they are not having sharp boundary. Now, there is no well-defined boundary for the atom. At this point is clear, then you can understand why those things are there, what things we are going to do. Now see, kids, if this point is clear to each and everyone, now see, my dear friends, atomic radius, hence internuclear distance of associated entities is used. I will let you know what is this internuclear distance. Let me tell you over here only. Internuclear distance means what? See, if I draw one atom, this is the nucleus. If I draw another atom, this is the nucleus. Now, if I touch these two lines, from nucleus to nucleus, this distance from nucleus to nucleus, this distance is known as internuclear distance. This is being internuclear distance from nucleus to nucleus. Now, this is having some meaning. See, kids, now we are not going to take the distance of the nucleus to the outermost electron because that we cannot measure. But nucleus to nucleus distance can be measured very easily. Now see what we are going to do. We will divide it in two parts. We were interested in this only, so this is the radii, this is the radii, and all together this is the distance. This is the internuclear distance. So I can say radii is half of distance. Now it's very easy. Nuclei to nuclei, we can measure the distance. Naked eye, with the naked eye, we cannot measure because we cannot see the atom. But yeah, with the help of some techniques, we can measure this distance. Now divided by 2. So this internuclear distance is also known as bond length. This is known as the bond length. Suppose if I draw chlorine Cl2, so this is the bond length of chlorine. This means from nucleus to. I hope that everyone, this point is clear. Now let's move ahead. Half of the internuclear distance between two atoms in a homodiatomic, because this I have drawn homodiatomic means their electronegativity is same. If their electronegativity is not same, then there is another formula. I will let you know. But this is the easiest example which I have drawn, because to understand the basics, we should know each and everything, and we have to start from the very basics so that it should go in your brain. Yeah, same as diameter. Yeah, you're right. Wow, Monisha, you are absolutely getting, this is the diameter. Because two radii are going to make diameter. Fantastic, awesome. Now see, this is covalent radius. Now my dear friends, covalent, you know covalent bond, sharing is caring. By sharing of two atoms, they are going to make covalent bond. Now this atom has gone a little bit towards this atom. Now, if I say this diagram which I have drawn was right or wrong, this diagram was right or wrong, this is not for chlorine. This cannot be for chlorine. See, chlorine is going to make covalent bond. This example I should have given for manganese, metallic bond, because the boundaries were like this. So manganese and manganese, metallic bond. This can't be the covalent bond, because in covalent bonding, there is sharing. One atom's electrons will be attracted towards the nuclei of another atom. So see, there is difference. This is gone. So see, if it has gone toward this side, the distance got decreased. Definitely I will say one thing, that covalent radii is less than metallic radii. Means metallic radii is more than covalent radii. It's, do let me know, agreed? Is everyone agreed that I'm saying metallic radii? See, this was the metallic radii. This was just touching. This has not gone inside this, that has not gone inside this. This is the metallic radii which I have drawn. Metallic radii is more. This value will be more because this distance is more. Are you able to understand? Covalent radii will be less. Yeah, agreed. Very good. Now see kids, this is dA by 2, means this distance divided by 2. This is radii and sim form atomic molecule. Now see kids, if the covalent radius for heteroatomic molecule, generally the NTA is not going to ask question on this because the numerical will get lengthy, but God knows, if they are going to ask question, we should know, we should be prepared for it. Now see to it, everyone. If it is heteroatomic, that means one atom will be more electronegative and another atom will be less electronegative. So there will be partial negative and partial positive. Let us suppose this is cation, this is anion. Anion is bigger than cation generally. So they made bonding, but you know, this distance and this distance, they are not same. One more thing, when the homoatomic nucleus was there, the force of attraction was not that much. If one is cation, one is anion, means opposite charges love together. Cation will attract electrons, that is of anion, means polarization will be there, means the electron of anion will get polarized more towards cation and they will be more nearer. Now so see, once they are more nearer, the distance will get decreased. Otherwise, if it would have been both the same, then Ra plus Rb, because they would be same. But here the distance is less, so we have to subtract some value. Why we are subtracting some value? This should be very clear. That amount we can learn. We have to cram it. But why we are subtracting some value? The reason behind is that the distance got decreased. This distance got decreased because love in between opposite charges. That is the universal truth. So the distance got decreased. Distance decrease because of more attraction. Because of more attraction. So more attraction is there. So we have to subtract this value, this value. This, remember that this is in angstroms. This is given in picometer. The scientist Shoemaker and Stephenson's. Shoemaker and Stephenson's has given one relation, Ra plus Rb minus 0.09. And this is difference in the electronegativity, the one who is forming the bond, like HCl. H delta positive, Cl delta negative, HBr, H delta positive, Br delta negative, ICl, I delta positive, Cl delta negative. Are you getting my point? So radius of A, radius of B minus 0.09 delta X, if it is given in angstrom and if it is given in picometer, then only 9 you have to subtract, and delta S is the electron. Now, my dear student, you must be thinking what type of numerical can be asked. You must be thinking what type of numerical can be asked. So let me show you the numerical based on this. But first of all, R cation, RNine, RA, RB minus 0.09 if you're going to solve in angstrom, otherwise minus 9. You want to solve it picometer. Now see, here is the question. No need to solve it because we should know how to solve it. I don't think that examiner is going to give it because lengthy calculation is there, but we should know the process. If they are going to give you the easy values, then the question is going to be easy question and you can do it. Now see, they have given RH is 0.754 angstrom. Distance in between chlorine and chlorine is 198. That means simply radii is given in picometer. We can convert into angstrom because the radii will be half of this. Half of 198 is, half of 200 is how much? 100. So half of 198 should be, very well. Now, my dear students, this is indicating that this radii is also given, this radii is also given, this radii is given in angstrom, and this radii is given in picometers. So either you convert it into picometer or both the values you can convert into angstrom. Are you getting my point? That's why this twist they have given. Now, the electronegativity of H is this and this is this. So difference you got it 3 minus 2.1. Definitely 0.9 is the electronegative difference. Then find out DHSL. Now DHSHCl, this is the bonding between electropositive and electronegative, means this is the case of heteroatomic molecule. Can you see? This is the case of heteroatomic molecule. We cannot apply homoatomic because HCl is heteroatomic, H delta positive, Cl delta negative. Now see how to do it. I've solved it for just to save time. I've created this slide. First of all, do let me know duration. Now don't worry, power cut is there. Don't worry, not lengthy class. Once take me atomic radius, after this ionization energy, electron affinity, and ionization enthalpy, electron gain enthalpy, and electronegativity. Electronegativity is very, very simple. Ionization energy and electron affinity will take some time. Okay, so don't worry. See, the difference 3.21 is 0.9. I've told you R of Cl is this divided by 2, 198 divided by 2, 99 picometer. Now picometer, deci, centi, milli, micro, nano, pico, femtoauto, deca, hecta, kilo, mega, giga, tera, peta, exa. So pico is 10 raised to power minus 12 meter and angstrom is 10 raised to power minus 10. Angstrom is better than 100 times better. So its value will get decreased by 100. Just divide it by 100, you will get an angstrom. This thing, if you know, simple things, these are given in class 6 standard. The numerical is never tough. Only two things are there. If you're making mistake, just convert the unit and just do the proper calculation and don't be scared of calculation. Now see, you got this value, you got this value, you got, so apply formula DHSL RH 0.74, it is already given. RCl 0.99, C 0.99 angstrom, this is also in angstrom, and 0.09 3.25, and here is the answer. My dear students, is it easy or not? Is it easy or not? Do let me know. It's I don't know the time. Everyone, you are asking about, yeah. Let me tell you, too much time is not there. If I'm going to give you this question to solve it, it will take too much time. It will take too much time, right? Just to save your time, the class has been started at 5. Number of students, they are not having charger, electricity. Okay, my dear students. First of all, show me the thumbs up, kids. I want to see your thumbs up. Solved. Very good. Luke Abrams, killer science. Fantastic. Once if you're able to understand, it's your moral duty to show me the thumbs up. That is a sign. That is the sign of that you are able to understand. Yeah, fantastic. Fantastic. I liked it. Now see van der Waals radius. It's, you know, London forces. If some atom is in Sweden and another atom is in India, they are far away. This generally happens in noble gases. One atom is there, one atom, like India is my country and all Indians are brothers and sisters, like that. So they are remaining far away. One atom is here, this atom is here. One is saying, hey dude, how are you? Just from 1 kilometer away, he is saying, hi, how are you? So see, too much distance is there. This is the nucleus, this is the nucleus. See, half of this is radii of van der Waals. So see, van der Waals radii, they are in noble gases like neon, argon, krypton, xenon, radon. Why they are making van der Waals radii? Now, kids must be thinking, sir, then why they are making bond? Why they are making bond? Let me show you. Let me show you why they are making bonds. Suppose if I say there is bromine, if I say there is bromine, Br2. So Br2 will be like this. Br2 will be like this, isn't it? This is Br, this is Br. Now bromine, they have reacted. This is Br. Br and Br. Br2. Their octet is complete. Now another Br2. Another Br2 is over here. Get see. If I say this is Br2, one more Br2 is there. Two Br2s are there. Their octet is also complete. Now you will say, sir, how to find out whether their octet is being complete or not? Let me tell you. Br is having 7 electrons in the outermost shell. Everyone knows 1, 2, 3, 4, 5, 6, 7. Br 1, 2, 3, 4, 5, 6, 7. Now they form the bond, covalent bond, and the octet has been completed. This is octet, 8 electrons. 8 electrons, both are happy. Here also 8 electrons, 8 electrons. Now, why this Br2 molecule is going to form a bond with this Br2 molecule? There is no force of attraction. Now the question arises, if this Br2 is happy, that Br2 is happy, then why they are attracted towards each other? This is the million-dollar question, isn't it, kids? This is the million-dollar question. Now see, kids, once this Br2 by chance, some force for just for fraction of seconds has been developed, this Br by chance disbalance is there, Br negative. Now this Br positive will create their negative and positive, but this force of attraction is very, very weak. Very, very weak force of attraction. So they will not come too much close to each other. So van der Waals radii is always maximum. So if anyone is going to ask who is having maximum radii, this is van der Waals, then yes, metallic, then covalent radii. This is the question. Van der Waals radii, then metallic radii. You see metallic radii, they are not overlapping. They are far away. This is the metallic radii. So see van der Waals radii, metallic radii, and then covalent radii. So maximum is van der Waals. Van der Waals radii is maximum, my dear friends. Then metallic radii, and then covalent radii. Is it clear to all of you, my dear friend? I hope this is very much clear to all of you, and this is the question. Number of times they have asked this question. Now this is clear to each and everyone. So atomic radii is inversely proportional to Z effective. Now my dear friends, I've told you Z effective. What is the meaning of Z effective? Z effective means the force of attraction by the nucleus on the outermost electron. This we have seen in the Slaters rule, Z effective, or you can say atomic radii inversely proportional, because more the force of attraction, less will be the atomic radius, means the outermost electron will be nearest to the nucleus and negative positive. More the number of electrons, more will be screening effect. Yes. So less will be the force of attraction by the nucleus on the outermost electron. So outermost electron will go far away from the nucleus. So the radii will decrease, the distance will decrease, and atomic radii will increase. Now see, what is common? N3 negative. If you can see, just see to it, 10 electrons, 10 electrons, 10 electrons, 10 electrons, 10 electrons, 10 electrons. This means they are isoelectronic species. Isoelectronic species. Am I right, kids? Everyone, can you apply your brain? What I'm telling you, just listening, or you applying your brain also? So I can say, in case of isoelectronic entities, the one who is having, yes, least protons, because isoelectronic species, they will be having same number of electron. Isoelectronic itself means having same number of electrons, having same number of electrons. Now kids, so you see it is having least proton, maximum electrons, least proton, maximum electron, maximum electrons. So maximum repulsion or more screening, so size will be more, because outermost electron, there is no control of nucleus on the outermost electron. I will not say there's no control, but there is very, very less control of nucleus on the outermost electron. So its Z effective is least. If Z effective is least, atomic radii will be maximum. Or you can see negative charge. You can't visualize Z effective immediately. If you are feeling difficulty in visualizing Z effective, you can see maximum is the negative charge. Maximum is the negative charge. And this is positive charge. You can see. And what happened? See, positive charge. This is having maximum positive charge. So atomic radii is least. I hope this is clear to each and everyone. Is it clear to each and everyone, kids? Do let me know. Everyone, are you able to understand it? Kids, now see. Factors affecting radius. Factors affecting atomic radius in a period. You know, as you move from left to right in the periodic table, what I have told you, by 0.65, generally the Z effective was increasing. If you remember, kids, I've given you the trick that on moving from left to right, 0.65, this is the digit, this is the number. I've told you that iron he man, right? So Z effective increases on moving from left to right. So this is increasing, atomic radius will decrease. So see, beryllium is having least Z effective, and as the Z effective is increasing, atomic size is decreasing. So which side can you see is having maximum? This is what? This is the value of atomic radii. You can see this is the value of atomic radii, and that side fluorine is having maximum Z effective, so least atomic radii. Now, my dear students, one thing you must be thinking, that beryllium is there, boron is there, carbon is there, nitrogen is there, fluorine is there. What happened to the neon? After fluorine, neon is there. My dear students, never say that at this place neon is there. Neon belongs to zero group, and zero group, they are going to form van der Waals radii. You remember van der Waals radii, so they are going to form van der Waals radii. So neon will be having maximum size due to van der Waals radii, that is the gas. Now atomic radius is directly proportional to number of cells. This is very simple. No one is going to ask. Why no one is going to ask? Even the kids, they know that more the number of shells, more far away will be the electron, and on going down the group, size increases. Cesium will be having maximum size. Better to say more than cesium, it's francium, but francium is being radioactive element. So I will say on moving from left to right, atomic radius generally decreases because zero group is having maximum, but on moving down the group, number of cells are increasing, so the atomic radius increases. My dear students, now see atomic radius: lithium, sodium, potassium, rubidium, cesium. So hidden Lena knows Ruby sees in France. Hydrogen, lithium, leave the hydrogen. Lithium, sodium, potassium, rubidium, cesium. It's increasing like this. Let me show you. This I have drawn for you. Kids, see. This is for you. Lithium, sodium, potassium, rubidium, cesium. Can you see the size? I have tried my level best by making these diagrams that you can visualize. Kids, are you able to see? Now, if you go from here, these see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, it's decreasing. But see, for neon, van der Waals radii, this much big is neon. Yes, Latharica, on moving down the group, size increases. On moving from left to right, it decreases. But see, neon is having maximum because it belongs to zero group. So never for zero group say that it will decrease. They are having van der Waals radii. See how is the diagram? How is being the diagram, kids? Do let me know. Now, kids, my dear friends, some kids are just doing publicity over here. Just they are, I don't know whether they are students or someone else. They are just talking about other coachings, my this sir, my that sir, and what you are doing over here. It's just focus on these slides. Your teacher has really done the hard work for you, and some kids are there, they are just doing the publicity of different coachings over here. They are not saying how good the slides are. Who is going to give you these best slides, best notes? See, kids, I have tried making these things. This is a simple thing, but it requires time, kids. No one is having time. I have not gone to the marriages. I left number of things. I made these slides for you. Who is going to make? See, you know that by seeing, by watching, you can memorize for a longer period of time. That's why I have tried. That's why I'm giving you these things. Who is going to do this much? This very simple to make circle, but who is going to do that? Now see, kids, this is the exception. The examiner will ask question from here. This is the place from where examiner is going to ask questions. See, this is D block for transition series. Science teacher, very crazy man, felt cold at night with cousin. If you remember this, do you remember? Science teacher, very crazy man, felt cold at night with cousin. Now see, this I made one quote. Just see, because I will tell you the reason also. But applying reasons, applying mind, you won't be able to give this accurate answer. So we will apply brain, we will apply this visualization effect, and then we are going to crack this question. See, this on y-axis I have drawn atomic size, and on x-axis I made atomic number. You can see atomic number from here, 21 to 30. 21 to 30. Now see, this is the size of a scandium. Now on moving from scandium, titanium, vanadium, chromium, science teacher, very crazy man. It's over here, man. Man is over here. Just see. If I draw If I draw, the man is somewhere over here. Just see, this is man. This is chromium. This is vanadium. It's decreasing. It is decreasing. Can you see? It's getting decreased. But you see, iron, cobalt, and nickel, they are having somewhat constant size. Just this, you have to keep it in your brain. In this way, you can keep it for a longer period of time in your brain, that felt cold in night. When somebody is feeling cold, just see this ship. When somebody is on cruise, they will go here to see, to watch number of things. Some will go over there. But during night, when they are feeling cold, felt cold in night, they will sleep. Just to sleep, you need something plain surface. See my visualization. Just to sleep, you need something plain surface. Felt cold in night, and they are sleeping. They are sleeping. Felt cold in night, and this is increasing. I'm going to explain it also. I will give you the explanation also. But only the explanation is not going to work. This is the best diagram which I have drawn for you to keep it in your brain, kids. The examiner will ask question from here, felt cold in night, and that's why they are sleeping. And that's why they are sleeping line. Others, they are slanting line, decreasing, increasing, but they are sleeping. You know, when you're sleeping, you are just sleeping state. Okay, now the time is how to explain it. What's the reason is behind it? See, in scandium, let me show you. Let me take one slide. Scandium, science teacher, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, this is constant, copper, zinc. Now see, if I say its atomic number is 21, 22, 23, 24, and see, if I reverse it, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. Now see, if I say this 2 is already 2, 4s2, it's 4s2, 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 like this. 2 is for 4s, 4s2, 4s2, 4s2. But if you see D, these electrons are in D. It's 3d1. In the D, only one electron is there. If one electron is there, too much repulsion is not there, but force of attraction is too much. Z effective. If I talk about Z effective, if you remember, Z effective was having abrupt values. In the D block, I have told you Z effective. I have shown you that table. Z effective was having abrupt values, and they are not increasing that much as in S and P block. In S and P block, for each element, it was increasing by 0.65. But in D, that was not like, even the Z effective was getting decreased also. Now, if I say D1, one electron, so Z effective is more. As the Z effective is increasing, because they are having poor shielding, 3d2, 3d3, 3d4, 3d5, up to here, Z effective got increased. From here to here, Z effective increased. Z effective increased. So the size decreased. Size decreased. This we have seen, see. This we have seen, that size is getting decreased. As the Z effective is increasing, size is Z effective increasing, size is decreasing. Now see, after this, now D is having how many electrons? Half filled stability, D5. This is not D5, chromium is not D4. This is an exceptional case. So it is also having, the chromium's configuration will be 3D5, 4S1, exceptional configuration, right? Now see kids, mosquitoes. I don't know from where have arrived. Now my dear students, after D5, this is having half filled stability. Both are having D5. They are having half filled stability. Half filled stability. After this, D6, D7, D8. Now, Z effective is, here also it is increasing. Now, the Z effective is increasing in these three elements. Z effective is saying your size has to get decreased. Z effective is saying I'm getting increased, size should get decreased, size is supposed to get decreased, size should, expectation, I'm saying expected. But the repulsion of electrons, repulsion of paired electrons, repulsion of paired electrons is saying that size should get increased. One factor is saying size should get decreased, and this factor, expected, is indicating that size should increase. That means Z effective is not that much increase, so the size should get decreased. One factor is Z effective is increasing, but that effect is not that much dominating, so that it can decrease the size of iron, cobalt and nickel, because repulsion of paired electrons are also increased. So one side repulsion is indicating size should get increased, and one side Z effective is saying size should get decreased, so it has become constant. Now in copper and zinc, you know, the repulsion is that much, that the repulsion got increased and Z effective is not that much increased. I will not say Z effective is not increased. Z effective is also increased, but repulsion is double, triple increased. That's why size has been increased. Now you can correlate this thing very clearly. Here the Z effective was increasing, size was decreasing. Here Z effective as well as paired electrons, repulsion was increasing, size has become constant. Now here, yes, definitely the repulsion has dominated over the Z effective, and that's why size increased. Clear to all of you kids? My dear students, did you like it kids? The explanation and the memory chart, at least show me some, it's already 12 past, and I will salute to these students, those who are really, now mosquitoes are also there from this studio, from where the mosquitoes have arrived, I don't know, and they are doing resonance everywhere. Even I cannot hit them. They are doing resonance. When I'm going to hit them, they are flying from here to there. I don't know from where the mosquitoes have arrived. So, okay, now this was the first exceptional case. Now, let's see another. Now, see kids, this I have explained. Now, lanthanoid contraction. Oh, this is the question number of times. Examiner's favorite question. Now, let me explain. First of all, see, then I'm going to explain kids. Just see to it. JDSS. Wow, that's really fantastic. Now see kids, science teacher very crazy man. If you remember this sky lace tesori half, Victory of Novita, chromium, molybdenum, tungsten, manganese, titanium, rhenium, iron, ruthenium, osmium, cobalt, rhodium, iridium, nickel, palladium, platinum, copper, silver, gold. If you remember, now, if you remember, then let me tell you these elements. This is 3D, fourth period, 4D, fifth period, and this is 5D, sixth period. Now, kids, those students who don't remember where was the lanthanoid, they won't be able to understand this. Just to understand this thing, you should know where the lanthanoid were present. If I say 3D, that means which period I am talking about? I'm talking about fourth period. If I say 4D, I'm talking about fifth period. The value of n is fifth. If I'm talking about 5D, I'm talking about sixth period. Kids, do let me know first of all in the chat section. Otherwise, this class is going to get waste. No use of this class while sitting in this class if you don't know where the lanthanoids were present. First of all, do let me know which period lanthanide was present. This is the period. I'm not asking for group. Let me till that time let me put their group, but I'm not asking for the group. Third, fourth, fifth, sixth, seventh, eighth group. This is one classification, 1B, 2B, and the another grouping can also be done like this also, that 3, another grouping 4, 5, 6, 7, 8, 9, 10, 11, 12. Both are being correct. So these are the periods. What I'm asking, which period the lanthanoids were present? If you don't know that, then you can go and sleep. I'm starting from the very basics. I've told you where the lanthanoids were present. Which? Sixth. Very good. Very good. Sixth period. That means here lanthanum. So here was cerium to lutetium. The 14 elements, cerium to lutetium, 14 elements were present. Lanthanoids were present. That means up to here it's safe. No lanthanoids are there. Now, why the lanthanoid contraction is there? I will tell you, I will explain the lanthanoid contraction. How many of you are interested in knowing lanthanoid contraction? Do let me know. Show me the thumbs up if you are interested in understanding lanthanoid contraction in detail. Detail means it will hardly take 5 to 10 minutes. That is detail. Not third period. No, Nanda. In third period, lanthanoids were not present. Lanthanoid starts from this sixth period. Actinides in seventh period. Okay, everyone is interested. Very good. The Josh is really very high. Now I'm going to explain lanthanoid contraction. Let us suppose, let me take any element from this, cerium to lutetium. Suppose I have selected lutetium, cerium to lutetium. Let us suppose I've taken 58 to 71. This 71 atomic number I have taken. I've taken this 71 atomic number. Now see, if I consider lutetium, now lutetium's atomic number is how much? 71. 71. That means how many protons will be there? Protons will be 71. Positive charge will be 71. In the nucleus, there will be 71 positive charge. Am I right, kids? Am I making sense? This is the nucleus. Let us suppose this is being the nucleus. This is present in sixth period. That means let me make first, second, third, fourth, fifth, sixth. Okay. Now definitely the sixth period, this is having 6s2. 6s2. Now number of electrons will be there. This is electron, this is electron. In S electron, this is also S electron. There will be 2s2, 2p6. There will be 3s2, 3p6, 3d10 will be there. There will be 4s2 and 4p6 and 5d. 5d. D will be filled. 5d or not filled? Filled or not? That is sixth. 1, 2, 3, 4, 5. This is okay. This is 4d. 4d. Now here will be 5s2, 5p6. Right? Now, it's the filling of electrons will take place here in F. That which F? 4F, 1, 2, 14 electrons. Now, my dear friends, if this F is not present, if F would not be there, then see these electrons. Let me tell you, these electrons are having force of repulsion. Electron, electron. This proton is putting force of attraction. This is the king. This is like king. And king is putting force of attraction on all the electrons. It is just putting force of attraction on all the electrons. This is, but every electron is doing the force of repulsion. So force of attraction is also there. Force of repulsion is also there. But first of all, let me understand. Are you getting it? Till now, everything is clear. Till now, everything is clear. My dear students, tell me till now everything is clear. If yes, then I will move ahead. Show me the thumbs up, because I'm just thinking of whether everyone is able to understand or not. If you're not able to understand, then what's the use of explaining? So I have to move all together by taking you along with me. I have to move ahead. And once the concept clarity is there, always try to show. Yes, thumbs up. Thumbs up, my dear friends. No, I haven't had my dinner. After this class, I will do my dinner, kids. Otherwise, I will not feel this much of energetic. To get energy, to remain energetic, I haven't done dinner. Yeah, but one apple. I've eaten an apple a day. It's talked away. So I have eaten one apple, my dear friend. Now, see kids. See everyone. Now, suppose if this F is not there, just see how was the F. I've shown you the shielding of F. Let me show you once again. Let me show you once again the shielding, how they are going to act. See kids. If I say this is, if I say this is S, this is S, S is having such type of holes, such type of holes. S is having such type of holes. And suppose you are fisherman, you are just going to take this net in the river and you are going to catch fishes. These are the holes. White ones are the holes. Okay. These are the holes. This is S type, S subshell. Now if I draw P subshell, it is having a little bit bigger holes. This is P. Now if I draw D, if I draw D, not D, D, if I draw D, it is having much bigger holes. D subshell. Now if I draw F, bigger, more diffused, If I draw F, see the holes, you will get shocked by seeing the holes. Now, my dear students, you can easily compare whose shielding is best. SPDF. These are the holes. White one are being the holes. All the fishes will cross this net. The F subshell can't have fish. Can you see kids? S is doing the best shielding, means it is absorbing, maximum absorbing the nuclear charge. Maximum charge, that is positive charge, is absorbed, and it is not letting the positive charge to reach up to the outermost electron. I will not say it is destroying the whole charge, but it is destroying maximum of the charge. So its shielding is best. Shielding is best. Now that's why if you talk about first period, second period, third period, there is no anomaly. There is no size contradiction, because up to third period there is no d orbital involved. Once d orbital is involved, it is having poor shielding. I have told you it is having poor shielding. Shielding means it cannot cancel the nuclear charge up to that extent, and F is really very, very poor screening or shielding. This I have explained in another way. Now see kids, once the nuclear force is going, now see, for each F electron, if I say there is 4F1, if I say 4F1, if electron is increasing in 4F1, then proton is also increasing. Whatever the protons are present, proton is increasing by 1. If I say 4F2, then proton once again increasing by 1. But the electron is getting filled in. This is not 4F here. It is not 4F. That is a fifth. So 4F will not be here. 4F will be here. 4F will be over here. 4F. But see kids, they are nearer to the nucleus. Not nearest, nearer to the nucleus, but they are diffused. This force of attraction is directly going. This force of attraction is directly going to what? It is going on the outermost electron, because they are not able to cancel out. The one proton, for each one increase in proton, the electron in F is also getting increased, but F is having poor shielding. F is not able to. So see, this is the king. Suppose this is somebody and he is fighting and he is going to kill that. These what to say, barriers, these fighters, they are not able to stop its positive charge. So this is like Ram is going to kill Ravan. So this arrow is going good, and these fighters, they are not able to cancel out this arrow, and this arrow will go over there or not. So it will catch it. This will come nearer to the nucleus. It will come nearer to the nucleus, because these 14 electrons, they are not able to neutralize this nucleus force. This nuclear force is going to attack on that, and this electron will come closer, and this outermost electron is coming closer, and this is known as lanthanoid contraction. I hope that you are able to understand that the force of attraction by the nucleus on the outermost electron increased up to that much increase, that the outermost electron is coming more closer towards the nucleus as expected value. As it was expected, it is more nearer to the nucleus. This is known as lanthanoid contraction, kids. And the actinoid contraction will be more, because whenever the actinoid is there, lanthanoid is already present. Kids, are you able to understand? Do let me know. Those who have got it, show me the thumbs up so that I can understand, kids. Really, I'm happy to see you. Your presence is the best present for me. Right now, it's 12:24. Just your presence means a lot to me. This is giving energy, my dear students. No need of food. You bio students, glycogen is going to supply energy to me. So, your presence means a lot to me. Very good, students. Very good. I can see the Josh is high. Now, see, due to this lanthanoid contraction, see, as we go down the group, I've told you in the S block, as we were going down the group in the alkali metal as well as alkaline earth metals, the number of shells were increasing, the size was increasing. Here also, see, before this, there is no lanthanoid, so size is increasing. Just see, kids. Scandium, more ytterbium, then more lanthanum, then more actinium. See, fourth period, then fifth period, then sixth period, then seventh period, the size is getting increased. But after this, because here are 14 elements, those of lanthanoid, titanium. Now see, here is no lanthanoid, so zirconium size is more. But due to lanthanoid, zirconium size is approximately equal to hafnium. If I talk about NCERT writes it is of 159 picometer. This is 160. This is 159. This is 160, means approximately equal. Now, as the number of shells increasing, they are saying the size should get increased, but lanthanoid contraction is saying size should get decreased. So the 4D and 5D, they are approximately equal. You can see expectation was that the 5D or the 6th period size should be more than that of the 5th period, and this is also in this, it's like that only. But after this, because lanthanoid, after this lanthanoid contraction, the size of 5th period and 6th period elements of the D lanthanoid, due to lanthanoid contraction, they are approximate. If you are able to understand, let me know, kids. Now, my dear students, you got it. Everyone, you got it. Now see, another exceptional case. See, this exception is, what's the reason of this exception? Just can you think for the reason for this exception? Let me show you where is boron, aluminum, then you can understand. See, let me show you. What's the position? Let me show you. This is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then gallium, germanium, arsenic, selenium, bromine, and krypton. Now, boron, aluminum, gallium, indium, thallium. Just see, after D block elements, this is D block elements, you can see. This is being D block elements. D block element. Just after D block elements, if I say which direct, just after D block, which group is there? Just touching, just the boundary line. This is free boron, aluminum, gallium, indium, thallium. But boron, aluminum, before this, nothing is there. But D is getting filled. D1, 2, D10, and you know that I say 4F and 5F shielding is very, very poor. But what will you say about D? The shielding or the screening of D is also poor, but not that much. But D is also having poor shielding, poor shielding. Now, and that's why you have seen that iron, cobalt and nickel size was approximately same. You have already seen that. Now see, this shielding is poor. That means that the nucleus is putting force on the electrons. So D will not be able to cancel out that much force of attraction on the nucleus, and the size will get decreased. That's why aluminium and gallium size is approximately same. It was supposed to get increased, but their size is approximately same. This you know very well. If you don't know, then you should know. And this is known as scandium contraction. This starting from scandium, just like lanthanoid starts from lanthanum, lanthanoid contraction, actinum, then actinide contraction, and D is getting filled from here. This is known as scandium contraction. Although the scandium contraction is not that much effective, but yeah, scandium contraction. Now, my dear students, due to this, on moving down the group, the size was supposed to get increased as the number of shells are getting increased, but due to scandium contraction, gallium size, the force of attraction by nucleus, that is Z effective, is more on gallium, and that's why aluminium and gallium size is approximately same, and that's over there, see kids. Boron and gallium was supposed to be having more size than aluminium. It is just back, or I will put this sign, they are approximately having same size. Otherwise, expected order was, everyone will say expected order was like this: boron, then aluminium, then gallium, then indium, then thallium. It should be like this. This is the expected, but this is wrong. This is wrong. Why? Because of here scandium contraction, and this is increasing it. Okay, boron, then gallium, aluminium, then indium, then thallium. Boron, aluminium, gallium, indium, thallium. This is okay. But here you have to take care. Here you have to take care. It's everyone is able to understand. Everyone is able to understand. Yeah, you see, the effect is that much, bit difference, not that much, slight difference is there, slight differences, slight difference, not that much of difference is there, slight difference is there. Is it clear to all of you, my dear student? Is it clear to all of you kids? Is it clear to all of you? That much increase is not there. Yeah, Nandra Kumari, yes, this difference is very small. This difference is very small. That's why I'm adding this size, because this difference is not that much, right? And this is opposite. What do you think? Expectation was gallium should be more in size, in spite of that it is less. It was supposed to be more. Now see, another exception. Yes, see, actinoid, the overall reasons: actinoid, then lanthanoid, then scandite contraction. These are the reasons which are changing the size. I hope that this much is clear to all of you. So let's move ionization energy. Let's move to ionization enthalpy. After ionization enthalpy, I will take some time for electron affinity, then electronegativity. So ionization energy is very, very important, my dear. Are you ready for this? Have a glass of water. Everyone, you can have a glass of water, then I can start. Just have a glass of water, because number of questions examiner will ask from ionization energy. Only I will take 40 minutes, not more than 40 minutes. It will, but I can tell you that I can't tell you the time, kids. You know, I haven't started the lecture by seeing the time. That was starting time was 5. I have started at 5. But how can I say I will take 40 minutes, 45 minutes? Can take 40 minutes, 50 minutes, like that. But kids, understanding and concept clearance, the clarity in the concept, that is much more important. So don't see the time, kids. I'm interested in explaining each and everything, kids. Avengers, conquer all strengths. Are you there, kids? See, now we are going to start energy. So see, just to study, energy is required. Just to teach, energy is required. You are going to charge your mobile, energy is required. All the things I'm talking about, endothermic process. Endothermic process. So the ionization enthalpy is the energy required. It is an endothermic process. So we have to talk about endothermic process. Oh, great. All Avengers, molecules, conquer batch, all dear students are there. Wow, that's fantastic, kids. That's really fantastic. That's really fantastic. And I'm liking this, kids. Now, kids, just see. There is one king. Let me take an example of which element? Say, let me take an example of chlorine. Chlorine, 17. 17. Just see 17. 287. 2 electrons. 8 electrons. 7 electrons, right? Now, you see, this is the positive charge. This is the king. King is loving. King is loving. These are this is like king. This is like king, and these are like ranis. All they are being like ranis, queens, queens. So king is loving all their queens. But in between Rani and Rani, there is force of repulsion. Force of repulsion. And between king and Rani, there is force of attraction. This is common thing. This is very common. Now somebody came from outside, some another king. This is king number 1. This is being the king number 1. And this king is having 17 ranis. 17 ranis. Now what happened, my dear friends? One day, another king arrived. One day, another king arrived. One day, another king arrived. And this king, number 2, let us suppose if I say this is H plus. This is without any Rani. This king is not having any Rani. This is without Rani. It is having 1 proton and no electron. So this attacked on this kingdom, and this is saying, oh, I will steal, not the steal, I will kidnap your Rani. It's not the particle, so we cannot use the word steal. Not the particle, so we cannot use the word steal. This, just a second, kids. Okay, just a second. The bond has broken. Let me fix it. Bond has been broken of van der Waals forces, weak van der Waals forces. This was ionic bond. Let me put it here. Okay. Now, am I perfectly audible, kids? Can you hear me? Am I perfectly audible, kids? Can you hear me? My voice is clear, my dear students. Am I audible? Okay. Thank you. Thank you for your response. Now, see, this is another king. This is king number 2. And this is just trying to kidnap one queen. Now, this king is also putting force of attraction, and that king is also putting force of attraction. You must have seen one movie. There was Padmini queen. Queen's name was Padmini, and there was Alauddin Khilji. So this is like Alauddin Khilji, and this is Padmini, and this is the husband of this queen. This is putting force of attraction towards itself side, and that king is putting force of attraction toward that side, and that is saying, I will kidnap this queen. Now, my dear friends, this king has to supply energy, or without energy, he is going to kidnap this queen. It's Padmavati. Yeah, Padmavati. Yeah, you know, your history is very good, kids. It's your history is really awesome. Now, see, kids, this this king has to supply energy or not. This king has to supply energy to eliminate out this electron. That means it has to provide. Now, whatever the energy is required, at least that energy he has to spend. If this king is supplying less than that energy, the queen will not go out, because this queen is attracted by this nucleus. So this king has to supply at least some amount of energy. This another cationic portion has to supply some amount of energy to eliminate this electron, and this all happens in the gaseous state. So how to define, kids? How to define ionization energy? Let me tell you, kids. Let me explain it. Ionization energy ionization energy, because direct question will come on the definition also. You should know definition. Ionization energy is the minimum amount of energy, minimum. Why I am writing minimum? Suppose if you want to buy one pizza and the cost of pizza is 100 rupees, then what amount of money you would take from your parents? First of all, do let me know. If the pizza, if I say, if the pizza is of, if the price means pizza is of 100 rupees, what amount of money do you require to buy this pizza? Just to let me know what amount of money, what amount of money is required to buy this pizza? Do let me know, my dear friends. Everyone, this is my question. This is my question. Answer it. Then only you can understand any science thing. Let's see. Some people are writing 500, some are writing 100. Only one student has given the correct answer, that is JSD, at least 100 rupees. The answer is at least 100 rupees. At least. This is the answer, my dear students. At least 100 rupees. This is the minimum amount. At least 100 rupees. This is the correct answer. Because if you are having 101 rupees, 110 rupees, 500 rupees, lakh rupees, crore rupees, million, billion, trillion, await those number of rupees, you can buy that pizza. But at least 100 rupees are required, because less than that, it would not work. You want to buy pizza, at least 100 rupees are required. Yes, very good. So you should know. So that's why I'm telling you, kids, the ionization energy is the minimum amount of energy, is the minimum point to be noted by my lord. The minimum amount of energy required, required means endothermic process. You should know an endothermic process. An endothermic process is the minimum amount of energy required to remove one electron. Now, my dear friend, is it possible, do let me know, is it possible that this king can try on these electrons? Is it possible that anyone can take electrons from the inner shell? Never. If number of people are in house, if somebody is going to attack, they will attack on the outermost room. They can't enter inside because they have to fight. So electron is always going from the outermost orbit, always from the outermost orbit. So let me define what I was saying. Is required to remove one electron from the outermost shell. From the which shell? From the, because each and every word is important. They will ask you questions. Each and every word is important. From the outermost shell. Now kids, if there is fight, if number of people are there and you want to fight with one guy, others will definitely attack on you. So it's not possible to fight. So everyone used to say, just come one, let's have a fight 1-to-1, 1-to-1. Then we will show you how much energy level is of yours. So required to remove an electron from the outermost shell of an isolated, means it should be alone, of an isolated gaseous, should not be in solid state, liquid state, no, neither in combined state nor in solid or liquid state. It should be in gaseous state, of an isolated gaseous atom. One more thing, you have seen the soldiers, if they are full of energy, then it's not easy to fight with them. They are sleeping. If they are in their ground state, anyone can go and fight with them because they are in their ground state. So isolated gaseous atom in its ground state, this is known as ionization energy. Kids, can you see the board? Can you understand each and every word of it? It should be isolated. This is examiner's favorite question. Minimum, isolated, gaseous, ground state. He will ask you outermost, true or false, and these are the points where he will definitely feel interested. He's going to show his or her interest in asking question. Now, this much thing, if we are able to understand, ionization enthalpy, this is something regarded with thermodynamics. So I will say ionization enthalpy is delta H positive. Delta H should be positive. Endothermic process. Energy has to be supplied. Now see, my dear students, if somebody has removed one electron, right? But I'm not going to remove two electrons. First, let's see one electron, and then I will let you know about two electrons. Suppose if I'm going to write, let me show you one table. Just try to understand why it is like that. Where is that table? See, is anything you are able to understand? This is atomic number and this is ionization energy. For example, if I say this is lithium, lithium is having 520 ionization energy, then beryllium is having more, then there is dip and it's continuously increasing. Neon is having 2080 kilojoule per mole. Just we have to apply brain. Then I will teach you. This is my main motto, and this pic I have taken, I took it from NCERT, and I have to explain it, kids, to you. Now, kids, just to understand it, we should know number of factors. Are you ready to understand the factors? Right now, you can't understand anything. So, is everyone ready to understand this table and to understand this figure diagram of NCERT? We have to have adequate knowledge. Are you ready, everyone? So, let's go back and I will come to this point one by one by telling you each and everything. Now, see, first of all, before coming to the successive, let me tell you ionization enthalpy, the factors which are responsible for ionization energy, see to it. Let me tell you, then I will show you the slides. First of all, let me give you the notes from my side. Then I will explain it. Okay, my dear students? So, where it's gone, we were at this point, then I've told you about this. This also have explained this. I was here. Okay, I was over here, kids. Now see, kids. If I say there is sodium, 11 atomic number, 281. In the outermost shell, only one electron is there. If somebody is going to supply energy, if somebody is applying energy, now in the outermost shell, only one electron is there. Everyone wants to complete its octet. So what is easy for sodium? To donate one electron to complete its octet, or to gain 7 electrons. Donation of 1 electron is easy, or gain of 7 electrons is easy. Which job is easy, kids? Do let me know. The A1 is easy or the B1 is easy, and why this has to do these two things. So either of these two things, to complete its octet, to have 8 electrons in the valence shell. Which thing is easy? Donation of 1 electron is easy, or gain of 7 electrons is easy. What is easy? A is easier. This is easier. So sodium, while gaining some energy, that is known as ionization enthalpy, sodium from 281 gaseous state isolated will convert into Na plus gaseous, that is 28. Its octet got completed and it has donated 1 electron. It has donated 1 electron. Now it has got noble gas configuration. You must have studied that even the coordination chemistry, if you see coordination chemistry, the central metal atoms, they were forming bonds with the ligands to have noble gas configuration like 1836 electronic configuration. So they are also, these are the atoms, they are not having molecular part, just they will donate 1 electron, but they need some energy for donation of electron. Now sodium has donated 1 electron and it has gained the octet complete. Now if I talk about magnesium, magnesium is having 2 electrons. Just see, let me tell you kids, let me tell you, if I talk about magnesium, then the position of magnesium is like this. Its atomic number is 12, 1s2, 2s2, 2p6, 3s2. If you are having knowledge of s orbital, then the s orbital is like this and it is having 2 electrons, and this is fully filled, fully filled, fully filled configuration. One thing is fully filled configuration. Second thing is that these 2 electrons are present in s orbital. The penetration of s is too much, that s is closer to the nucleus. If I say s, 4s, 4p, 4d, 4f, who is more closer to the nucleus? S. More is the S character. That's why we always say S character. S is always nearest to the nucleus. So one thing is fully filled, and the second factor is the penetration of S is more than P and D. Penetration of S is greater than P. So penetration means this is more penetrated towards the nucleus. This is more close to the nucleus. That means the Z effective of nucleus is maximum on S. So its ionization energy is more S than expected, because you have to remove 1 electron from the fully filled, as well as penetration of S is greater than P. That means it is having more penetration. So kids, whatever is expected, its ionization energy is higher, even higher than aluminium. What you have studied in class 10th, let me show you. When I was in class 10th, teacher was teaching like this. As we go from left to right in the periodic table, let me talk about when I was in class 10th standard, when I was in 10th standard, my teacher told me on moving from left to right, ionization energy increases. Ionization enthalpy increases. My teacher told me, and going down, the ionization energy decreases. My teacher told me like this. My teacher told me like this. It's here decreases, here increases. But when I have entered into class 11th, what they started saying, no. There was word generally. There was one word generally. Oh my God. It is just like that. You always speak truth. If anyone is saying, generally, I always speak truth, that means, hey, something is fishy, something is fishy. And here also, generally. Now, that's why maximum people, they talk like generally. That means nothing is fixed. We have to apply brain. So as the level of studies is increasing, we have to go more into it. More in-depth knowledge is required. Now see, what is the accurate thing? Let me tell you. It is like this. If I write down lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then let me write down their groups also. This is 1, 2, 3, 4, 5, 6, 7 halogen and 0 group. So as we are moving from left to right, this is okay. But if I write arrow like this will be wrong. This beryllium is having more ionization energy than boron as well as lithium, because if I say this is second period, then this is having 2s2, and that is fully filled configuration, one thing, and the penetration power is more. So I will say it is being 1s1, sorry, 2s1, this is being 2s1, 2s2, this is 2s2, 2p1. Carbon is, so it will be having more, carbon will be having more, nitrogen is having more than this as well as more than this. Once again, nitrogen is having more than oxygen as well as then carbon, then fluorine, then neon, like this. Now see kids, why it is like this? I will say 2s2, 2p2, but here if you see 2s2 and 2p3, although P is having half filled configuration. Now you will say, sir, if P is having half filled configuration, then why it is not more than that of this beryllium? Now see kids, as you move from left to right, there is one thing that is known as Z effective. That is also increasing, and Z effective of this nitrogen is that much. The Z effective of nitrogen has got increased, because in S&P I've told you the Z effective increases by 0.65. If you remember, the Z effective for each increase in proton, Z effective in S&P increases by 0.65. This is going to increase like this. So the Z effective is increasing, and that's why this nitrogen is having more than that of beryllium. Now, oxygen, fluorine, neon. Now, if you see about neon, this is having 2s2 and 2p6 fully filled configuration as well as noble gas configuration. So that's why it is having 2080 kilojoule per mole ionization energy, and that is being maximum in this respective period. So where you have to take precaution, the half filled configuration, the fully filled configuration, Z effective and penetration, how many factors you have come across? One is Z effective. We have seen from the starting, Z effective will always play a role. Whether you talk about electronegativity, Z effective directly proportional. Electron affinity, Z effective generally directly proportional. Ionization energy, Z effective is directly proportional. Size inversely proportional. So Z effective is the whole sole criteria I've told you in the starting only, my dear friend. Now this thing you are able to understand. Same is like the sodium magnesium. If I talk about, same will be for sodium magnesium. See, sodium mangal sips chilled argon. Sodium mangal sips chilled argon. Now if I write down Just it is below than beryllium. I've written beryllium. No, beryllium was not here. There was lithium. Lithium, it's like lithium, beryllium, boron, carbon, silicon, germanium. Not silicon, germanium. What happened? After carbon, there is nitrogen, then oxygen, then fluorine, then neon. What I've told you, this was in this was in this was in first, second, third, fourth, fifth, sixth, seventh, zero group. And I've told you, my dear students, what I've told you, this beryllium was having more than both. So here also more than both. So it was increasing like this, but nitrogen was having more than that. So it is also having more than that, moving like in the same way, in the same way, in the same way, same way. Can you understand? These are having maximum, and down the group it is decreasing. This is having maximum, like in their respective period they are having maximum, but otherwise neon is having maximum. On going down the group, it's getting decreased. Kids, I was unable to see the chat. First of all, do let me know. Are you able to understand? Whatever I have told you in the air, I have given the notes. I prepared the slide. Don't worry. Z effective, directly proportional, penetration power, all these things. Whatever I was saying, I'm having the notes. So show me how's the energy level. It's 1. Already it's 1, kids. Just 20 minutes more, I will complete it. See, kids, I'm not seeing the time. I'm just interested in telling you each and everything. How the mosquitoes, they entered in my studio, I don't know. My kids, they are right now, they are biting me. What to say, kids? But they are making me active. If no mosquitoes would have been there, I must be feeling lazy, I must be feeling sleepy. So mosquitoes are also doing some great work. Now see, kids, I'm saying oxygen and nitrogen's ionization energy is more. But if I talk about, see, kids, if I talk about what is successive ionization energy, and then let me tell you, see, kids, if I say this is nitrogen, atomic number 7, 1s2, 2s2, 2p3, half filled configuration. If I talk about oxygen, 8, 1s2, 2s2, 2p4. Definitely nitrogen's ionization energy is more than that of oxygen. This ionization energy is, nothing is written, this is first ionization energy. But if anyone is saying the second ionization energy, that means what? That means what? If anyone is talking like this, there is N plus and O plus. Now, what is it? N plus. N plus means 6 electrons. O plus means 7 electrons. Now, for 6 electrons, what should I write? 1s2, 2s2. Now, 2p2. Now, for O plus, what should I write? 1s2, 2s2, and 2p3. Now, who is having half filled configuration? There it was having half filled configuration, half filled. But here this is having a half filled configuration. So for this I have to use second ionization energy, because they have already lost 1 electron. They all are in gaseous state, otherwise meaningless. All of them are in gaseous state. So could you please let me know who is having more? So I will say oxygen's ionization energy is more than that of nitrogen. That is ionization energy 2. Am I right, kids? Am I right? And this is too much more because it is having more number of, sorry, its electrons will be 8. Electrons will be 7, but atomic number will be 8. Atomic number will not change. Atomic number will not change. So this, the electrons have written, atomic number will not change. It's till now everyone is able to understand. First of all, do let me know. Is everyone able to understand till now, kids? Show me the thumbs up if everyone is able to understand till now, kids. Do let me know. If everyone is able to understand till now, show me the thumbs up, kids. I want to see thumbs up so that I can tell you some interesting things. Now see, kids, if I talk about successive ionization energy, what is the meaning of successive ionization energy? For example, there was one sodium. There was one sodium atom. Its atomic number was 8. In gaseous state, it is 281. You have given just less amount of energy and you have taken out one electron. You took one electron by just spending some amount of ionization energy and you got Na plus. Gaseous. Now sodium is very happy that yeah, I'm feeling good by losing electron, but no one wants to donate electron. Electrons are like money and atoms being human beings. So somebody has given energy, then only they have lost electron. Otherwise, no one is going to lose electron. Now, my dear students, once it has donated electron, its condition is like this. Now, if anyone is asking, hey, sodium plus, I want to snatch your one electron. Now, kids, is it possible? Is this process possible? Do let me know. Is this process feasible that it is going to donate one more electron? This is known as ionization energy 2, and this is known as successive ionization energy IE2. This is known as IE2, and that was known as IE1, IE1, IE2. Is this process possible, kids? Is this process easy, kids? Do let me know. Is this process possible, kids? What do you think? Is the second process is feasible? This was the A process, this was easy kill, but is this process possible? I want to see, kids, need not more energy. You are right, more energy, very, very high energy, because it is having noble gas configuration 2,8, and this is noble gas configuration. So this energy will be very, very high energy, very, very, very high energy, high amount will be required. Now, can I say there is too much difference, large gap in between IE1 and IE2? Can I say like this? Can I say there is too much difference? That means IE2 is too much than IE1. The gap is too much. The gap is too much. Too much gap is there. Too much. Large gap is there. It's, are you able to understand? Then I will compare. I will compare it with someone else. Can you understand? There it was happy to lose one electron. No one is happy while losing electron, but he said, okay, let it go, so that by losing one electron, I am getting some energy. No, I am getting some stability. If you are feeling hungry and you want to eat pizza, you have given 100 rupees. If it was available, if it would have been available for free, no one is going to spend money. No one is going to spend electron. But by spending 100 rupees, you got some energy. So you have donated 100 rupees, right? So sodium said, okay, just take my one electron. I'm getting energy. I'm getting stability of noble gas configuration. So let's donate one electron. But here it's saying, why to donate one electron? Already I'm having stability. Once you are in Ames Delhi, and some coaching person is saying, hey, come, let's take coaching from me. Will you take? Right now, you are spending your time, you are giving energy, money, charging because you are gaining stability. But once you have already in the aims and somebody is saying, hey, just attend my class, HSP Baba is calling you will not come because already you have got stability. But then also I'm saying, hey, just for sake of my this and that, I'm calling you again and again. Then you will say, okay, sir, I will come for some time. I will come for some time. It's like that. Now, let's take another example. This was the first story. Let me take another story of magnesium. See, there is one magnesium. Its atomic number is 12. The being gaseous, its electronic configuration is 282. And somebody has given energy. Now, it has become Mg plus gaseous. Donated one electron, although this energy was too much. Now, if I say already I'm having magnesium 1 plus, that is 281. If it is going to spend its electron, it will become Mg2 plus. Mg2 plus, then the configuration will be 288. 288, 281, 2810, 111, 11. Yeah, 28. 28. Now, this is noble gas configuration, noble gas configuration, and this is known as ionization energy 2, ionization enthalpy 2, and this is known as ionization enthalpy 1. What do you think? Which is less? The 1 is less or 2 is less? Which one is less? Could you please let me know, kids? I want to see you answer in the chat section. Which one is lesser? Kids, which one is lesser? Do let me know. Ionization energy 1 is lesser or 2 is lesser? Just think. Kids, don't say like this. Think, first think, then only. Kids, just think, just think. Only JDSS and Shishma, some other students are also there. My dear students, most of the students said this is lesser, and that's why I was focusing on this point. My dear students, just see, magnesium is having how many protons? Magnesium was having 12 protons. Here also magnesium is having 12 protons. The charge, the positive charge is getting increased. Number of electrons getting increased. What do you think? Z effective was directly proportional to what? Z effective was directly proportional to positive charge, inversely proportional to negative charge. Am I right, kids? Am I right? As the positive charge was increasing, Z effective was increasing, or you can visualize it. The king's power is remaining same. What was there, same over here. Here, the number of Ranis were 12, but here number of Ranis are 11. The force of repulsion got decreased. The screening got decreased. So the force of attraction on the outermost electron got increased. Or you can think like this. If there is mother and mother is having 2 kids, if one kid has been kidnapped, now what do you think? Mother is going to send another kid to the school. A mother is having 2 kids. Both were going to school. One kid got kidnapped. Now what do you think? The mother is going to send the other kid next day to the school? No. She will say, just sit at home. I can't they are going to provide extra precaution, because the affection, the possessiveness towards another kid will get increased. Am I right, kids? So this king has already lost one queen, Electron. Now the power of king, the proton's power, the effective nuclear charge is increased. So remember that whatever the configuration they are going to get, the successive energy will always be greater. Remember that this is more, ionization energy 2 will always be more than 1, 3 will be more than 2, that always increase, will never decrease, whatever the configuration anyone is going to get. So this is the point, this is more, and this is the point to be noted, my lord. Successive ionization energy means always, whatever the configuration, irrespective of the configuration, ionization 3 is more than ionization 2 will always more than ionization 1. And this is the fundamental thing, because the Z effective will increase. So the Z effective will say that ionization energy has to get increased. My dear students, are you able to understand? This is the meaning of successive ionization energy, that it's not possible like that. Otherwise, everyone, carbon must have lost 4 electrons to gain octet complete. Every element is going to lose or to gain 4 electrons. Then carbon should not have done the covalent bonding, the catenation. Either carbon must have lost 4 electrons or the carbon would have gained 4 electrons, and this is not possible. Are you getting my point? Is the point clear to all of you kids? So this is due to Z effective. This is due to Z effective always. Now see, let me give you one question on this, but before giving that, let me tell you the factors affecting in a period Z effective. In a period, Z effective generally increases, Z effective increases. So the ionization energy also, ionization enthalpy also increases, This point I've told you, already told you. So remember this, already I've explained, I've told you, I will give you a sheet, I will give you. Now see, in a period, a PD is not palladium, this is period. Stability of half filled and fully filled. This I've told you. Z effective I've told you. Half filled, fully filled also I've told you. So see that half filled and fully filled configuration already I've explained. Now see, this one also I've told you. The first ionization energy of nitrogen is more, but the second ionization energy of oxygen is more. I'm giving you the slides. I'm explaining it on the rough, and I'm providing the slide skits. How are the slides? First, do let me know. These slides are handwritten, kids. These are handwritten slides for you, kids. How many nights I was awake, how many days I was awake just to give you these slides, kids, handwritten without any error. No single error is there, because right now I am giving you in front of you, kids. At least show me the thumbs up, put the like, smash the like button, call your friends. Your Baba is still awake, and you are still awake. Hats off to you kids. You are still awake. Really awesome. Really. I'm saying from the internal core of my heart, if I've seen your this dedication, my dear students. You are really genius kids. Really loving kids. Lot of love, respect for your dedication, hard work, my dear students, regularity and the perseverance, my dear students. Really feeling good. Now see, this I was telling you, penetration power of subshells, S, then P, then D, then F. This is the HSP. You can remember H is silent, the penetration power. Who's close to you? HSP, SP, then D, then F. DNF are far away, DNF are too far away, DNF are duffers, like duffers, they are far away. So this is the penetration power. That's why beryllium's ionization energy is more than that of boron because it is having 2s2. Now, my dear students, this already I have explained. This is a slide. Now, see this. Beryllium is more than but boron plus. Now, why this is like this? Because boron plus will have fully filled configuration. Can you understand? Or it is required to explain? Just do let me know in the chat section. Are you able to understand this? Is everyone able to understand this? What I'm telling you, after losing one electron, the boron will get the configuration of beryllium because it will have fully filled s orbital and more z effective. Two factors will be there, z effective as well as fully filled configuration. Now, ionization energy is inversely proportional to atomic size. If the atomic size is more, means electron is far away from the nucleus. When the kid is far away, see why the kids are getting kidnapped from the school or from the picnic bus places, or you must have seen the kid is playing football in the ground and the ball has gone to the jungle. Now kid has gone to the jungle. Now he has not returned back because the kid has gone far away from the protection power. When somebody is going far away from the protection power, they will get kidnapped. It's like this only. And so this is happening over here. When the outermost electron is going far away, far away, far away, then it would be of someone else. Now see, this thing I have explained, lithium, boron and beryllium. Beryllium was having more than boron, and this is maximum of neutron. This is due to penetration power due to this half build. This I have explained on the plain page, rough page. Now you can see clearly these are the slides. When I was doing MTech in 2004, 2002, 2 to 4, I haven't made good notes for me myself, but I have prepared for you kids. You really mean a lot for me. Now just try to understand. Finally, we have reached. Just to explain this chart, I was telling you each and everything. Now try to understand. Lithium, beryllium. Now beryllium is having a little bit more than boron because of penetration power. It is 100 and 801. This is 899. 100 kilojoule per mole. It is measured in kilojoule per mole, EV, like that. So slight difference is there. Beryllium is having more than boron, then carbon. Now nitrogen and oxygen, just 100 difference of 100. Now see, lithium 520, add 400, then 500, then 600. You can get, see, lithium 500, add 400, 900, add 500, 1400, add 600, 2080. No need to cram the values, but I'm telling you just to explain this graph which is given in your NCERT. I took these many slides, but yes, I got success in explaining it. What, first of all, do let me know, is everyone able to understand this graph now? Let me move aside and do let me know, everyone. Is everyone able to understand this? If yes, then do let me know. Show me the thumbs up if yes. Now everyone is able to, if everyone is able to understand it. Very good, my dear students, very good. Now, see, this is the favorite question of examiners, exceptional case. And that's why you must have seen in quota factory, they're always talking about exceptions. They were not having this much of knowledge. Otherwise, they would not have talked about exceptions are there. We are not able to understand chemistry. They were talking like this only. Inorganic chemistry, pedicare, radu customer. But I would like to say, let's romba solver. See kids, The expected order is boron, aluminium, gallium, indium, thallium. But you know that this group is just lying after D block. And which element is lying after D block? This gallium, then indium, then thallium. How they are so normal? They're not going to be that normal because they have to do something. Now see, this is the observed order. Why this? Everyone is saying this is the supposed one expected. As we go down the group, the shells are increasing, the electrons are going far away from the nucleus, then definitely they would have taken less amount of energy. But this, now how to learn it? Because nothing I can explain that boron, then thallium. Thallium, you see, boron, aluminium, gallium, and thallium. Thallium is lying at the last. Lanthanoid, actinoid, number of contractions are there. So definitely gallium is having scandite contraction. Now my dear students, we have to cram it. Whatever the brain you are going to apply, you won't be able to do this question, and this is very, very important question. Now how to do it? See, BTL, battle, who has battled without taking any arms, and ammunitions, who has then done the battle, do let me know, who has then done the battle without any arms and ammunitions, without any harm to anyone else. Yes, hey kids, in the chat section I would like to see who has done the battle without any arms and ammunitions, without any hot talks, without any fight. Gandhi ji. Yes, Samria is there. Samria, welcome. Battle by Gandhi ji. Battle by Gandhi ji. All India likes. Battle by Gandhi ji. All Indians like. See kids, how's the trick? How's the trick? This trick right now I made. I was thinking of this. I have given 10 minutes to this. I was not able to make the trick, but right now in front of you, I am getting such type of positive waves that I made it. It's this time I'm getting such type of positive energy from you people because your hard work I can see, and right now I made it. Battle of Gandhiji, all Indians like. Ionization enthalpy. Battle of Gandhiji, all Indians like. Battle of Gandhiji, all Indians like. Now see kids. The application of ionization energy, you know that metallic and non-metallic character. Metallic is directly proportional to less ionization energy. Why? Metals are known for donating electrons. Metals are known for their tendency to donate electrons. So less energy if it is required, less is the energy required to remove electron. They can easily donate electron. They are known from the Khandan, the house of Tanvir Khan. They want to donate electrons. Sodium is having 1 electron, he wants to donate. Magnesium wants to donate 2, aluminum wants to donate 3, manganese want to donate 7 electrons, chromium want to donate maximum of 6 electrons. Anyways, so this is inversely proportional to ionization energy. That's simple. This is simple. Examiner will not ask reactivity of metals. If they are going to spend more electrons, definitely they will form more bonds. Just like in KMnO4, K positive MnO4, negative, single negative, then oxygen double bond, maximum bonds it is going to form. Definitely, it is going to be more reactive. It's very simple. Now, application. Stability of oxidation state. This is really tough, and thrice this question, this concept based question has been asked in your AIMS examination as well as JEE examination. So this time, reduced syllabus is there, so they can ask question based on this. Now see to it. If the difference, this is really tough, if the difference between two successive ionization energy of an element is same element, successive ionization energy is greater than or equal to 16 electron volt. What I'm saying, if the difference between two successive ionization enthalpy of an element, same elements, successive means same element, is equal to or greater than 16 electron volt, then it's LOS. LOS means low oxidation state, lower oxidation state. It's stable. For example, Na plus, Na2 plus, and this is value is given. I cannot write it down. This should be given. In the question, this value should be given 42.7. This is more than 16 electron volt. So which oxidation state of sodium will be more stable, plus or 2 plus? Definitely lower oxidation state. So this lower oxidation state is more stable, kids. Now see, if difference between two successive ionization energy of an element is less than or equal to 11 electron volt, then higher oxidation state is stable. Now see, this difference is 7.4, and the 7.4 electron volt is less than this, then higher oxidation state. That means this is more stable. So the value should be given over there, and we have to understand this is really going to be the best question. But for this, we should remember 16 and 11. 16 and 11. Okay, that you have to keep it in your brain. Now, see this question. Let's see, will you be able to do this question? This question was given in NEET examination. From there I have taken. Just try to do this question. Let's see how many of you will you be able to do it or not. Let's see, kids. Everyone. And don't worry, kids. After this, I will tell you electron affinity. It will take 10 minutes. Hardly it will take 10 minutes. And electronegativity, it will take 5 minutes. Means 15 to 20 minutes more than each and everything will get explained. Okay, my dear students? 15 to 20 minutes more. Just 15 to 20 minutes more, kids. Not more than that. So, what's your answer? What's your answer? What's your answer? Let me see, kids. Yeah, I will explain, but first of all, just apply your brain. Tell me the answer. Silicon. The ionization energy potential of IP1, IP2, I3, I4 of an element are given. So answer, how to do it, kids? You see, maximum differences, maximum jump. Can you see? Maximum jump is over here. 3 and 4. In between 3 and 4, maximum jump is there. Isn't it? 1, 2, 3. 1, 2, 3, 4, 5. Something is missing. 1, 2, 3, 4. Okay. Now see, kids. Is something missing, kids? Is something missing, kids? In the question, something is missing. Something is missing, kids. Is something missing? I think IP1, IP2, IP3, IP4, IP5 is missing, right? Missing or not, kids, do let me know first of all, because understanding of question is, yes, half done. Now see kids, definitely your answer is correct. That is, maximum jump is over there, and silicon belongs to carbon, silicon, germanium, tin, lead. That means silicon is having 4 electrons in the outermost shell. 1, 2, 1, you can remove 2, you can remove 3, you can remove 4, you can remove. Okay. Why these energies are given? Because if you are removing from 3 to 4, 3 to 4, yeah, if you remove 4, you will get noble gas configuration. Noble gas configuration you will get, and then it is not going to release electron, because after once getting noble gas configuration, too much high energy will be required. So I think your answer is absolutely correct. How many you got the correct answer? Show me the thumbs up. If your answer is correct, show me the thumbs up, kids. Those who have got correct answer, show me the thumbs up. Now, another question. Yes, second question, kids. Those who have got the correct answer, show me the thumbs up. Very good. Very good. Very good. Now, this question's answer. Let me know what is the answer of this question. What is the answer of this question, kids? Yes, my dear friends. This is fantastic, awesome question. I want to see what is the answer, my dear friends. Your Baba wants to see what is the correct answer and who is going to give the correct answer, kids. Hey, my dear friends, apply your brain. Apply, just apply your brain. Everyone, just apply. Kids, this time, apply your brain. Everyone, you need to apply your brain properly. Yeah, now you are correct. The answer is D. See, which of the following has first ionization potential greater than second? What I have told you, the successive ionization potential is always greater. This thing I have explained, the IE. I have explained or not? IE 3 will be greater than IE2 will be greater than IE1 will be greater than. The successive ionization potential will always be greater. So no, there is no element in this world whose successive ionization energy is not going to increase. It will increase. It will increase. Everyone, this question was really superb question. Superb question, kids. Really awesome question. Now, this question is from All India PMT 2009. Just see to it. All India PMT 2009. Try to get the answer. Let's see, kids. Yes, my dear friends. I'm waiting for your answer. What's your answer, kids? And those who got tired, my dear friends, if you got tired, you can see the replay. I'm not saying just for the views to sit. If you're not feeling that much energetic, you can go and sleep, kids. You can take rest. I have to I have to end it up. I have to teach each and everything. Hardly it will take 20 minutes, 15 to 20 minutes, but I will complete it, kids. I'm not saying that if you're not feeling energetic, you have to sit over here. You can take rest. C. Let's see whether your answer is right or wrong. Oh, yay! Yay! Hip hip hooray! You got it! You got it. Now see why. Among us, the elements which of the following electron configuration will have highest ionization energy? It's very simple. 3p3 half filled configuration. So everyone has got the correct answer. Now my dear students, let's move towards electron affinity. This is the time to tell you about electron affinity. See, tickets. So everyone is ready. Only electron affinity will take 15 minutes. Electronegativity is very simple. Electron affinity will take 15 minutes because I have to explain it in detail. It's not going to take too much time because electron ionization enthalpy you know very well. So electron affinity will not take too much time. Now see kids. Are you ready? Is everyone ready kids? Do let me know, is everyone ready? This is the correct term. Electron affinity, I will not use the word electron affinity. Actually, the actual term according to thermodynamics is electron gain enthalpy. This is the actual word kids. Thermodynamics says this is the actual word we have to use. Electron gain enthalpy. According to thermodynamics, electron affinity is nothing. Why thermodynamics says electron affinity is nothing? Because it is given in NCERT. First thing, let me tell you, because always you are studying electron affinity. Electron affinity is nothing, kids. That's nothing. Let me tell you. Electron gain enthalpy. Thermodynamics says this is the word, that is delta H. Now, if you compare with the thermodynamics and the relation between electron affinity and electron gain enthalpy, delta H, electron gain enthalpy is equal to, is there anyone? Because it is given in NCERT, is there anyone? Is there anyone who can tell me the relation in between electron gain enthalpy and electron affinity? Is there anyone? Is there anyone who can let me know what is the relation? So the relation is delta H electron affinity minus of this minus 5 by 2 RT. Just check it out in your NCERT. Whatever I have written is right or wrong, kids. Do let me know. If anyone is having NCERT, do let me know. Do you know this relation or you don't know? First of all, do let me know. This is electron gain enthalpy, that is electron affinity minus of 5 by 2 RT. If anyone is having NCERT, just check it out. So electron affinity is actually misleading word. This is nothing. So I'm not going to use this word electron affinity. So don't use this word electron affinity. Yeah, that's really correct. Thank you. So electron gain enthalpy is really the thing. And if I talk about electron gain enthalpy, we have to talk about when someone there the energy was required to remove electron, and this is related with the gaining electron. They were losing electron. Cations forming metals were forming cation. They were losing electron. They were becoming cations, and non-metals, they want to gain electron. They want to become anion. Then cation and anion will combine together to form ionic bond. Secrets. How to define electron gain enthalpy. How to define it. See. First C. Let me write down Cl. This is alone. Gaseous. Okay. Ground state configuration. Okay. It will accept one electron and it will become anion. Cl negative, gaseous. 288. Now, if you see properly, if you see to it properly, it is just looking like to me reverse of electron affinity. Anyways, this chlorine has gained one electron and acquired noble gas configuration. Some are acquiring noble gas configuration by donation of electron. Some are acquiring noble gas configuration by accepting electron, and this is the world. Somebody is losing money, somebody is gaining, somebody is losing electrons, somebody is gaining electrons. So this happens. This is the world, and this is the way how the business is happening. Now see, it has gained stability, that is noble gas configuration. Noble gas configuration. So if you see, the energy is released because bonding is taking place in between this atom and this electron. Bonding has taken place, and whenever the bonding takes place in between atom and electron, bonding is taking place. In ionization energy, the electron was getting away from the nucleus of an atom, and whenever the bond is broken up, when we are going to break the bond, energy is 99% cases energy is required to break the bond. Whenever the bond is getting formed, 99% energy will get released. Tickets. Bond is getting formed. I'm not saying in between any atom, but electron and atom. So energy will get released. Energy will get released, and all these things are indicating an exothermic process. Exothermic process. Exothermic process means delta H will be negative. So it is like this, but it should not always be negative. It will be positive also, and whenever it is going to be negative, positive, we require some in-depth knowledge. If everyone is ready, I will give you. Surveys is what, think of that. She didn't give up on her dreams till now. My God, surveys, how much you are writing. You're good in chatting. It's what you are doing. Just ask him what he is writing. Focus on study. This is 1:51 2 morning AM. In the AM, came back to California. Thor's PA has gone to Uranus, Neptune, Pluto. In the morning, in the AM, came back to California. Now Einstein has become famous due to Mendel's Nobel law, and what he is writing, what Charves is writing. Now kids, just see. Let me define electron gain enthalpy. So, because its definition is important, examiner can ask electron gain enthalpy. Just I'm writing over here, you have to think, you are thinking and I'm your brother, I'm writing over here. Don't sit like sir is writing and we will copy it, then we will make this and that. Once I'm writing over here, you have to apply your brain that what sir is writing. Electron gain enthalpy is defined as the amount of energy released when an extra electron when an extra electron is taken by an isolated gaseous atom in its ground state. Now just see kids, each and everything is covered. Definition means, definition always means each and everything should be there. You can write in your own words, but nothing should be missing. Each and everything should be present over there. My dear friends, today mosquito, they are just forming bond and they are making exothermic reactions. Uh, Alone joke. Let's end this only. This is the very, very important. Whatever I have promised, I have taught each and everything. Just this is the topic. Electronegativity will take hardly 3 to 4 minutes, 5 minutes. This is really very, very important. It holds a hell lot of weightage. So it's my humble request. It's my humble request. Please just give me 15 minutes. Even if you got tired, kids, see in my room mosquitoes have entered, but then also I'm fighting with them while teaching. I'm really fighting with them with the legs, with my hands sometimes, but haven't to stop teaching kids. Thank you. So nice of you, Alonjo. So nice of you, so nice of you. Now see kids. Now there is one thing. There's one thing. Let me tell you. Electron gain enthalpy. If I talk about fluorine, chlorine, bromine, iodine. Now see kids, these are the four elements who is maximum electronegative. This element is maximum electronegative. And this is less electronegative. Less electronegative. This I have to tell you each and everything because this is a question where you would have got number of times failed. Most of the students are getting failed. Now if I say electron gain enthalpy, negative electron gain enthalpy, I will use the word negative electron gain enthalpy of this is less, is having less value. This one is having negative word is required, negative electron gain enthalpy more. This is the actual term I have to use. Just try to decode it. Try to decode it. What is the difference? And if you want it to understand from my side, I will explain it. I will explain it. How many of you want to decode it from your side? And how many of you want it from my side? If you want, thank you, Srinath, thank you, Srinath, thank you. How many? If you want to be explained it from my side, show me the green, blue, whatever the hearts. Yes, I will understand that from my side. Okay, because this is the question all the time you kids are facing, you are struggling with this concept, and I'm going to tell you this concept in such a easy way that you will never forget. Thank you, YS. Thank you, kids. Thank you. Now see, kids, if I say, if I say there is one, there is one, just see what is this. Just try to tell me what is this. What is this? Elephant. This is an elephant. And this is one ant. This is one ant. This is elephant. And this is one ant. So see, kids, elephant is also having ant, and this is ant. Ant is very, very small. No need to write small. This is fluorine, and this is being chlorine. Size matters a lot. Just try to understand. One is ant, one is elephant. Elephant is bigger in size and ant is being smaller in size. This is simple thing. Now, ant is hungry. Ant is hungry, not eaten for the last 3 days. Not eaten anything for the last 3 days. Ant is hungry. Ant has not eaten anything for the last 3 days. For the last 3 days. Hungry. Even this has stopped working. Just let it cool down. So even the board is saying, smart screen is saying, oh, I need some time. Let's see. Now is it working? Oh yeah, now it started. So it is feeling hungry, not eaten for last 2 days. An elephant has done breakfast. Has done breakfast. Now, kids, who, and there is pizza. There is pizza. There is one pizza. Pizza. Now, kids, do let me know who is tempting more towards pizza. Tempting means who is having more eagerness to eat pizza, who is feeling more tendency towards pizza. Do let me know who is having more liking towards pizza. Liking, so definitely ant is having more liking, more liking, more liking towards pizza. This liking is electronegativity, liking towards electron. This is the electron. Pizza is the electron, kids, over here. Pizza is the electron over here, and this ant is having more liking. I'm not saying the one who is liking will have it. Having means something else, and liking means something else. Liking is something else, having it something else too. Now, ant is more liking. More liking means electronegativity. It is like electronegativity. More electronegativity, and this is having less liking means less electronegativity. Less electronegativity, kids. Let me tell you the values also. The fluorine's electronegativity value is 4.0 and chlorine's electronegativity is 3.00 approximately, you can consider. But see kids, when they will start eating pizza, who is going to eat more pizza? Who will eat more pizza? Once they will start eating pizza, the ant and elephant, who will eat more pizza, even though elephant is not having that much liking towards pizza, its electronegativity is less than fluorine, but once they are, elephant will eat more pizza, will consume more pizza. Are you getting my point? Will consume more pizza, will eat more pizza. This is electron eating is electron gain enthalpy. This is electron gain enthalpy because the size of elephant is more than that of ant. Once the ant is going to eat, whatever the ant is having in her stomach will start repelling. So is the case of fluorine. Fluorine is having maximum liking towards the electron, but the inner electrons, they are showing repulsion. They are not going to gain one extra electron so easily because the size of fluorine is very less. So the interatomic electrons, they show more and more repulsion to gain one extra electron. They will not easily gain that extra electron. That's why electron affinity of fluorine is more. I hope that everyone is able to understand. So in fluorine, there is inter-electronic repulsion is more, and that's why, my dear student, let me tell you, it's not only the case of chlorine. It's not only the case of chlorine. Let me tell you, if you see boron, carbon, nitrogen, oxygen, fluorine. I will not talk about right now about noble gases. I will come to that point. They are second period element, and second period element size is very less. They show anomalous behavior in their size, very small size. They have very small size. So if we compare these elements with the third period elements like boron, aluminium, carbon, silicon, let's leave this because they are metal. Let's not talk about them. Nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine. Then definitely I would like to say that chlorine's electron affinity, electron gain enthalpy is more, negative electron gain enthalpy, sulfur's more, phosphorus more, silicon's more. That means these elements are having, the second period elements are having more electron gain enthalpy in their respective groups because this is small, so this is winner. So their electron affinity is in increasing order in this way. So kids see their electron affinity is increasing in this order, increasing in this order. I'm not saying going down, but here second and third period I can compare. This is the comparison of electron enthalpy. In this way we can compare electron affinity. I hope that everyone is able to understand, my dear students. This point is getting clear to each and everyone. This point is clear to each and everyone. But never forget the sign. The negative electron gain enthalpy of chlorine. Along with the sign you should know. Now I'm not saying electron gain enthalpy. Just remember this word. What I'm saying, that negative, why this negative sign is there? Because electron gain enthalpy is an exothermic process. Negative electron This negative sign doesn't mean that energy is negative. Energy can never be negative. This is just indicating that energy has been released. Negative electron gain enthalpy of chlorine is more than negative electron gain enthalpy of fluorine. This is the correct statement. You can see, you can read your NCERT. You can check your NCERT. Now, my dear student, why I have left helium, neon, argon, krypton, xenon, radon? I'm coming to that. Before coming to that, let me tell you the second electron affinity. See, kids, if you want to add second electron, already one electron is there. See, if I say chlorine, negative is there, 2, 8, 8 is there. And if you want to give one more electron, now what chlorine will say? Once your stomach is full and somebody is saying, hey, eat this dosa, idli, rajma rice, will you eat? Will you eat? You're full on a stomach. You're full. Now, you will not show any temptation towards that food. And if he has to give you food, he has to supply some energy. He has to apply force. Now, my dear students, this, it's not a spontaneous process. It's not a spontaneous process. Now, then also if you want to supply, then it will become endothermic process. So, second electron gain enthalpy is always positive, is always, see these mosquitoes, is always positive. That means an endothermic process. You talk about any atom, you will say, sir, it is having noble gas configuration. That's why you're talking like this. No, my dear friends, if it would have been oxygen, that is not noble gas configuration, then also its second electron gain enthalpy will always be positive. Why this so? Because if any atom has accepted one electron, once it has accepted the electron, it will get negative charge. When it has gained negative charge, that means electrons are more, protons are less, then the Z effective will get decreased because the nucleus will not be able to apply that much force on the outermost electron because screening will increase, Slaters constant will get increased, Z effective will decrease, or directly you can apply Z effective was directly proportional to positive charge, inversely proportional to negative charge. If negative charge is getting increased, Z effective will. Is that clear to all of you? That second electron gain enthalpy for every element, definitely it has to be positive. Now, what I was talking about noble gas configuration, let me tell you noble gas configuration, what I was going to tell you gets noble gas configuration. Now see, these elements, if I talk about these elements, helium, neon, argon, krypton, xenon, radon. Have you seen their configuration? This is 2s2. This is 2s2, 2p6. 3s2, 3p6. And like this. Their octet is already complete. Do you think that they are in need of any electron? It's do let me know. Do you think these elements are in need of any electron? The answer is no, not at all. They are not in need of any electron. Their octet octet is already completed. They have complete octet. They have complete octet. Now, my dear students, if their octet is already been completed or they are having complete octet, they will not accept, they are not in a mood to accept any electron. Once you are going to any party, but you have eaten something before the party and you are full on stomach, you are not in a mood to eat, and if somebody is applying extra force, you must have seen the jijaji, means sister's husband, and sometime you must have seen sister-in-law saying, hey, have some more puri, and they have eaten, now they are going to vomit. Because forcefully you have given something to eat. Now, if anyone is going to say neon, if anyone is going to give one electron to this neon, now neon is not going to accept this electron, this proposal, he is not interested. Now, if then also you are interested, then you have to supply energy. That means for zero group, the electron gain enthalpy is even the first electron gain enthalpy. If I am writing electron gain enthalpy, that means first only electron gain enthalpy is positive, means you have to supply energy, otherwise they are not going to take electron. And same is the case with, exactly is the same case with second-day elements. Same is with second-day elements also. Same is with beryllium, magnesium. Same for beryllium, magnesium, calcium, strontium, barium, radium is radioactive. My dear students, can you find out the reason for this? The reason is that penetration power S is more, even though they are not having complete octet, but their penetration, one thing, they are being metals, they want to donate electron. So why they are going to accept electron? Second, the penetration of S is more and they are having fully filled configuration of S. So they are also having positive electron gain enthalpy. And this, I wanted to tell you about electron gain enthalpy. Now, I will take 5 minutes more just to teach electronegativity, and electronegativity is going to be the last topic of this periodic table, and this gets really just 5 minutes more. Really, I'm feeling very good that you kids are there. Now one student is writing Sushma Shingari, then why they participate in reaction? Let me tell you, Sushma, your question is really valid. Xenon forms a bond with PtCl6, ZePtF6 or ZeOPT, that at high temperature somebody has reacted fluorine with xenon. That reaction is not that easy. One is fluorine being highly electronegative, and second thing, at elevated temperature that reaction is possible. It's not that easy. So only xenon is going to form, not all the noble gas configuration. And that I will, oh, thank you, Lobasting, testing, thank you kids. You see, okay, let me tell you about electronegativity, then I will end this lecture. So I have covered, first thing, I'm very happy that I have gone through each and everything in detail. First of all, do let me know, everyone, kids, I've gone through each and everything in detail or not. I've given you what? The tricks, the logics, in-depth knowledge, slides, questions. What is missing, kids? Wow, thank you, JDSS. Thank you, kids. You have to share it. When you wake up in the morning, I don't know at what time you are going to wake up, but whenever you are going to wake up, you have to share it, because this video really is going to be viral, because tricks, awesome explanation, awesome slides, each and everything is really good. It's not good to appreciate ourselves, but it's when there is no one is there to appreciate you. Always when you wake up in the morning, say to yourself you are an important person, and then definitely you will start doing each and everything, even minute things, in the positive direction. So you should be the one who has to appreciate yourself, whom you have to beg for appreciation. You kids really are awesome. Otherwise, oh my God. Oh, Wasim sir is there. Kids, Wasim sir is there. Hey, kids. Baba Thalaiba is still awake. Hey, my dear friends. Wasim sir is here. My God, still awake. Oh my God. Salam, salam, sahab. Oh my God. It's really feeling very good. When Wasim sir is there, Wasim sir is even more energetic than me. Once what happened, let me tell you the thing. I was in Bangalore, and during the night we have gone to hospital because somebody met with an accident, and we returned back at, I think it was 3 or 4 o'clock. It was almost morning. Then we have taken just 2 3 hours sleep, and there was one marathon, and that marathon was of mine only, and that marathon was, the timing was, I think, 9:30 a.m. And I said, Wasim bhai, when you wake up in the morning, and even though if you're not having mood of getting wake up, please help me. So he was the first person who got awaked, woke up, and he helped me a lot, my dear students. Session was of mine, that marathon session, but he helped me a lot. So this is the energy level of Wasim circuits. So yeah, it's good morning. Oh my God, it's morning. It's morning, kids. It's morning. Really, it's morning. Wasim sir, just now 5 to 10 minutes are left. I have to tell them electronegative. Oh my God, Wasim Bhatt sir is writing love you, Baba. Oh my God, yeah. Wow, 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 kids. Wow, really, really awesome. Really awesome. Many Avengers are also here. Oh, that's really awesome. So nice. So nice, kids. That's really awesome. Nageshwar Roy is here. Hey. So call every Avengers, but Avengers must be sleeping. Most of the Avengers must be sleeping, kids. Because it's already 2:20. Oh my God. You both are awesome. Oh my God. Thanks a lot for your appreciating words. Really. And see, it's 2 a.m. 2 and means it's 20 past 2. And Wasim sir, I'm taking session, it's okay. But Wasim sir, he is still awake. Can you believe this, kids? Can you believe he is still awake? That's really awesome. That's really awesome. Something good, looking good, energetic, that I'm not the only one who's being awake over here. Wow, really, really, it's mind blowing. Mind blowing, kids, mind blowing. He is dedicated. Yeah, really, 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 really. Now, see, kids, Now the last thing, that is electronegativity. Electronegativity gets it will not take more than 5 minutes. Electronegativity. Now my dear students, first thing I would like to tell you that electronegativity of any element is not fixed. It is variable. It depends on the surrounding atoms, where it is located, where it is being added, with whom it is joined. So first thing, always remember in your brain that electronegativity is not fixed. It depends on the surrounding atoms. This is really very, very important thing, that electronegativity is not fixed. It depends. It depends. For example, if I say that this is carbon, this is also carbon, this is also carbon, kids. All three are being carbons, but see, its electronegativity is 2.5, this is 2.75, this is 3.25. Why this so, kids? Because you see, the hybridization, which is mathematical manipulation, even hybridization is nothing, but let's take right now, because time is too much. So this is SP. You can see here the percentage of S character is just 25%, 33 and 50%. So two things or three things, I will say they are related. What are these three things? If I say, kids, that percentage of S character is directly proportional to bond angle, and that is directly proportional to electronegativity of central atom. Now my dear students, this is okay, I've told you. Why I've started from here? I would have started from nitrogen, phosphorus, what are their electronegativity, but I have started from here because the first impression is always the last impression. So always we are going to teach, and when I write fluorine's electronegativity is 4.0, then that is going to fix over there that fluorine's electronegativity is always 4.0, but it's not like that. It all depends on the surrounding atoms. Now see, kids, it's just like that. If you see the movie, if somebody is terrorist, so all terrorists are not from by birth. They have not decided that I will become terrorist. These are the means circumstances. If somebody is guru, somebody is hero, all these are the circumstances, that what the circumstances that person has got, and what in which direction and what he has become. Suppose if Ramu is having 6 crore rupees and Ramu has decided that in Kedarnath I will donate 1 crore rupee. 1 crore rupee, Ramu is going to Kedarnath, and in meanwhile somebody has stolen 5 crore rupees. Now Ramu is having 1 crore and somebody has beaten Ramu and he has taken 1 crore also. Now Ramu is without money. Now what Ramu is going to do? Ramu now, it is in need of money. The person who was going to donate money now is asking for money. He wants money. So it's all the circumstances. If I say there is manganese, manganese wants to donate electron, but there is manganese 6 plus. There is a need of electron oxidizing agent. Manganese 2 plus is reducing agent. Are you getting my point? Now see kids. Now let me tell you kids. These are the elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now, how to find out their electronegativity? Just see my rule, my funda. We know that its electronegativity is 4.0. Nothing you have to do, just subtract 0.5. Just subtract 0.5. 0.5 you have to subtract. Now see, it will become 3.5. It will become 3. It will become 2.5. It will become 2. It will become 1.5 and it will become 1. It's so simple. No need to cram it. Cramming is not required. Just keep on subtracting. Now you will say, sir, what about sodium magnesium one? What we are going to do? Sai Nadu is saying there are no words to convey our gratitude. This means a lot for us. Think there is no other channel providing this much stuff to the student. Thank you, Sai Nadu. Thank you. Thank you from the internal core of my heart, because I've tried my level best to give you each and everything without skipping, with tricks, in-depth knowledge and everything. And thanks for understanding, Sai Nadu. You have to spread these words to each and everyone. So now, if I talk about sodium magnesium 1 like that, sodium, magnesium, aluminium, silicon, phosphorus, now chlorine, now some element. One element is missing. Which element is missing? Sodium mangal, S is missing. Steps, cold drink, right? Now we know that its electronegativity is 3. Now here you have to remember, first subtract 0.5, then it will become 2.5. It will become, oh, not working. Just wait for a few seconds. Thank you, JDSS. Just wait, because board is saying, oh, how long you have taken. So just give it second. 2.5. Yeah, it's working. Then subtract. This app subtracted 0.5. Now 0.4. Subtract just 0.4. How much it will come? 2.1. Now 0.3. 2.1 minus 0.3. 0.3. How much it will come? Kids, do let me know how much it will come. Everyone, do let me know. Subtract 2.1, 0.3. How much it will come? 2, 1.9, 1.8. 1.8. Yes, 1.8. Now once again subtract minus 3. How much it will come? 1.5. Once again subtract 0.3. 1.2. So this much only it's required, kids. This is very, very important. Kids, I hope that everyone is able to understand. Everyone got it, kids. Everyone got it, kids. So really, thanks a lot to each and everyone for forming this great bond, giving this much of respect. Thanks to Wasim sir also. for coming in the session to give this much of positive energy. And thanks to all persons, those who are working, see, at this moment of time also, they are still awake. We don't know their names, but number of persons just to make it possible, just to provide you this much of stuff, number of persons they are working, number of people are there, kids. So I would like to say thanks to each and everyone along with my dear students, my chemistry, chemical molecules, in HSP and family at this platform, my dear students. This is your Unacademy's NEET English platform. Whenever you get any friend, tell them that free of cost, we are giving this much of study steps. And tomorrow at 10 a.m. in the morning, I will take one class. It's already been scheduled. That is free special class on your Unacademy web platform. You know very well. That class is just to make all those points clear, which you're feeling any doubt, you're having any doubt, any question which I was unable to see in this chat. Because whenever we are taking class and number of students are there, the chat runs very fast, my dear students. So my dear students, take proper sleep. Whenever you get time, revise it, because revision is also very, very important. And once if you have gone through revision, then you can do anything, my dear students. So whatever we are having, just to make it possible, it should remain there in your brain. That is the most important thing which is required by these students. And I will pray to Almighty God to give you a good health, all prosperity, with the best rank in coming examination. And in this way, Almighty God should provide you stability for your parents as well. Good night. It's how much you liked it. In the morning when you wake up, please write down in the comment section. My dear students, right now I will not ask because I know how much tired you must be feeling. But whenever you get time, it's a humble request that you have to write down in the comment section, because these slides I made, I will keep on making such type of slides. If you are really liking, what thing you liked, what thing you haven't liked, if any negative comment is there, then also most welcome. I will try to improve, because the man, the person, the teacher who is always improving himself or herself, then only they can reach a one step higher. No one is perfect. No one can become perfect. No one can become ideal. We can just do improvement. And so I'm a simple teacher, but yes, I always want to improve myself day by day, every day. If even a single point I can improve, definitely a day will come, I will get lot of improvements, lot of good things in me, right? So good night, Shabba Khair, bye bye. We'll meet you. Already it's been morning, so already one new day has been started. Pranam. Dhanyabad Alu. Thank you, kids. Thank you. Thank you. Thank you.